then moved on yesterday to Ethics and Society Day, where we were contemplating how individual AI researchers, how organizations, and how people in the societal level could think about AI ethics progressively, pragmatically, and sort of make algorithms that were going to do good, or at least not do wrong. And today, in Applications Day, Applications and Entrepreneurship, we're going to be thinking about the use cases of AI. And in particular, we want to hear about the use cases for good. We're a non-profit, we have an educational mission, and I think all of us as AI researchers, entrepreneurs, otherwise, really want this technology to benefit the world. And we're going to hear from a range of really fantastic speakers. Today is a bit of a celebrity day. And so the first of those celebrities is Sadid Hassan, giving the opening keynote. Dr. Hassan is one of the AI leads at Microsoft, has been working on producing AI algorithms, but also using them to build new products, all the way integrated from apps to web browsers. And he came in at the last minute to give the keynote that OpenAI committed to and then never replied to emails about, which we really appreciate you doing. So if we could welcome Sadid to the stage. It's really wonderful to have you with us today. And who better to learn about AI from on Applications Day than someone that's been at such great companies and institutions as yourself. So thank you very much.
Thank you. Thanks for it. Thanks for it. Yeah, thanks for the invite. I'm really glad to be here today. So I think this is the third day, as you mentioned, right? So I'll try to combine everything that you have learned in the 3 days, hopefully. So from algorithms to, ethics, responsible AI, and also applications, because you need all of them to be in an application to make people use it, right? So it's really, that's the field that I'm trying to cover today through this talk. And I've been giving this keynote for a while, so I don't know if you have been in one of my past talks. But yeah, I hope I can share some new information, because the field is progressing so much that it's really hard to catch up. So yeah, so a little bit more about me. I'm Sadid Hassan. I've been in this field of AI for about 2 decades. Right now, I'm leading Office M365 Copilot development as part of Microsoft's Advanced AI Development and Acceleration Program. So my office is in Kendall Square, just a few miles from here. So, before that, I was an executive director of AI at CVS Health, and before that, I was AI lead of Philips Research North America, which is also across the river here. Yeah, so feel free to connect with me at LinkedIn. Happy to catch up afterwards. I guess I have only 20 minutes, right? Okay. All right. So generative AI is transforming, how we work, how we create and collaborate, right? So it's really transformational for everything that's going on right now. So in terms of applications, so there are many applications right now we can see in generative AI, right? So we have collaboration going on across different industries. As you know, Microsoft is a global company, so we have lots of applications, billions of users of our apps. But not only that, we collaborate with government, and some of the applications we worked with before was the GraphRag project. So I don't know if you're familiar with the GraphRag. So it's kind of trying to understand complex documents, making the best of both worlds in terms of graph-based learning as well as generative AI, because one is a little bit more structured, so you can get the connections, and the one is you can learn from unstructured, of course, using large language models. So how can we use the best of both worlds, and why it's needed? Because in government, there are lots of use cases where you need complex understanding, complex documents, history you need to analyze, trends to make policy decisions and things like that. Yeah, I'm not going to go over all these applications. I think you're pretty familiar with other ones like automobiles, finance. We have a gaming org. We have various games that we develop. But I'm going to focus on the 2 applications that I'm more interested in and spend a long time in healthcare So healthcare has the highest potential, I would say, in terms of applications of generative AI. Some of the applications I used to develop over the last few decades is clinical diagnosis inferencing, because there are lots of data sets in healthcare, right? So how do you make sense of all that? So if you go to the doctor, you should have 100% confidence that the things that we are going through with our health, that is identified correctly, right? So that's where I think there's lots of potential. But also in terms of empowering the clinicians, in terms of note taking, because they have to spend a long time to write summaries of discharge summaries and things like that. If you're in a hospital in ICU, lots of copy pasting going on, right? So one of the research I have done in the past is the copy paste errors, the documentation errors, that actually leads to that's the leading cause of death, and nobody knows that. So so that's kind of fascinating, that if AI can help you to take a look at during the process of documentation, is there anything that is not making sense, right? So that's one useful applications of AI in healthcare. A little bit about education. I had a panel discussion a few weeks back with Peter Norvig. We read all through his book, right, the AI book. So he's a pioneer in education. So we have been discussing how AI can help in healthcare, right? So in education, sorry, in terms of tutoring, right? So personalized tutoring. So we used to have, our teachers expert in different domains, right? So now generative AI has given that luxury that you can have a 24/7 tutor using any large language models that you can think of right now, at least to get some basic sense of or basic understanding of a domain. So tutoring systems, and if you think about the teachers and professors, they can use similar models for generating questions. So we released Forms Copilot few months back. It's one of the highest rated applications, Copilots. If you use Microsoft Forms, so you used to spend a lot of time to generate questions, right? So or write questions for yourself, like questions and what should be the answers if you want to do a survey or quiz or things like that. But we developed this from scratch. So now you can just give a prompt, and you can generate questions with options, just within seconds. So that's a huge empowerment for the educators. So moving on, just to take a step back, how we came from here. I know we don't have much time, so I'm just gonna pass through this. So that all started billions of years ago, right, with all of us, right? So this progress contributed by all of us from different fields, right? Because everything is learned from data, right? So these models are learning from data. But if we pinpoint, hundreds of years ago, printing press, that's actually one of the pivotal moment, because people knew that, okay, how to express ourselves, how to write it down, right? And from that, then world's first program was created by Ada Lovelace. So she was an intern for Charles Babbage. But that was not appreciated. But we knew that logical reasoning, that is useful, right, to make sense of the world. Next 50 years, in 1950s, there was PC operating systems, AI, machine learning terms were coined, but incremental progress happened, but not much because of the compute and data related challenges, right? Then in 1990s, internet came, so that is another explosion. I would say that's the most important in my opinion, the pivotal point, because before internet, everything was siloed, right? So we had data in our own computers, but then how can we scale it up? So that scaling began through World Wide Web, and lots of data started being generated. And then IBM came with Deep Blue, then social media. So that's also another, boost of data and connections and expressions. But then how do you manage all this data, right? So then cloud computing was necessary, right? And how to optimize all this, how to scale all these things. Then smartphone, I don't have to explain. So now we have more data through that. Watson came up with that application that won the Jeopardy. So that's also a tremendous boost to show that how knowledge bases can also help making sense of the world. The deep learning era came in the last decade while I was working on some of these applications. So here, so in terms of reinforcement learning for summarization, my PhD thesis was on summarization. So how to summarize complex data in unstructured documents. And throughout that process, we had sequence-to-sequence models and all the way up to transformers. That is the back end of all these large language models. And of course, we know the rest, ChatGPT and GPT-4, all these models that came. And afterwards, now we more know about AI and discussing all this because, of course, the Nobel Prize in 2024 have been awarded to a few AI pioneers. So that's the how we came here. So the reason I had that slide is because if you see the history, that there has been lots of evolution, right? So evolving definition of AI and complexity and expectations, right? So in 1950s when Alan Turing proposed the Turing test, right? So there the idea was, can machines think like human? Can it actually fool human, right? So if you're in the other side of the room, do you know who is doing the computation or who is behind, right? Is it a machine or a human? If you give some mathematical calculation or things like that. Now, do we now know, right? Do we expect that? We take for granted, right? So computers can compute in at scale, right? So that's the question we try to ask throughout the history. Can machines act or think like humans? So Richard Feynman, so famous physicist, so he came up with this nice analogy that machines may not think like human, so they can at least think maybe differently, right? In terms of performance, they could perform maybe less than humans in certain tasks, or they can perform better than humans in certain tasks, right? So that's the idea. So not like human. Then the analogy he used is plane and bird situation, where planes don't flap their wings, right? But bird does. So that's the idea. And in terms of data and machine learning, everything is learned by machines through the data, right? So the data also includes humans' limitations too, right? So that is the challenge. That is one of the open problems, right? How do you make sure the data is clean, and who is the judge here, right? How do you evaluate? So yeah, I'm going to talk more about it if I have time. But from this, you can see that there is the expectation changes. So when IBM came up with Deep Blue, right, the chess algorithm, nowadays we take it for granted that AI can play chess very well in a constrained domain like chess or Go games, right? All these constrained domain, AI can think ahead, memorize all those experiences, situations in the game, and beat champions easily. We take it for granted, right? So then, how do you define? Now, can we say the machines are intelligent enough? Maybe not, right? So how do you define intelligence? Is it knowledge, or how do you think about, is it wise? Because there is a difference between knowledge, wisdom, and intelligence. Are machines aware of what they are doing, right? Because they don't have awareness, right? So that's the other part. If they make mistakes, there is no way that they can tell it. But now we have self-reflection mechanisms to be able to kind of, ask itself. So the, models can have prompts inside or some reflection agent that can, try to understand if the responses were good enough or not. But then at the end of the day, that might also be something errors, right? Some errors may come up. You have to judge continuously, right? So in 2012, there was another test of intelligence came up from University of Toronto. It's called Winograd schema. So that was about common sense reasoning and NLP. So think about it. Even a decade ago, people used to think that, okay, if this sentence, the trophy wouldn't fit Brown's suitcase because it was too big, what was big? Is it the trophy or the suitcase? Just to understand this sentence, was hard, right? But nowadays, large language models can, understand this or do common sense reasoning like this very easily. Now, fast forward this year, right? If you think about intelligence, it's basically combination of everything. It's the human cognition abilities, right? So attention mechanisms, the machines need to have some sort of memory. It has to have ability to learn, change, understand, act, all this, right? So the things that we do as a human, plan, organize, innovate, imagine, all these different cognitive processes, and going towards autonomous agent. Can it do everything by itself, right? So these are the expectations that we have now over machines. And we didn't have these expectations before ChatGPT, right? So we used to think, okay, there's no way that this is possible, right? So now, so that's the progress that I would say that happened after ChatGPT is our expectations changed, and the impossibles, the things that we used to think before, that are becoming possible. So now if you look at this slide, just to show you that how the expectations change is also related to computational capabilities and AI capabilities, right? So here you can see the compute complexities, the AI capabilities also changed exponentially, and that's also based on our expectation on AI. And the rate of adoption, if you think about it, because this is the most transformational technology, right? If you compare with PC and internet, you can see from here that within the first 6 months, 40% adoption rate for generative AI, which is significantly higher than PC and internet. So that also tells us that people are using it more and more. And we had one AI at work report. So we tried to write this report. Our broader team works on it. So how to make sure that people are using it and how to know that it's useful. So 75% of people are already using it at work. So this is like 6 months old report. And 46% of them, they started just 6 months ago. So these are the proof points that these are helping people to empower themselves. All right, so how things changed is based on natural language. Okay, so I'm going to fast forward. So things started from natural language translation, and that is decades ago. And then word embeddings, sentence embeddings, all this give us the understanding that we can actually make sense of the words and phrases. That led us to large language models. So some of the papers are highlighted here. I contributed in neural paraphrase generation. That was one of the first deep learning model for making sense of sentences and paraphrasing it at scale. Yeah, moving forward, I have 5 minutes, right? So the verticals, right? So there are lots of data domains, right? So that is the future that you can see. We started with language, started with text, but then we have image, audio, video, 3D code, all these domains that are all supplying data for tremendous generative AI boost. Now the main thing that changed in the last decade and through this generative AI is the foundational models versus task-specific models, right? So when I used to do research, I had to have specific data sets, specific training data for specific tasks. But nowadays, for foundational models, you don't need specific data because, basically everything is taken into account as sequence of words, because sequential words can be used for self-supervised learning. And for that, you can now also have multimodal, multitask, and multilingual learning going on if you, train a huge language model. Now, yeah, I'm not going to go into details of these models because I'm pretty sure you know that this is basically trying to understand and predict the next token. Now, remember, the pre-training is not enough, right? Because if it was enough, then language models were here, long time. So even with lots of data, language models are not enough. So you need supervised fine tuning. You need some sort of supervised data on top of it. Then you should have a reward function and reinforcement learning based, human feedback on top of it to make it all work. So ChatGPT gave us that recipe that how things work. But this is the most important slide for today, I would say, is even though you have the model, most powerful model, that is not equal to product or application. You have to think about users, how they would feel, how they would experience, what's the context, what's their intent. You have to have responsible AI validators, guardrails to understand all this. And then you may have a model, right, to generate the ideal response. And then the response also needs to go through different RAI checks before it can really put it into production. But this is also not about GPT-based model. The products that we are building, it's not only about language models. It also includes various traditional machine learning models. So it has to combine all the best of different worlds to make it work at scale, because there are so many users, right? So how do you know if it is a complex intent or a simple intent? For simple tasks, you don't need to use large language models, but for complex tasks, you might need. So optimization is huge when there are like billions of users. Yeah, so Microsoft's vision is, of course, innovation, transform industries, and transform society. And we do it at using responsible AI principles. Yeah, you can check it out in our website. So these are the all the application layers that we have. If you go to the website, the Azure AI Foundry, so that helps both developers and users to build their own applications and use the applications that we are hosting here using various APIs. So the platform is at the bottom layer. At the top, you'll see the application layer. In between, there are lots of microservices shared for different type of use cases. And yeah, we are building all these copilots, as I mentioned before, and I'm leading the Office M365 ones and also the Azure AI copilots. We are also working on copilot agents that was released few weeks back. So you can build your own agents now if you go to the Azure AI Foundry. All right, so future. Okay, I'm just gonna flip through the slides. Time is very short. So our current work is, should we just keep building these models and make it larger? Maybe not, right? So how can we optimize this? So that's why we're creating smaller language models, because it's more affordable, accessible, perform as equal as large language models, cheaper to develop, easy to customize. So you can look at our Phi and Orca series models. We're going multimodal, multilingual, as I mentioned before, because obviously to make sense of the world, you cannot really do it with one modality. You have to go across modalities. Doing it at agent scale, so agentic design patterns. I talked about reflection, but how do you connect all that with various tools that are already here? Planning, multi-agent collaboration, delegation, specialization. So this is, we're going towards the agentic world. And I will end with few slides. I have just, this is my current focus, research paper accepted at Calling. Even if we are learning everything, can we unlearn? Why do we need unlearning? Because as a human, we have the luxury that we can forget things, right? So if I ask you what you ate for dinner a few weeks back, I'm pretty sure you're not gonna remember, right? So we have the luxury that we forget unintentionally without knowing how we are forgetting. But for machines, it's hard if you have a large model to make it unlearn. Why you need unlearning? Because some of these large models, we don't know how they're trained. They're black boxed, what data set they used. So there might be unintentionally some of the data going that is harmful. And because of that harmfulness, we have to spend a long time to make sure they don't hallucinate, they're not harmful in terms of responsible AI guardrails. So this kind of a chicken and egg problem, like how to make it work. So one way to do it, can you unlearn? So in this paper, we showed, yes, this is a new state-of-the-art results we achieved, that you can actually force it to forget some of the things that you wanted to forget without by the same time making sure that it doesn't forget the things that you want it to remember, right? Because previous state of the art has that problem that it didn't work at scale. All right, so the key problem with all this, the open problem session, right? So the open problem, I would say the one problem in all this that I discussed is the evaluation. How do you evaluate this? Okay, human evaluation is not gold standard. So if you look at the benchmarks, they have ground truths. Who created those ground truths? Humans, right? How do you know that we didn't make a mistake? Who is the judge here, right? So that's why, the assumption here is that loss of data, loss of human judges, maybe there is a consensus between the judges, annotator agreement is a good measure of that. But then again, you'll see there is not 100% alignment because as a human, we differ in our opinions, right? So that would be the ongoing challenge all the time, is how do you evaluate all these solutions when you build these applications? Yeah, so this kind of summary slide, what I talked about. So various things we are working on right now. And then the future, well summarized by OpenAI a few months back. So we have achieved level 1, which is conversational chatbots. We now can use it at scale. Reasoning and human level problem solving is also kind of done. We are going towards planning, reasoning, and agent-based at level 3, so that is happening. And we should go towards imagination and innovation because that's the holy grail of intelligence, right? But even that's not enough, right? So the things that are not mentioned here is, emotional intelligence. Can machine inspire you, right? Encourage you to do something. So there are many other aspects, right? So those are not possible or not evaluated in the existing benchmarks. And level 5 is, organize events like this, right? And then we just get invited at scale. All right. Thank you so much for your attention.
Thank you so much for a wonderful talk, Sadid. We can take a question from the audience if there is one. And maybe Andrea, you can come and start setting up. Yeah, let me give you the mic.
Hi, I'm David Rose. Since your background is in summarization, I just had a kind of hypothetical, which is, do you think we can write good obituaries? Like if I was able to record a lifetime in audio and maybe some visuals as well, like could you take that and make a meaningful, compelling summarization of a life?
I think so. Yes. Yeah. With the current technology, that summarization is one of the use cases that we feel that it's kind of solved because of large language models and also multimodal models, right? So video, text, image, text. So all these attention-based models and transformer-based models that we have. So that is really powerful. Yeah. So I would say that's, even I don't know if you used Google's Notebook LLM, right? So from text, it can generate podcasts in seconds, right? So that shows this has come a long way. So yeah.
Thank you. And I'll ask one as Chair's right. So you're talking about reasoning and agents, multi-agent settings. Do you think that transformers plus reinforcement learning are a powerful enough combination of algorithms to capture that behavior, or do you think we need new fundamentals as well?
We need new fundamentals. So I'm following the Liquid AI's work. I don't know if you're familiar. So obviously these models are static, right? So once you finish training, how do you make sure they're constantly learning? So that's the challenge of continued learning, and people do fine tuning. All these OpenAI models, they have now new releases coming up, right? But in Liquid AI, they came up with the technology where even you have something in your architecture that can help you continue your learning even during inference. So that is, I think, game changer, I would say. Yeah.
Thank you very much. And let's thank Sadid again. Thank you.
Thank you.
Okay, for our next keynote, we're extremely fortunate to have Professor Andrea Bobu come all the way from MIT to tell us about her fascinating research working on human-robot interactions. So we got to know Andrea when she gave a wonderful talk at our Mathematics of Neuroscience and AI conference, remote, unfortunately, but I hope we can have you in person another time. And we just loved it. You know, we thought it was such insightful work, really right at that sort of open problem frontier level of thinking about computationally how we can build robots that can understand human intentionality and work with them together. So Andrea has some really cool videos, and we're going to see some of them of her work in action. Andrea, we can't thank you enough for joining us today, and when you're ready, take it away. Thank you.
Thank you so much for a really lovely introduction. I'm so excited to be here today and to share with you a little bit about our work on enabling efficient and human-aligned robot learning. So in our lab, our very new lab at MIT, we're 4 months old, we develop robot algorithms that learn from people. And we do that because if we want robots not just live in a vacuum, if we want to put robots in human-centric environments, then we would like for them to be capable to adapt to the people that they're interacting with. And so as an example, here this robot wants to carry this mug over to my colleague on the left. And so it can do so by generating a trajectory that kind of optimizes a pre-specified reward function. So this could be hand-specified, or it could be learned from data. And so initially, the robot only cares about being efficient, so it follows this shortest path trajectory from start to goal. But then I notice that it's carrying the cup way too high above the table. So what I can do is I can push on it to correct it, and now the robot can learn from correction and adapt to how I want the task to be done and kind of generate a new trajectory that does the task the way I want it. So this is one example of robots adapting to people. Now this works because the robot already had a representative prior on what the human could possibly want or care about. But this is just one example of one preference. Humans have vastly different environments, tasks, preferences, and so when those differ from what the robot expects, you're going to have some problems. And so as an example now, if I want the robot to stay away from my personal laptop, say, but the robot's prior kind of doesn't know about that. Whoa, my computer froze. That has not happened before. Whoa. Sorry about that. This is unprecedented. I've never seen this before.
So sorry, yeah.
Reboot? Okay. That's unfortunate. Okay, rebooting computer. Luckily, it's a brand new computer, so this should be quick. But then the fact that this is a brand new computer makes me very worried. It's possible. All right. Great, we're back. So if I now want something else, like the robot to stay away from, to keep the coffee away from my personal laptop, I could try to push on it, but the robot's prior doesn't really account for this new preference. It's never seen it before. And so the robot isn't going to be able to learn well from my push, and even worse, it's going to learn something else entirely. So I'm not super happy with the execution here. Now you might say there's an obvious solution to this. Just collect more data and build better priors, better foundation models. And in fact, there are all these amazing research teams from Stanford, from NYU, from Columbia, that have come up with these really creative hardware designs for how to make it easier to collect more data for our robots. And so this effort has resulted in some pretty impressive robot capabilities. And so these systems are remarkable feats of robot learning and of engineering, but they still have some crucial issues that prevent us from having a robot in our home right now. So first, even for a simple task like this, picking and placing a teacup on the plate, the robot needed 300 demonstrations, which is about 3 hours of human data collection time. And this is for a single task. If you are trying to think of having a personalized robot that can adapt to multiple different preferences, this is already completely infeasible in practice, and it's not attainable. Another issue, and this is kind of related a little bit to this first issue, is that without a ton of data, you have these powerful models that are very brittle, and they kind of fail to generalize even when there's a slight shift in the domain distribution, when they're slightly out of the distribution. And in fact, we even tried this purely data-driven approach in our lab. And so let's see what happens. So we have a scenario here that's very similar to what we saw before, where we have a person that wants to keep the cup close to the table and away from this laptop. So spatially, the reward function might look something like this, where it's really low when you're right above the laptop and high above the table, and it gets better when you are closer to the table and farther from the laptop. Now, the robot has a mismatch prior, right? That's missing some notion about this distance to laptop. And so what we could do is we could say, hey, let's just collect more demonstrations and just try to retrain our model and try to learn a new reward function. It turns out when we do this, we vaguely learn that being around the laptop is bad, but we don't really learn these more fine-grained details of the reward function that also combine this gradient of like, hey, distance to table also matters. So we're kind of seeing that without enough data to kind of cover a domain or to cover the state space in this case, deep learning ends up generalizing pretty poorly. And the implication is that if I now take this reward function and optimize it and try to produce a behavior, I get something that's pretty suboptimal in contrast to what the human would want to see from their robot. And so the core question that we're tackling today is how can we get robots that adapt to new and diverse user preferences efficiently? Or in other words, how do we get robots to learn a lot from a little? So what I think is that robots don't just need more data, they need better data. And to learn a lot from a little, we kind of have to rethink how we engage with humans and with human input and with the structures that we build around collecting human input. And so today I'm going to talk about three kind of lessons or three ways in which we've managed to kind of learn a lot from a little in our lab. So first, we're going to talk about designing new types of structured human input that are rich in information for the robot, but they're also very effortless and easy for the person to give. Then I'll talk about how can we amplify the sparse human data that we get by using perhaps simulation or LLM priors. And finally, we're going to talk about how structuring the learning process, so structuring the actual training on the robot's end, can actually make tasks a lot easier for it to learn, so it will necessitate less data than otherwise. So let's start with the first one. And let's come back to this example. And so here we had that the robot was missing something. So it was missing this distance to laptop feature or aspect of the task that the human cares about. And so rather than taking this purely end-to-end kind of approach to this problem, what we're going to do is we're going to try to focus explicitly on learning what the robot is missing, this feature phi, from some sort of human input about it. And so this is what we're going to be focusing on. This is how we're going to solve this problem. But then the question is, what kind of data do we ask from people to learn this kind of feature? And so one idea would be to just learn it to just naively ask the person for labels of different feature values at different states in the state space. So I'm collecting this data set, and I run super standard supervised learning and train my neural network model. Now, you're going to see some very familiar issues with this. To cover the state space, the robot needs a lot of labels, which is just unfeasible for a person to give. It's just too burdensome. But there's another problem, which is that people are pretty imprecise when labeling states directly. Something like 0.57, it doesn't exactly come naturally to us as a label. We can tackle the second issue, it turns out, by instead asking the person for relative labels, comparing the feature values in pairs of states across the state space. And so I can now take these comparisons, the set of comparisons, and train my model with what is called the Bradley-Terry model for pairwise comparisons. But I'm still stuck with this first problem, that I still need a ton of comparisons. So our take here was that humans are actually a lot more competent and intelligent than giving 0-1 labels, so long as we give them the right way to give us data. And so what we wanted here was to come up with a new type of input that is really informative for the robot, but doesn't place too much sample complexity burden on the human. So our idea was that we can pack a lot more information if we ask the person for a sequence of states with the property that the feature values are monotonically decreasing. So we called a sequence of this property a feature trace. And what's nice about this is that the robot can sort of exploit the structure that this monotonicity brings and automatically extract these comparisons on its own. So let's see what this means in practice. So in practice, what a feature trace looks like is if I am trying to learn the distance to my laptop here, I would start somewhere where the feature is very highly expressed, so right above the laptop, and I would move the robot away to somewhere where it's not highly expressed, so away from the laptop. So then the robot can collect a few of these feature traces, and from them, it can learn a feature function neural network that's defined by them. Now, what does this look like in experiments? So we have some examples of features that we learned with feature traces from expert users, as well as non-experts in a user study. And for all the evaluations we're going to look at, we sort of sampled this test set of states in the robot's reachable set. This is the 3D ball of points here. We color it with the colors corresponding to the feature that we're learning. So this is the distance to laptop feature. It's yellow right above the laptop, and then the gradient goes towards blue when you move away. And something else that I can do is I can project this onto a representative plane to kind of have an easier time visualizing. So for the ground truth feature, when you look at it, at the projection, you see that you have this kind of projected ball that kind of decreases in intensity the farther you look from the laptop center. And when we learned a feature with our data, our structured feature traces, we ended up with something that's pretty structurally similar to the ground truth. And this result holds across multiple different features of varying complexity. And what's nice about this is that we learned these features with somewhere around 10 to 15 feature traces. So this is maybe minutes, just like 3 minutes of human effort time, which is a far cry, which is so much better than the thousands of demonstrations you would have needed in the end-to-end approach. Now, we also wanted to know, can real people who aren't experts also give feature traces? Is this a possibility? And it turns out the answer is yes. So these are examples from my user study. So we see that people kind of started their traces in the middle and then moved away in all sorts of directions. We recovered the feature that looks very structurally similar to what we saw on the previous slide. For table, they kind of went up and down vertically and spanned the feature. And finally, my personal favorite is this proxemics feature, which is this idea that people really don't like to have things in front of their face more so than to their sides. And so these non-expert users figured out that the best way to teach this is to give these traces that are longer in front of them and then shorter and shorter to their sides. So we didn't tell them that. They just figured it out. So this kind of indicates that there's potential for these kinds of new types of input to be teachable to regular users, not just roboticists. And so now that the robot understands what I want. It's able to do the task in the way that I want it. It stays close to the table and also stays away from my laptop. So the takeaway from this first section is that data isn't just what we collect, it's how we collect it. And so by structuring the input, the human input, in ways that align with humans, we can make data collection more effortless for the person while also packing a lot of information for the robot so that it can learn faster. So next, we're going to have a look at how can we augment the sparse data that we're getting from the human after we collect it. And I'll talk about two key ideas that we found promising for this approach. So one idea for learning a lot from a little in this approach was to collect a small amount of data from the person, like a small amount of labels, but then amplify them using simulation. And so if the person, for example, cares about teaching the concept of objects being near each other, we can collect data from them of like, oh, this image is near, this image is not near. So we collect a small set of labels. And then we use some privileged information from the simulator, like object poses, bounding boxes, and so on. And with these labels from the person, we can train this kind of small neural network model, the small model that represents the concept that the human wanted. And then what we do is we kind of instantiate many, many different objects in the simulator for many different poses. Again, we have a lot of variability that we can kind of explore and exploit in the simulator. And so then we use this concept that we trained from humans, this very small, nifty concept, to act as an automatic labeler for a ton of data of high-dimensional images for free. So essentially, with the simulator, we're able to augment a data set of like a couple hundred human labels into tens of thousands of examples for free. And this enabled to learn some pretty robust concepts like objects being near or above each other, and that transferred to the real world with no additional human feedback. So this worked out of the box. So by distilling human knowledge into this small model and using a simulator, we were able to kind of automatically label so much data that kind of, at the end of the day, all we needed was maybe 15 minutes of actual human labeling time, but simulation is a very powerful tool for amplification. And the other idea for how to augment human data is to use strong LLM priors. And so here we had a human demonstrate throwing away the can in two different scenarios. And we wanted to ask the robot, hey, why are the two behaviors different? What makes them different? Now, to us, it's pretty common sense that the person wanted to avoid stepping on electronics. So we wanted the robot to be capable of the same sort of common sense reasoning. So it turns out that large language models, or LLMs, have a lot of these great common sense reasoning skills. And so in these two recent papers, we essentially leveraged these LLMs. We equipped our robot with an LLM. It was able to identify what is the hidden preference from the two behaviors. And then we were able to generalize, the robot was able to generalize to totally new situations that it hadn't seen before. And so here, the human didn't have to say anything about, hey, I want you to also avoid electronics. Instead, we only wanted them to give us two contrasting demonstrations, and just from what the demonstrations looked like and what the scene looked like, the LLM kind of did the rest of the work. And the LLM was able to say, okay, this is kind of closing the gap of a hidden preference that the human didn't communicate, but is kind of, it's kind of implicit in their data, in their demonstrations. Some other examples we had were throwing away the rag, where the kind of hidden preference was we would like for the rag to not drip water on the book. And so the LLM-equipped robot was able to handle that. And another example was watering the person's plant, where the hidden preference was holding the watering can at the right height to be able to water the plant. And so pre-trained LLMs capture this implicit human knowledge that robots can use to infer hidden human intents and hidden human preferences without any actual new input from the person. So data augmentation isn't just about blindly scaling up, it's about structured variability and guided inference. So by purposefully amplifying data, we can kind of fill in gaps and kind of infer some hidden things about human intent. Finally, on the robot side, we can also induce structure in the learning algorithm itself to require less data overall. And so here we wanted the robot to exhibit expressive behavior like tiptoeing when it's afraid to its goal or stomping aggressively when angry. The problem is that emotion is, as you might imagine, a very subjective and very challenging concept to convey to our robots or program into our robots. But luckily, cognitive scientists have come a bit to our rescue. And they found that all emotions live on this really nice three-dimensional space called valence, arousal, dominance. That's very, very studied. This has been studied in cognitive science for years. And so what we did is, because we have this really nice structure that's already been studied, we were actually able to map these complex behaviors on the right to the structure with just 20 minutes of human labeling effort, which is super fast. And as a bonus, these representations, you can plug them into language models, and they generalize out of the box to completely new emotive phrases like great weather today or didn't get the offer. And so using representations inspired by cognitive psychology here helped us simplify the task for the robot, so it was able to learn faster. And the final piece of work I wanted to talk about, we hypothesized that if the robot does have a good representation of what people care about in their tasks, then it should be pretty easy to build on it and adapt it to different user preferences and tasks and contexts, because these are all just different reward functions on top of the same representation. And so the final thing that I want to talk about is how do we actually learn a good representation, because that's going to make our downstream learning much faster. And the core idea here was that if two behaviors appear similar to us, then that means that in our brain we're mapping them similarly. So we represent them similarly. And so what we did is we introduced something called trajectory similarity queries, where we said, and then we asked the person, hey, can you pick the two trajectories from this triplet that, according to you, are most similar? So in this example, the human finds these two trajectories to be more similar because they do the task in the same way. They both stay close to the table and away from the laptop, despite the fact that they look so different. They're very far apart in Euclidean space, but it didn't matter. And so this information, we can use it as kind of examples of positives and negatives in a contrastive loss. This is kind of contrastive learning, a super popular technique for learning representations. But the bottom of it all is that we were able to learn a representation that pushes the positives, the similar trajectories, close together and pushes the negative far apart. And so that enabled us to learn a very robust representation that we can now use downstream. So now that we've used this representation, we can simply attach it to multiple heads of reward functions. We can learn a reward function for one preference, for another preference, for another preference. And so we were able to do this and kind of optimize for new behaviors very efficiently, very quickly by reusing the same representation. So the final takeaway here for the third part is that the representations we use shape how efficiently systems learn from human input. So by designing these inductive structure that we put into our robot learning algorithms, we're able to downstream learn much more efficiently and with much less data from the person. So the message I want to leave you with is that by rethinking how we engage with human input and with the structures that we put around it, we can shift from systems that just rely on quantity to systems that kind of can learn more deeply and more efficiently with minimal human input. I'd like to thank all my collaborators. I'm happy to take any questions if there's time.
Thank you for such a wonderful talk. We've got time for one question, and maybe Agatha, while we're doing that question, you get set up. Yeah,
thank you. The question that I have is regarding the three approaches. The first approach you demonstrate contrasts with the initial example that you have this human pick up like a cup, and you say that you need 3 hours to get the data that is sufficient. The question I see there is that in the example 3 hours, let's say if the cup itself have some kind of sensor allow you to capture the data continuously when moving the data, then the kind of learning process will be similar to what you talking about in the first instant. Is that correct? I mean, that's how I thinking about. It's just the way that you capture the data is much more efficiently that allow you to learn it much faster. So.
Yeah, exactly. So in that example of the teacup on plate, that's the example you're talking about. The reason they needed 3 hours of data is that they assume absolutely no structure in kind of the observation. Like the observation is just an image or like a stream of images. That is a very high-dimensional observation space, and learning a mapping from that to these are the actions that you're supposed to take is gonna, like being able to disentangle a lot of correlates that you have in that high-dimensional space is gonna require a lot of data. Now, the problem gets even more complicated if you want to generalize to new teacups or maybe new tables. Actually, I learned yesterday that they had another set of experiments where they tried to generalize to like a coffee shop table or a table in the park or whatnot. And then they needed to collect 3,000 demonstrations. So basically, the more you want to generalize, the more data you need. Or what I'm proposing, what I'm saying is, or you could have some structure. You might want to try to not just do purely end-to-end approaches. And so the kind of, I guess I hope that through my talk I kind of inspired you to think that structure does help with alleviating the heavy data burden that we currently are posing on ourselves in robotics.
Thank you very much. Question from me. Are you going to come to Croatia and give a keynote there?
When is it? Yeah?
In June?
I would love to. I mean, now I have a visa, so now I can travel.
Fantastic.
That was the problem. That was the problem back then, that I didn't have a visa.
Fantastic. Thank you very much for the question and the wonderful talk. So this is a great pleasure now to introduce Agata Lapidreza from Northeastern, also from MIT, coming today and at Northeastern, a very interesting kind of center for experiential AI, which Agata was telling me a little bit about yesterday. It's a pleasure to have her join us and to give the last keynote of this morning session, which is roughly data coding and robotics. Sam Colvin, when he talks, is also in this session. We're really looking forward to the talk, Agata, and when you're ready, take it away. Thank you.
Okay, thanks for the nice introduction. I'm here to talk about emotions today, and it's great because Andrea already did a great job in motivating why do we want emotion perception or machines that have some kind of emotional capacities. So I've been working on emotion perception for like around 8 years now, and one of the things that fascinates me the most is this capacity that humans have to perceive emotions. So if I show you this image, we don't know anything about this person, but probably most of you agree that she seems to be experiencing a pleasant emotion here. She is showing affection towards her dog. She seems to be relaxed, laying on the floor of her apartment. So all of these perceptions that are so natural for us are very, very complex for machines. And actually, there's been already a lot of research in trying to simulate this capacity. So giving an image of a person, trying to perceive the emotions that this person is maybe experiencing or maybe signaling in this particular situation. And most of the work has focused on facial emotions, facial movements. The thing is that we communicate a lot with our faces. And right now, we already have these very robust systems that detect faces, detect facial landmarks, and map these facial movements with prototypical expressions of emotions like happiness or sadness. Here you have another example. So here is the same type of software. Surprise is detected, the mouth is open, very prototypical expression of surprise. But what happens when we see the context? Well, it turns out that there are many reasons why we move our faces. So we move our faces to communicate emotions, but also for other actions like blowing candles here. So we cannot just rely on one signal. This is something that we have been hearing in several of the talks. One signal is not enough. We need multiple signals. We need context as well. So this idea of how to perceive emotions from visual information has been studied in psychology and has been studied in cognitive science. And psychologists have been running this type of experiments of showing one face and asking participants, do you think this face is communicating anger, contempt, disgust, fear? It's not clear. So what happens when you provide more information? So you provide more information here, people usually say it's disgust. What if I change the information? So this is the same facial expression, I just change a little bit the context, right? So this context is just an object, is a gesture, but the same facial expression is perceived in a different way because the way we perceive emotions is more holistically, not just relying on the facial movement. So these examples that I showed before are from this paper. There are multiple works on showing this importance of context, but for a long time, it was ignored for the computer vision community. So we started working on trying to incorporate this idea of understanding also the context to make a better sense of facial movements when we try to perceive emotions. And the idea was work on this problem of apparent emotional state recognition. And notice that I'm saying apparent emotional state because the reality is I'm just seeing an image, so I have no idea about what is exactly in the head of this person. It's apparent emotional state, that's fine. So instead of looking at the face, let's try to also make sense of the context. And when you look at this face, maybe you can already say, there's like a positive emotion here, but when I show you the context, you can say, okay, you can go by more fine grain because you understand the situation. And maybe you can be more detailed. You can say, probably this person is feeling confidence here. So we were approaching this, this problem of trying to train these deep learning models, machine learning models that have images as this one as input, so images of people in different contexts, and trying to estimate this apparent emotional state. And the problem that we faced when we started working on this project was that we didn't have data. So we needed to go through some data collection process. So what we did is we collected a lot of images from different public data sets that are widely used in computer vision, but also some images that we downloaded from search engines. And then we designed different types of annotation interfaces, like the one that I'm showing here. So basically, we were using Amazon Mechanical Turk. We were showing these images, and we were asking annotators, what are the emotion categories that you think this person is experiencing or expressing in this image? And we collected also information about valence, arousal, and dominance, so other types of emotional annotations. And then we came up with what we call the emotic data set, so this large collection, thousands of images with these annotated emotions. And we were training different types of machine learning models, so trying to make models that can do this task automatically. So just very briefly, the type of models that we were designing were models that, on the one side, were extracting information from the person. On the other side, we're extracting information from the whole image and the context, and then we were merging this information to predict the emotion category. So if you check our papers, you'll see a lot of different types of configurations of the model, loss functions, and so on. I'm not going to enter into the details, but what I want to explain today are some of the conclusions and lessons learned with this project that have shaped part of the research that we do in my lab right now. So, as I said, it was the first time that in computer vision we were bringing this importance of scene context, and what we noticed is that this scene context was providing meaningful information, so we were getting better accuracies when we were considering the context. So that's cool. And now, so right now we are working with incorporating other types of context. So scene context is just one type of context, but there's cultural context, context about the person, context about the annotator, so there are many types of context. One thing that is very interesting, and I think that this has been discussed this morning as well, is about the subjectivity of emotions. So not all of us express and experience emotions the same way. So it's less objective than other tasks like detecting a car in an image. So how do we deal with that? So one thing that we observe, this is just one image, and this is the annotations of 5 different annotators. So you see that annotators provide different emotion categories, but there are still some patterns. So there's one other way of visualizing this, which is with a histogram. So basically, I'm showing here a histogram, x-axis, all the emotion categories, and then you count the votes that you had per each category. So what you observe is that when you start collecting annotations, in this task in particular, these histograms change. but at some point, after 15, 20 annotations, they stay pretty stable. So basically, there are different opinions, yes, but it's not random, so there are patterns, so there's something we can do. But still, when we model these type of problems, we need to embrace the idea that we are different, there are individual differences, we have different opinions, so we need to use machine learning models that can deal with all of these different opinions if we really want to make machines that can simulate these emotional skills. So we have been working a little bit on how to deal with this agreement level and reflecting different annotation opinions. If you're interested about this, I can discuss this more. But then the other idea is this task is very challenging. So perceiving emotions is very challenging, and particularly if you want to make machines that can perceive emotions in the wild in any type of situation. So when you have a very complex problem, one thing that you should do is make it a bit simpler so that you can approach it and make some advancements, right? So one idea is, let's approach emotion perception in more restricted domains, which is related to use cases. This is something that we are also interested in. So I'm going to explain one example of use cases that we have been working in my lab, and this is the domain of assistive driving technology. So we hear a lot about autonomous cars, but right now, there are not autonomous cars around us, but we have cars that help us drive in a more comfortable manner, in a safer manner. So we have assistive driving. And one thing that we were interested in is developing systems that can perceive particular emotional states like stress that can affect the experience of driving and can affect the road safety. And the reality is that we experience extreme emotions while driving, and work commute takes around 1 hour on average in the US. And these extreme conditions, as I said, can affect our mental health and road safety. So there's been a lot of interest from the automotive industry to reduce the stress and make sure that you have a better experience while driving. So how can you do this? So basically, you can put sensors. You can be very creative here. So basically, the idea is, let's capture signals that are meaningful for perceiving emotions. You can think about cameras. You can think about microphones and analyzing voice tone. You can also think about having pressure sensors in the steering wheel. So you can be very creative here. And then, of course, you need signal processing, machine learning, to make inferences about the emotional states. And third part, very important, you will need to design interventions, right? So imagine that the car detects that you are very stressed. What should the car do to help you reduce this stress? So we have been mainly working on the perception part. And one thing that we noticed is that in these types of technologies, the focus was always in the interior of the car, this steering wheel or the cameras in the interior of the car. But the reality is that you drive in a context, you drive in a road scene, right? And depending on the context, this context is going to affect your emotional state. So we were studying, this is a collaboration with my collaborators from MIT, my PhD student Christina. So we were studying how to understand the emotions evoked by the road scene, so this contextual signal. And here I have a question for you. So imagine yourself driving either in scene A or scene B. Which of the two do you think is more stressful? So who thinks that scene A is more stressful? Okay, who thinks scene B is more stressful? Just me. So, and the thing is, there's a lot of agreement on this feeling of stress, because what happens in scene A is that there are a lot of elements that are less predictable. There are pedestrians, there are cars. So our hypothesis is that some objects and events that are visible in the driving scene are informative to understand the current driver's subjective stress level. So what did we do? So we work with this type of data. So basically, we have people driving. We have self-provided stress. So there's someone in the car that is taking notes about the stress the driver is experiencing. We are also taking physiological signals with bracelets. We are not using right now the physiological signals, but of course, physiology also gives a lot of information about your emotional experiences. And then we have a camera pointing to the road scene. And the task is, let's take the video of the road scene and let's try to estimate the driver's self-provided stress. with, of course, deep learning models. So we have this video sequence, and we want to predict the level of stress. So again, we try different models. You can check our papers. But one thing that I want to highlight is that we were very interested in using explainability techniques. So I'm not sure if all of you are familiar with explainability, but the idea of explainability is we want models that tell us not just this is high stress, but ideally, we would like to know why. What in the road scene creates or triggers stress in the driver. And for that, we can use post hoc explainability techniques depending on the type of architecture that we are using. But for one of the architecture we were using, we could use these explainability techniques. And here you're going to see the example. So imagine that you have this video sequence labeled as high stress. So this is one explainability technique. It's called class activation map. This is a technique that we actually developed around 2016. It's been broadly used. But the idea is that with a mathematical formulation, you can create these heat maps that I'm showing here. And the red areas are the regions of the image that contributed the most to the output that produced the model. So basically, if I also have object segmentation, so a system that tells me, the different objects that I have in the scene, and I cross this information, the class activation map with this object segmentation, I can know what are the objects that seem to be causing stress to the driver. And this runs automatically. So the nice thing is that once you cross this explainability with these segmentation techniques, you can do analytics of stressors in all of your data and discover like the presence of pedestrians and pedestrian areas correlate with high level of stress, while vegetation or non-obstructive views correlate with low levels of stress. The nice thing is that this was automatically discovered by the model. So basically, with these models, you can have this type of output. So the outputs of the middle, so basically you have the input video, and then at the bottom, the segmentation, and then in the middle, the intersection with these stressors. So imagine how this can enable, at some point, real-time interventions of your car to help you deal with stressful situations. Of course, there are limitations in our research, so these are promising results, but all of these experiments were run in a small data sets, so 45 min drives, nine different participants. It's not a huge population, and it just represents one geographical location. So before implementing this in practice, we need to scale up the experiments for sure. Okay, so this was about assistive driving technologies for adults. There's one project that I want to briefly mention, which is assistive driving for kids. This is a project that was inspired by the assistive driving technologies for adults, but the goal here is very different. So we want to develop a ride-on car, a ride-on robotic car, to reduce the stress of kids before surgery. So the idea is to integrate the same type of sensors and use this car to take kids from the waiting room to the surgery room and reduce anxiety through distraction with different interventions that you can implement in the car, and ideally also take vital signals at the same time to avoid this moment where kids go to this room where they take all of these vital signals before going to the surgery room, which is a moment that they experience a high level of stress. So this is a long-term research. So at this moment, we have the conceptual design. The car was produced by Hyundai. We had a collaboration with Hyundai. And we ran a small pilot in the Children's Hospital in Barcelona. There are many people involved in this project from MIT, different companies. But if you are interested, we have this paper summarizing the first pilot. And okay, so these were like two examples of projects in my lab, more related to use cases. I want to talk a little bit about ethical implications, because well, you heard a lot about ethical implications yesterday. It's a very important aspect, of course. And here we are talking about emotions, which is sensitive information. So of course, for all of this, there are a lot of ethical implications. So let me just mention a few considerations. So one thing that is important to take into account when you work in this type of research is that there are multiple ground truths involved in, for example, emotion perception. So imagine you have here that person, the target person, so you want to create a system that perceives the emotion of this person. This person is experiencing an emotion, so meaning that this person has an internal state. But then this person might be signaling an emotion intentionally, right? With gestures, with the face, etc. Often, you have an external observer which is going to perceive the emotion. And this perception of the emotion is going to be affected by the internal state of the observer as well. So here you have three different ground truths. They might not be the same. Maybe, I don't know, I didn't have a good day today, but I don't want to show it here. So, you know, there might be some misalignment with the emotions that, with my own internal state, what I express, and what the audience perceives. So we need to be aware of that, because often there are works that focus on perceived emotion, and then you might think that this system is perceiving the internal state of the target person. That's not okay. That's actually terrible. So it's very clear. It's very important to have this clear. Then there are different ethical implications depending on the type of ground truth that you are working on. So it's not the internal state is much more private than whatever emotion that you are intentionally trying to signal. So different levels of ethical implications. And when you think about use cases, it's important to know for that use case, what is the ground truth that is more appropriate to work on and how you can get this type of ground truth. Of course, it's essential to be aware of the limitations of the technology, and then the user must be able to decide whether to use these functionalities or not, I think, when we use these technologies in practice. And to conclude, so I talked a little bit about some use cases today of emotion perception for the assistive driving technologies, but of course there are use cases. We work also in social robotics, trying to enhance human-machine interaction, but there are also use cases around gaming technology, user experience, wearable sensors. We are working on trying to understand mental health conditions better through data capture with wearable sensors. So there are multiple use cases, and I'm happy to answer any questions you may have.
So thank you very much for an awesome talk. Golden Gate Bridge, Tunisia, Barcelona. Something tells me you like to travel.
Yeah, I do.
Excellent. So we have time for one question, and then we're going to take a short break, and we can ask more then. So does anyone have a question for Agatha? Yeah.
Hi, thank you very much for introducing this very interesting topic. I'm working for the healthcare industry, and actually we have a big problem of the mental health part, because it's a very common disease, but actually currently we don't have the very nice drugs or the assessment, measurement of the drugs, because we use the way is to let the patient take the drug and then to collect the data maybe 4 weeks later, and to give them score about the current, how about your dimension, depression, for example, in many dimensions. But actually, there is a lot of problem. One is the recall bias. They might already forget the last time. What is the 5 point? What does it mean? And another problem is about the interaction. Because of some skills from the nurses or physicians, they might circle the different points. So we can't really get the very objective to compare which one, drug A and drug B, which one is better. Even currently for FDA, they also use such ways. So I'm just wondering whether such kind of the technology can change this situation to let us to really develop the very effective drugs, and also to ruin the effective drugs, and not to ruin those ineffective or rule out those effective drugs. So that is very, very important in this mental health drug development area. But we also have the problem. I mean, when I think about this emotion perception technology, I think I really hope this can be finally be applied in this area and to change the situation. But currently, it also have, I think there are at least 3 problems. The first problem is how we can continually to collect the data. I mean, by daily, or when we can collect this data and how. And the second one is because there are heterogeneity among patients, different people, as I mentioned about it. So I was just wondering how you can really capture the true data, can really, I mean that to implicate their situation get better. And also, a third thing is I think it is also a long way for those regulatory agencies to demonstrate this digital endpoint is really very effective ones. So I think these ones, I want to expose these questions to this community and to cause some thinking whether you are interested to apply this technology in healthcare and to help more patients. Thank you.
Yeah, all right. Thanks for the question. And I think that you did a great job summarizing the challenges of the, understanding mental health conditions. You said a lot of things, but so I guess that my general thought is, yes, we are actually partnering now with clinical psychologists, particularly for mental health use cases. What we are doing is trying to use wearables, different types of wearables. We are using like bracelets, glasses, different types of wearables to collect continuous data in a passive way, right? So if you have a wearable, this wearable can be collecting continuous data in a passive way. And then what we are trying to do is extract from this data information that is meaningful for the clinician or for the patient to better understand the condition, for the clinician to make better recommendations. So one of the, you mentioned a lot of issues, but this idea that you have to actively provide, field questionnaires from time to time, this is not reflecting objectively all the information. But some of the questions, so for instance, it's known that exercise and depression or depressive symptoms, there's some correlation, right? So it's not really clear cause-effect relation, but there's correlation. So if you exercise more, you are less likely to develop maybe severe depression symptoms. So does it make sense right now that we ask people, how often did you exercise last week? No, I mean, if you wear like something like an Apple Watch, right, you already know this information. So can we go further? So can we extract other type of markers that can help monitoring the progress of depressive symptoms more objectively? So that's one of the things that we are doing. And the other thing that you mentioned about regulations and so on, so actually we are also partnering with some collaborators in the UK to try to introduce or give more visibility to responsible AI practices around mental health in particular. And we actually are developing some guidelines for policymakers. So we are also active in this area. I would be happy to talk more about everything that you said, but it's in our research right now. Yeah.
Thank you very much. Okay, so 5-minute break, get up, coffee, stretch legs, and then we're back for the lightning talks, which will be really exciting. Okay. Hello, hello. Oh, hi everyone. Okay, so if we could make our way back to our seats, please, for the lightning talks, that would be fantastic. So maybe the robot job. Thank you, ladies and gentlemen. If we could take a seat, we got to get started on the lightning talk. Thank you. I'm sure the dog is going to stay until lunch as well. There'll be lots more opportunity to play with it. Yeah, the dog. Okay, so now for the lightning talks, we're going to have a new presenter, a new MC, Nemo Shi, who's here on behalf of Ethos, who are co-running this event with us. So, Nemo, I've really been looking forward to these lightning talks. When you're ready, take it away. We're really excited to see them and see what Ethos has been cooking up.
Thank you so much, Rory, and thank you for the Thinking About Thinking's partnership to make this conference happen. My name is Nemo. I'm a startup funder, community builder, and also co-founder of Ethos, which is an AI hub, a nonprofit and social benefit organization. In this lightning talk session, you will hear from about 15 researchers, founders, and friends of from the Ethos community as they share their visions, the problem they are working on solving, and also the solution they're building responsibly. So who we are. As the name suggests, Ethos, we are a value-driven community of AI innovators working in a shared physical space to exchange knowledge and then to support each other and advance technology in ethical and responsible ways. We have 4 pillars with our ethos. First is innovation with purpose. We support founders who are creating solutions to make changes in a meaningful way for the planet and the lives of people. And we bring in collective community intelligence and community resources to help them grow. And second of all, we encourage integrity and responsibility. Ethical AI is at the very core of what our startups do, integrated into their business and also their product development lifecycle by design. And then third is service mentality. So we are building a community of a caring community, rebuilding that trust in our social connections and also in this ecosystem. We encourage contribution to each other's growth. And last but not least, we are a community of inclusivity. We are sector agnostic, believing that the diversity and outside of the box thinkers are the true engines for innovations. So responsible AI is really at the core of what we do. We foster value-driven culture within our startup community and also are developing toolkits that are practical to help founders to do the same thing with their ventures and within their teams. We also convene practitioners and policymakers, like the one we did 2 months ago with American Center of Entrepreneurship from DC and the Berlin government to talk about AI regulations and to develop the successful case studies on how to promote responsible AI practices. And the third, we are right now assembling expert councils in verticals to advise industry leaders and produce case studies on responsible AI practices. And last, we are engaging with broader communities and citizens to include their voices in responsible AI conversations and leveraging their feedback to guide our initiatives. In Cambridge, we have been mobilizing resources, including computing resources, GPUs, legals, finances, and so on and so forth. And recently, we've been established our physical community in Berlin, Germany, where we're collaborating with the Berlin government to build an AI innovation ecosystem there. We've launched an expert council to advise on this effort, specifically around creating a bridge for AI innovation and healthcare innovation between Boston and Berlin. Many similar conversations are underway as we look forward to building our global trusted network of AI innovation community. Wherever you are as an innovator, we want Ethos to feel like a home for you and your venture and also your research. So we invite you to join us in this mission because our corner of human experience, creating this campus to support innovators, require activity at multiple levels to be effective. We need big functioning campuses, much like those in like universities, and also we need focused, energized, and exceptional groups of people tackling real content of the things that matter. Such things as supporting AI entrepreneurs and founders and researchers to achieve and to do it in a pro-social ways. So these are the QR codes. You can join us if you're experts, if you're founders, if you're researchers. We would love to include you in our orbit. And next up, which is the important part of this session, is to celebrate the innovations from the community. And I want to give this stage to our first founder, David, who's building AI and a navigation system on water. So let's give it up. Round of applause to David.
Thank you. Thank you, Nemo. How many people are boaters out there? Anybody? Anybody have a good boating story? So boating turns out to be incredibly dangerous, about 13 times per hour more dangerous than driving. And we're building a co-pilot, an AI co-pilot, to help make boating safer. So we trained the system on a lot of things that you shouldn't hit on the water. And we are using 3 neural networks in order to help spot and highlight those things for the captain. So we're using a multi-object tracker, scene segmentation to understand what is water and what is not water, and then a monocular distance estimation network to figure out what the closing time is to that object that you shouldn't hit. We could use existing cameras that are on boats, and we can use existing thermal cameras that are on boats. They tend to be very expensive, so we built our own camera. It replaces the light that sits high on the boat and has a night vision camera, a daylight high-res camera that can zoom, and a 360 camera, kind of like a GoPro below, to see all the way around the boat and see things coming up on your rear. So that's what it used to look like. So this is what it feels like out on the water. The camera sits high on the boat, and we use the screen that's existing on the boat in order to show you this information. So we highlight and classify other boats, buoys, lateral channel markers, and use Fusion to figure out the chart said it was here, but you see it over here. Paddle borders, we put the center line of the channel on the water. So we're basically trying to paint the world with information that makes boating easier and safer. Now, this is especially important for boats like fast foiling boats that have deeper draft and they go faster, and the consequences of hitting stuff, I won't swear, is quite high. We're also working on finding mammals so that boats don't hit mammals like the right whale population, and trying to embed as many cameras as we can on Viking yachts and other fishing vessels. We use a 3D simulation engine. We were using Unity to kind of make the 3D world everywhere and spatially anchor 3D objects to it. But the real challenge for the company, and if you're an engineer, I'd love to talk to you about how do we fuse computer vision data that we see, chart data, AIS targets, radar targets, bathymetric underwater data, and also cloud data. So when one boat sees something, other boats can benefit from that. To highlight objects, to mark things that are chart data in the world, to show shallows, to show paths, and to understand the collision regulation. So if someone's coming at me and they're showing their port side of the boat, I know that I have to be behind that boat. So the rules of the road are really important to express. We're funded by Rich Miner from Google Ventures, also other MIT, Wharton, Angels, and looking for data fusion engineers and other boaters and boat clubs if you know any. Thank you.
Hello, my name is Kimo Gandel. I'm a 3L at Harvard Law School running a legal technology company. I'm going to split this presentation in two. The first, I'm going to show you our basic product, what it does, and then I'm going to show you one of the difficult challenges it addresses, specifically in LLM. So basically, we are a arbitration provider. Does anybody know what arbitration is here? Raise your hand. Nope. Okay. Well, Most of us probably hate it. It's an alternative dispute resolution mechanism. Basically, think about it as a privatized judge. Often people pursue this because they don't want to actually go into litigation. Litigation sucks, trust me. Can definitely tell you as a law student, nobody wants to do that. And so we have a very basic subscription model. Companies pay per contract, and then they're able to use the arbitrator as much as they need to. And here's just a very quick video. Let's see. The video is not. Oh, and now it does want to play. Sweet. So basically, you're able to upload everything. The LLM will summarize it. It'll allow you to do briefs. It'll allow you to browse the different documents uploaded. It'll conduct discovery. Once discovery is subsumed, it'll ask you any key factual questions, and then eventually it'll produce a binding opinion. Now, the big question here, obviously everyone's probably asking, is about decision making. We actually use traditional machine learning for that. Because you don't want LLMs making all your immediate decisions. But I think one of the most important discussions on a practical element is how to deploy an LLM model effectively and cost effectively. One of the reasons for that is using an agentic methodology to prevent hallucinations can get very expensive and very time consuming if you don't consider how to deploy it properly. So let's dive into one of the most difficult problems here, which is how to resolve LLM deployment. So you can deploy models locally. Most of them are very large. We're thinking in our context, Llama 3.1. There's different optimization techniques that allow for easier local deployment. I don't think I have enough time to actually show an example of that. But simple reason, if you have a lot of data you need pre-processed, it's often better to run it locally because then you're paying mostly on time and electricity and upfront costs as opposed to paying per token. And so, for example,
Okay. Perfect. And then do we have a timer going? Yes. Okay. Awesome. Well, hi, everyone. It's great to meet you. My name is Jenna Winokur. I'm a current student at Harvard's Graduate School of Education, and I'm also working at MIT's PKG Center for Public Service on our Ideas Social Innovation Challenge. Since coming to Cambridge, my partner and I have also decided to start a company with one of our mentors that is focusing on AI preservation of cultural wisdom and heritage, and the ethical collection of data in the Global South. I'll pass it over to you.
Yeah, beautiful. Hi, Thomas Baker, formerly the CTO of Applied General Intelligence. My background is more on the technical side. And part of this actually came from some experimentations with collective reasoning and how to understand and develop collective reasoning, and what data we need to access to be able to develop it. So we'll kind of get into that right now, but also the ability to preserve and protect cultural and heritological data needs to be fundamental for as these LLMs advance and as this technology advances. So.
Yeah, so the problem, the technical problem that we're trying to solve is the fact that there is currently just a lack of more diverse human reasoning data out there. Most of the data that current LLMs are trained on is scraping from explicit data that's captured on the internet, and there's an assumption or a hypothesis out there that actually 99% of human knowledge is not currently written down. So we are kind of on a mission, ideally, to try and harness a lot of that wisdom and a lot of that knowledge that's passed down in different regions and cultures, more orally or in traditions. And so part of that is using AI. Oh, that's weird. Part of that is using AI to kind of understand the processes of linguistics there, and the nuances in how you parse that data. So we have kind of our own proprietary approach for structuring those interviews, which we'll get into in a bit. Well, wait, do you want to go back to the technical solution?
Yeah, we have more slides on the technical solution, but I know for the sake of time, there's a lot to get into, so feel free, we can talk about this more, and we can come up and have discussions about the same mathematics and so the methods we're using. But from this technical perspective, collecting this effective human reasoning data can be done in a multitude of ways, but like one of the other presentations mentioned, is there's a ton of language in facial understanding, there's a ton of language in dialects, and to be able to separate and parse and understand those dialects is a phenomenal way to start understanding that data.
So just one quote we pulled out from the World Bank to summarize a bit about why this problem is important is recognizing that AI applications must fit specific community needs and context to ensure their effectiveness and sustainability. Training AI systems in local languages, incorporating region-specific knowledge into AI models, and adapting interfaces to local customs are all crucial steps. So something I hope that you all kind of walk away from this presentation with is thinking about how you can do that as AI innovators in the projects that you're working on as well.
Beautiful. And so if, without diving too far into this, because I know this is a much larger discussion with a lot of the experts in the room who are very well aware of some of the, I wouldn't say failures, but challenges that we're facing with LLMs specifically. The ability to collect this functional reasoning data, you can start homogenizing the data at larger training sets and larger parameters, right? So one of the ways to do so is you can effectively shift between the tacit knowledge collection and explicit tacit knowledge collection, or explicit knowledge collection, and be able to validate that against the sets and the practices that you're able to kind of extrapolate. So again, keeping an eye on the time, we'll move on to the solution. So part of this for starting is always with these cases expert in the loop, right? We are partnering with a few more governments, I would say.
Universities?
Yeah, universities and governments in Africa and Northern Africa and the Middle East as well, who are facing a lot of these problems. The ability to identify wisdom and understand how to classify it is one thing, and so our system goes through and is able to collect context structures and set up meta-context structures to be able to do so and build a functional relational database that is able to match these. And then it's validated with local experts to be able to do so up until the training set is understood to have a subset of patterns of recognitions that we're able to apply faster and faster. At least that's how our current system works, and there are a few more advancements coming in the future. So the AI agent is able to flag this implicit. No. Okay, good deal. All right, I realize we should, also keep an eye on the time here for, diving into the actual math. But for the wisdom in collection platform, right now we have a system that is able to effectively overlay on a function of WhatsApp as well as video comms. And so when you're talking, just like you would, or video calling your grandparents, you're able to, if they have a separate dialect, you're actually able to identify and parse that dialect and flag it. And so our system is able to autonomously flag that and be validated by experts, of linguists and anthropologists, and those who are government officiates for that field of understanding.
Yep.
And we have a full functioning app that's able to do so.
And I think we will just end by saying a quick ask that we'll send out there is we're early on in our production. We have a few government contracts, but we're really open to feedback and insight that you might be able to share. So please come talk to us if this is something that's of interest to you. And finally, I'm putting together an AI in the Global South conference specifically focused on education applications. If you are a partner and would be interested in talking to me about partnerships there, please come find me.
Looking forward to it. Thank you so much.
Hey everyone, and thanks for coming. So I'm Tanay Wakare. I'm currently a computer science PhD student at MIT, and I'm co-founder and CEO at Prompt Inversion, a boutique AI consultancy. So today I'll be discussing prompt injection attacks. What are they? Why should we care? What do we think is going to happen in the next few years? And what are some of the solutions to them? So prompts are really the fundamental way that we interact with LLMs. So you go to ChatGPT, you give it a prompt, it spits out an answer. And in a lot of use cases, this is the only way that you can interact with an LLM. But it turns out that LLMs are super sensitive to the actual wording of your prompts, and you can get them to do a lot of things that they're really not supposed to do. So here, ChatGPT is actually telling you how to build a bomb in extreme detail. And it's really not supposed to do that. If you ask it, hey, ChatGPT, how do I build a bomb? It'll just say, I'm a helpful AI assistant. I can't tell you. But if you kind of guilt trip it a bit, if you like try and persuade it and tell it like, hey, I'll get fired by, like my boss is gonna fire me this week if you don't tell me, you can actually work your way around this, and you can actually persuade them a lot like humans. And this is a really different type of cybersecurity attack than previous modalities. So there's a lot of ways to do this, and prompt injections basically just mean prompts which force GPT to do things that you don't want it to do. And they're really sensitive to the actual prompts. So it's kind of a mix of art and science. And there's a lot of ways that you can do this. Another interesting one is algorithmically. So you can actually create nonsense-looking strings that will also give you harmful output. So here it's like, how do I commit identity theft cult? So it tells you both how to like create a cult and also how to commit identity theft for everyone. And the key point is that there's a lot of random looking punctuation in here. And so with this random looking punctuation, something breaks inside GPT and it acts in a way that we really don't expect it to. And this seems to be a pretty inherent vulnerability to language models. Like they seem like you can keep patching these prompt injection attacks, but then you can find new ways to create them. So there's some algorithms that actually can create adversarial prompts, and you just feed this into ChatGPT or an LLM of your choice, and it just provides harmful output. So why does this matter? Because LLMs are getting more and more integrated into everyday life, and we think the next step change is really going to be the introduction of agents. So you've probably heard about agents during this conference, quite a few times maybe. But these are going to be LLMs with access to tools and permissions on your computer. And so suddenly all of these problems with ChatGPT become much worse when these agents have access to your computer. Like what if it can download unverified files and suddenly you just have 100 viruses and your computer is a brick? Or what if it has access to your email inbox and it suddenly emails every single person that you've ever talked to? So these are real issues that we have to think about, and prompt injections are the primary attack method if you don't have access to the internals of the LLM. It's really the only way to interact with an LLM system in the wild. And we're really kind of in the Wild West era. It's like in the first days of the internet, you could just hack the government if you wanted to, like see what NASA's up to. And right now it kind of feels like that way because a lot of enterprises have deployed LLMs in the wild, and you can prompt inject them. So there's people are thinking about this issue, but it's really very nascent. Like, what are the solutions? So Llama Guard is an example of what's called a guardrails product. So this filters your input prompt and the output separately to check if they're harmful. So it can say, oh, your prompt is trying to convince me how to like commit identity theft. Like, I know that's going to be a harmful request, so I'm just going to reject the prompt. Or it can say, I can give it some really crazy, like, random-looking prompt, but the output is, how do I commit identity theft? And so your guardrails product reads that output and says, okay, it's harmful output. I'm going to reject this. So Meta's kind of built more of an ecosystem around Llama, and they're pushing Llama Guard pretty heavily. But all of these guardrail products are still kind of in their infancy. So if we go to so some of the solutions that they're actually incorporating are like perplexity filters. So this rejects random looking strings all the time. And so this is kind of meant to address these like random looking algorithmically generated jailbreaks. But this does reject some like useful prompts that you would want to actually answer. And then we can take the prompt, and prompt injections are very sensitive to the exact wording, the exact punctuation, the exact special characters you use. So you could ask an LLM, like, hey, reword this prompt, and usually that kind of destroys the like prompt injection harmful behavior. And custom retokenization is another version of this. So you can, but the issue is these kind of degrade performance because you're rewriting the prompt, you might lose some of the user's initial meaning. So there's kind of a whole, like, there are a bunch of security issues with LLMs that are popping up all over the place now. I'd be happy to chat about this afterwards. And so what has our team done with this? So our team our core team is 2 PhD students in AI, 2 ML engineers. And so we discovered and published the phenomenon of twin prompts. So this is 2 prompts that give you the same output. One makes sense in English, and one just looks like nonsense, or it has random characters. And we showed that this isn't just for like adversarial behaviors, but this applies across a whole wide range of settings, that you can find these kind of twin prompts that look random, but give you like reasonable English language output. And internally, we've been developing like a security product where we red team LLMs automatically. We're starting to set up different attacks and different classes of attacks and see how can we break your LLM. And we're also thinking about defenses as we go. So yeah, thank you so much for coming.
Thank you. Just gonna put on a timer here, so I'll keep you in a good track. Here we go. Hello, everyone. Let's just move on here. Okay, my name is Fred Heiding. I'm a postdoctoral researcher at the Harvard Kennedy School working with cybersecurity and AI. Today we'll talk about one of my research streams, which is AI-enabled phishing attacks, and primarily how to evaluate the capability of AI models to launch phishing attacks right now, compared to how good they were last year and how good we think they will be next year. So phishing attacks to start with is these emails. Most of you have probably gotten them. It's different types of scam. They might want you to press a link to download something, or they want you to upload your credit card information. But in a summary, phishing is some sort of a cyber attacker who wants you to press a link and do something that's bad for you. So it's kind of a psychological trick. One thing that's worth to note is that a really good phishing email is actually the same as a marketing email. They look the same anyway. The only difference is the intention. So phishing is malicious and marketing is not malicious. This makes it tricky to identify which one is good and bad for spam filters and so forth, which is pretty problematic. Anyway, in this study, it's pretty simple. We send out a bunch of emails from 4 different groups. So we have a control group, which is just arbitrary spam emails. They don't really matter for this talk. But then we have human expert-generated emails. So one of my collaborators is a very prestigious phishing and cybersecurity professor. He wrote a bunch of books about how to scam people and so forth. So we basically use this. We have some human experts, and we create really, really good phishing emails, and then we send them out to a bunch of human participants, and we track how many people interact with these emails. So these are kind of costly emails to make. The human experts went online and they Googled information about the targets. So for example, me, they would Google Fred Heiding, they find out that I'm a Harvard researcher interested in cybersecurity, and then they tailor a message that's very suited for me to increase the chance of me pressing it. For the AI automated emails, the third group in our study, We did the exact same things, but completely automated. So we have a tool. It's pretty cool that we build. The tool can be integrated with all the big frontier models. And the tool automatically uses some browser scaffolding, so it goes online, it searches 2 to 10 Google pages, and it automatically saturates when it finds out that it has enough information. So it creates a vulnerability profile. Then it takes that profile, and it creates an email targeted to that person. It also creates a synthetic sender. So for me, it would probably create a sender that's a research collaborator, and it creates a really good email and send it out. So this is all automated. Then we have one fourth group, which is a combination of the two. So it's an AI automated process, but when this AI tool goes online and scrapes information about a person, we have a human in the loop. So a human can stop and correct any mistakes that were made, and also before the email is sent out, the human can stop and correct any mistakes that are made. So why we compare this is, again, we want to see how many people fall for these scams that are created by humans versus AI. It's pretty cool. This year, for the first time ever, AI actually performed on par with human experts, which is problematic for a lot of different reasons. Of course, first of all, these attacks historically, you needed to make a trade-off. Either you had really bad scams that were cheap to generate, you can send a bunch of them, but the click-through rate, the success rate is very, very low. Or you had good scams that were tailored and targeted, but they're expensive, so you can't send so many. Right now, you don't really need to make that trade-off, as we see here. It's very cheap to create high-quality scams. We have a little graph to predict. Again, this is our research that we did last year. We have a pretty controlled setup, so we're going to do this every year continuously to just see how much better the AI models are getting. And it's quite likely to believe that next year AI models will actually be more deceptive than humans, which has a lot of problems in a lot of different angles. We just talk about scams and spam here, but AI deception is, of course, problematic for a lot of other reasons than that. Another way we evaluate the success of this work is that when we have the human-in-the-loop interventions, again, when AI generates these emails, we sometimes let a human stop and see, do we want to change this email? Is it spelling errors? Is the logic wrong? And so forth. And we classify this very simply to say that if we don't change anything at all, we give it a 5. If we need to change a lot of things, we give it a 1. And we released a white paper recently. All the information is in there. I'm not going to go into that now. But the important thing is that last year, the human in the loops, the experts, they always modify the emails. Because they're experts. They're really good at this, and the AI models weren't that good. So they changed the structure of the email. They changed the persuasion technique, the influence technique, and so forth. These things they sound trivial, but they're pretty tricky, because you need to have a really good way to influence and persuade people. This year, the humans, the experts, they almost never changed the emails. So the emails were almost perfect from scratch. The AI is getting really good. Of course, we hypothesize that next year, the human in the loop can be removed completely, and you never need a human to improve AI-based deception. This is a pretty simple economic calculation, just an overview. We have a pretty deep economic calculation and modeling of how AI affects the cybersecurity landscape in our white paper. And we do this every year to see how the economic incentives change over time. The big part here, which I work a lot about, because I also do some policy recommendations for this, is that AI-enabled phishing attacks are really, really cheap right now. They have been expensive to launch good, but they're getting really cheap. And this is a problem for a lot of reasons. For example, in the US, we have a bunch of sanctions against North Korea because we don't want them to create nuclear missiles. However, North Korea is estimated to get up to 10% of their GDP through cyber attacks. That's a real large amount. And a lot of these cyber attacks are enabled by scams and phishing emails. And now we see here in our research that phishing gets up to 50 times cheaper to launch. Well, it's quite easy to believe that foreign states and other scammers will improve and do this a lot more. So this is quite problematic, and the numbers are really against the defenders here, because we can add defense layers, but we're talking about humans. So in other technical areas, AI benefits attackers and defenders symmetrically. But with human targets, you can't patch the human brains, right? They're old mental heuristics that we hack here, so we can't change that so easily. So the defenders has a disadvantage in the case of scams. And the last thing, before I let you go, is some countering things. I'm talking more about the problem today, but we work a lot with mitigation as well. We do enhance current spam filters. Again, it's really, really difficult because modern scam look exactly the same as marketing emails. So you have to look at metadata, which you can, but it's also very easy to purchase new domains and create new sender burner email addresses. So it's really difficult for spam filters to do this. And even if you get 90+%, the remaining percent can be very dangerous for organizations. We work with personalized spam filters. I'm pretty excited about this. So when we learn people's vulnerability profiles, our AI model is pretty good at finding out, for example, me, I may fall for one type of persuasion, because there are different persuasion techniques out there. And another person fall for another persuasion technique. And then you can filter out emails. They may be legitimate or bad, but you can flag emails using a certain persuasion technique. So that's pretty cool. And we have a digital footprint cleaner, which is our last tool. That sort of helps you say what information do you have available online. Most people have a lot of information available online, and help users find out what can you remove and what information is most valuable to attackers. So that's about it. That was 8 minutes. Thank you so much. And if you're interested, we have a white paper. I can give you that.
Hi, everyone. I'm Mireia Torelló. I'm CEO and co-founder of AI Create. When we founded AI Create, we imagined a world where teachers and students, they don't just use AI, but they really understand how it works. So at AI Create, what we do is we teach them to create their own AI models and think critically, just like a pilot that not only learns how to fly a plane, but it also learns how it engineer it. And because we think that being a passive passenger today is not an option. AI is transforming the daily life from students, and we think that the students that are not prepared for this new era are at risk of being left behind in a world they cannot shape and they cannot understand. And we start our journey 8 years ago in our family-founded school in Barcelona, established 54 years ago. It's a project-based learning school, and we start teaching AI literacy from a humanistic point of view. And then slowly we build up the whole AI literacy curriculum from scratch. And then our project was accepted here in the prestigious MIT bootcamp, and we decided to establish AI Create here in the Boston area. Our vision is to make AI literacy accessible to all middle and high schools around the world. What we want is that our students are able to understand what is AI, to build their own AI models, and to be ethical leaders in this world. We use our teaching method is a blended technology. We use like Zoom online lessons, and also we have our own apps that they are responsible across devices. And we also use on-site for AI hackathons and AI bootcamps. What we think is that students need to learn AI with hand-on tools. And then we have designed our very hand-on tools and interactive tools so students can think and develop critical thinking and problem-solving skills. We also have our self-learning based game app where the students can go and learn through challenges, and also they can create AI models using their devices as the tools. And also we have a community, so we think that it's very important that students work from students around the world, creating AI challenges. And for teachers, we've offered online training, and also we have a dashboard so that they can follow the progress of the students, and they can also assign lessons to the students. And what makes us different is what we do is we do what we call our dual thinking methodology, which combines the critical technique of AI skills such as math, stats, coding, and AI development, together with critical thinking and imagination, which are the skills that need because in order to solve problems that machines cannot resolve alone. And also we have our all fine-tuned large language model, which we use because from our experience we have seen that not all the kids like coding, so we can teach them how to create their own AI models with prompt engineering. And also this our Create prompt, what it does as well is explore, and it's also a 24/7 support for teachers and students because it has our AI literacy curriculum. And we are making a big impact. We are working with educational institutions here in the US, in Mexico, Panama, Costa Rica, Brazil, Spain, and Israel. And also our own clients has brought us students from university and also like C-level executives. So right now we are rebranding, we are making a new website in order to be able to explain that we are offers these services. And also we are on an open B2C. Right now we are B2B, we are working with the schools, after schools programs, like the kids from corporates and then governments and NGOs. But yeah, so we are expanding. And then we have global recognition awards. We won last year the second positions in the special AI track in the JES Awards. And this year we were finalists in the North American JES Awards. And we have our advisory board has key people from MIT Media Lab, from Babson College, and also the ex-head of the JES Awards at the Mindset. Thank you so much for your attention. And if you want to join the AI revolution in education, you can scan the QR code. Thank you.
Hey everyone, I'm Trevor, the founder of CodeApt. We're building an AI code generation tool for full stack TypeScript specifically. And at the core of our product is a multi-step agent pipeline. And everyone's talking about LLM agents, but what does this really mean? So it means internal conversations between the application and the LLM where the user isn't necessarily part of the core loop. And one example of this is that if you ask ChatGPT to find some information, you might not tell it to search the web, but it might go and agentically search the web for you. And we've actually spent thousands of hours on figuring out how to best utilize these LLM pipelines in the code generation space. And I'm going to talk about a few of the most important lessons that we've learned from that process. So the first one is that we want to give LLMs as few possible actions as possible. So it's really tempting to go and pass a task to an LLM, give it a whole bunch of things that it can do, a huge number of actions, and expect it to choose the best series of actions. But if they could do that, I think we would already have AGI. So we have to take these models that aren't quite as smart as a human yet and kind of guide them through a process in a more well-defined way. And so how we do that is we use a pipeline of smaller steps. Rather than saying, hey, you can do A, you can do B, you can do C, you have all these options, we say you can do A or move on to the next step, and then do B or move on to the next step. And one example of how that looks in the code generation space is that in generating code, you have to do things like list files, read files, write files, and then test the change. But it doesn't make sense to read a file until you've listed the available files to read. So those go into separate steps in the CodeApp pipeline. So breaking it down into steps really helps the LLM kind of have more accurate results at each step. And that leads to more accurate results in the overall pipeline as well. So the second lesson is to populate as little context as possible while making sure that you still have the right context in the context window. And so the purpose of giving the LLM context is usually to override the default behavior, to override what answers the LLM would give you just based on training data. An example of this in CodeGen is, so we work on the Next.js stack. The user might have asked to add a login page, for example, and there's a bunch of SDKs inside Next.js that the LLM has to write code for to build this login page. By default, it might use an old version of Next.js, which is way more prevalent in the training data. And so we need to make sure it has the documentation for the latest version of Next that we're building on top of. So we need that information about how to build a page in the context window. But if we go and we put all the documentation of Next.js into the context window, it's actually so much that it'll start to ignore the context. So you need to strike this middle ground of putting just the right context at the right time without too much. And this actually ties in very nicely to the pipeline I talked about in the last slide as well, because if you break down the actions, you can also break down the context needed for each action. And so this kind of brings up the question of how do you get the right context at the right time, which leads to number 3, which is to consider more creative ways of doing RAG, some more creative ways of choosing what context goes into the context window. It's tempting here to say, hey, LLM, what do you need to know to create a page for a Next.js application? But often the LLM will kind of respond with, well, I don't need anything because I already know in my training data how to do that, even though it doesn't know there's a new version of Next that we're building on and it doesn't quite know how to build for that. So one trick that we use at Codapt is we actually let the LLM start hallucinating. We let it start trying to write this login page or do whatever it wants to do, and then you can pattern recognize against the hallucination to derive an intent from that. So we can see, okay, it's trying to create a form, trying to create a page. We're going to throw away this conversation, but take those intents, populate the context into a new conversation with just the right information. So how do you create a form in the latest version of Next? Similarly, for anything else it's trying to do, start a new conversation where from the beginning it had that right context, and then it emits much more accurate information. So instead of saying, hey, LLM, you know, what do you need for this? Tell me what you need. We're figuring it out in a more tricky way, which works really well with LLMs at their current accuracy levels. And so most importantly is to be able to iterate on your LLM pipeline as quickly as possible. So these are all lessons that we learned for our code generation application by going through dozens and dozens of different kind of pipeline layouts, different amounts of tasks in one step versus split into different steps. And so setting up your engineering team's tooling so that you have different abstractions and can iterate very quickly is kind of the key to figuring this out. So, you know, models are changing, new versions of models are coming out. It's not an exact science. With every new model that comes out, a different pipeline layout will work better. And so just set up your team to iterate quickly, and then you can kind of stay on top of the accuracy curve as things change. Yep, so that's what I've got. If you're interested in AI code gen or agentic pipelines in general, please do reach out. Thank you so much.
All right. Next up is myself. So my name is Albert Chen. I'm a AI strategist and prompt engineer working with nonprofits, startups, and businesses. I also partner with Tanay and his team to Jedi mind trick chatbots, and I'm apparently the resident AI productivity guru at Athos. So today I'll be talking about the how and for what of prompt engineering. And for those who speak Spanish, that's the el cómo y para qué. So how many of you are familiar with prompt engineering? Raise your hands. Okay. How many of you are not familiar with prompt engineering? All right. So for the 3 of you in the room and everyone else who's too ashamed to raise their hands, this talk is for you. Everyone else, stick around for the jokes. So prompt engineering, we got a couple of things, and this is hotly debated, and everyone likes to complain about prompt engineers on LinkedIn. But what I'm going to use is essentially the prompt is how we talk to generative AI. Prompting technique is this idea of like creating a template and setting things up, and the prompt engineering is how you improve upon that. Now, I'd rather just show you. So, for instance, a prompt could be, help me create a presentation on prompt engineering. Now, if I were to prompt engineer that, it would probably look something more like this, right? Where I'm asking it to take on a role, being very clear about the topic, the channel, who's my audience, what's the task, what's the format, what's my goal, and what are the parameters. I want it to include humor, right? And then what you end up with is, something like this where, it gives you a nice hook where, I tell a joke in the beginning and, I tell about how amazing prompt engineering is. And then if I wanted to, I could take this and throw it into other products like Gamma that just turns this into a whole presentation. And then that's the end of my talk. Thank you. No. What I want to do is dive a little bit deeper into that. And what does it mean to actually prompt engineer that? And so this is, instead of the algorithmic and automated prompt engineering that you've probably heard a lot about during this whole conference, this is how I kind of manually prompt engineer. And I think this is actually quite underappreciated because in the real world, you don't always have the data to do lots of scaled prompt engineering. And so, you got all the typical things of like structuring the data and all that, but I think there's a whole underappreciated area, which is like approaching prompt engineering from more a cognitive psychology perspective or more emotional based. And I love what Andrea and Agata had shared earlier, because it really talks, if you take that lens and think about it from prompt engineering, you unlock a lot more capabilities. at the same time of using all these frameworks to improve on prompts, you could also use it to exploit prompts in LLMs. And so the same thing can be used to gaslight, manipulate, social engineer. We talked about security just now, and that's one of the easiest ways to trick LLM is to gaslight it. And so, you know, armed with all this knowledge, I said, I'm going to go and I'm using AI for everything that I do. So this is an example of me prepping for my 10-year anniversary. You know, in Boston, everyone knows who's lived in Boston in the summer. It's really hot and humid, so I wanted someplace that's climate controlled. And essentially what I got with Perplexity was a bunch of storage units that it recommended. And I asked myself, what went wrong here? Like, did I ask for storage units? And if I go back, I realize I mentioned nothing about romantic or wedding, right? So whose fault is it, right, that I had to spend my anniversary here? Now, granted, Fortress is actually a better option, so that turned out better. No. At the end of the day, right, the problem is AI wants to give you what it thinks you want, right? And so Amanda Askell, you know, called that a sycophancy, right, where it's just going to please you. And so if it's trying to just fulfill the task that you asked for it and not what you actually wanted, the way to counter that is by being very clear and unambiguous about, you know, what you want, give it context, expectations, all that prompting stuff that you know. But this led me to another question. What if what I wanted isn't necessarily the best answer, right? And so I saw these articles recently, which is, you know, couples are using ChatGPT to fight, right? And so let's say, oh, yeah, this is a great use case if that's what you wanted to win an argument. Fortunately, my wife and I, we do use ChatGPT, but to resolve our arguments after the fact, well long after the fact. And I asked myself, is there a way to actually utilize AI to help improve our relationship, not just for me to win an argument, which is not going to actually make the relationship better. And so I dug into AI and be like, okay, wait, what's wrong with it? Well, yeah, it's got one-sided content. You know, it's going to just tell me what I want to hear and not necessarily tell me what I need to hear. And so, you know, one weekend I decided, you know, I'm going to build myself the perfect pre-prompt that will allow me to actually have it mediate my fight when I'm not in the heat of the moment and super angry and just want to do an angry prompt. It's like the same thing about like texting at 2 a.m. You probably don't want to do that. And so, you know, I created a simple thing that simply has two different sides inputted into a single AI that doesn't show the other person what's going on. And through a ridiculously long prompt, I have it go through a psychoanalysis of what everyone's feeling, their needs, all those things. And then what it outputs is XML that gets extracted and then sent separately to each person, starting off with a thoughtful acknowledgement of their feelings, followed up with insights that you probably need to hear but didn't want to hear, but it's helpful to hear it from a bot that's like uninvolved. And then some personal advice, helping nudge you a little bit closer towards reconciliation. And then finally, if your heart is finally softened, a suggested response that you can tell the partner or person that you're fighting with. Now, at the end of the day, right, I asked this question, like, what can prompt engineering solve by going beyond what people want to what they truly need? And at the end of the day, I wanted reconciliation, so that's why I built this thing. But there's prompt engineering opens up the door to approaching problems slightly differently and thinking beyond just the immediate request that I'm asking for. So, yeah. I'd love to chat if you have your own issues with prompt engineering that you'd like to solve, or you just want to nerd out about LLMs. Thank you.
Let me start the timer. And we're off. Nope. Nope. There we are. So my name is Waleed. I am a founder and CEO of Mako, and you are going to learn about GPU kernels today. So first, you know, this one's a gimme, but how many people have used ChatGPT? Probably everybody. How many people know that all of these AI models run on GPUs and know what GPUs are, know NVIDIA, that kind? How many people know what a GPU kernel is or have heard of CUDA? Good. How many people have written a CUDA kernel? Let's talk after. Find me. GPU kernels are incredibly important. GPU kernels are how we take an AI model and convert that into the code that actually runs on the GPU. Now this matters because an AI model, as I'm sure many of you are aware, is actually just a bunch of math. It's a bunch of linear algebra. So when you type into ChatGPT the question, hey, how are you? Can I just hear some guesses from the crowd how many math operations it takes for it to return, hi, I'm good, I'm ChatGPT? 1 million. How many? 10 trillion. Any other guesses? One more guess. A few billion. 50 billion. The answer is actually, our friend in the front is the closest. It is 30 trillion math operations happen in the few seconds it takes. And that includes the time it takes for, when you hit enter, for that sentence to be transferred to a data center that has thousands and thousands of GPUs, for your sentence to run through those GPUs, and for all those math operations to take place, for it to generate another sentence, and for it to send that back to you. So the GPU kernel is the order in which these math operations happen. Now 30 trillion, you think, holy crap, right? Like, that's a lot. What's actually happening, and this is a really small example too, so Nano GPT is about, what, 20 million times smaller than ChatGPT? And in this example alone, from the very first segment of Nano GPT, you can see all these green arrows and all these blue arrows pointing. Each of those is essentially a different math operation that happens. And so you can imagine, in something that's 20 million times bigger than this, how you get to your 30 trillion math operations to get your result. Now the GPU kernel, like I mentioned, is how you order the math that needs to happen. Doing 30 trillion operations one at a time, you could say, hey, hello, and get your answer, what, 6 hours later? 6 days later? That wouldn't be very useful. So the GPU kernel is actually very akin to, you know, a factory floor layout. The GPU being the factory, the layout of the factory being how you order all the different math. Now, there are a million different ways to do the layout of a specific factory. You have the warehouse, which is all the materials. You can have a factory line. You can have multiple factory lines. You can have multiple different kinds of people. And to design a GPU kernel properly is to design the most optimal layout of the factory floor. And when it comes to doing 30 trillion operations, very small changes in efficiency have very dramatic impacts on performance, on the time it takes for a result to get back, and ultimately on the cost of deploying an AI model or the cost of making some sort of an AI product. So innovations in how we write GPU kernels and how GPU kernels are deployed directly impact how available and accessible AI is today. Actually, in 2012, there was a specific GPU kernel written by somebody named Alex, which literally started this whole deep learning thing. What we do at Mako is we are using AI to generate optimal GPU kernels. So you can kind of think of the way of designing a kernel as a search problem. Essentially, there are thousands, millions of different ways to lay out the factory, and one of those ways is the fastest. A lot of those ways are the slowest. And whatever way you have right now, you can imagine different tweaks you can do to improve performance by 2%, 5%, 50%, 100% even. So what we do at Mako is we use AI-powered search to identify and automatically generate better GPU kernels. Search ultimately has 3 different components to it. There's the search space, which is all the different possible options, the search strategy, which is a proposal for a solution, and then the evaluation strategy, which is how you evaluate that proposed solution, and then you decide where to go from there. We actually use AI in every single step of the process. We use generative AI to propose solutions. We use neural networks to do comparative latency estimation. And end-to-end, what you end up with is a system that can actually use AI to improve AI. And why does it matter again? GPU kernel optimization has such dramatic impacts on cost. These are real examples from a customer that we're working with. They were running a model called Flux. They're running it on about 4,000 NVIDIA H100s. They're running at a very large scale with a 2% improvement in GPU kernel utilization. They end up saving over $1.3 million a year. Using our software, we're able to get a 47% improvement, which with the same exact model, no changes to the model, same exact hardware, you can run the same amount of AI on 2,700 GPUs instead of 4,000. And this ends up saving you $22 million annually. So the GPU kernel, you know, it's the little thing that a lot of people never touch in their lives, but it really is massively important, especially when it comes to the implications, the affordability, the availability of AI. So if any of you care about GPU kernels, if any of you know what a compiler is or what the difference between LLVM and VLLM is, come talk to me.
Hello, everyone. So I'm Kachina Studer. I work in the mechanical engineering department at MIT. I work in the LEAP group, which is the Learning, Engineering, and Practice group under John Liu. And what we look at is how training and adaptability in manufacturing is going to affect the industry, and also how tools like AI and XR and co-robotics can be impactful. So with manufacturing and AI, we've kind of entered an era of technology where everything is evolving at a rapid pace. But that speed comes with a critical question, which is how can this technology truly benefit us and the people who work with it? Now, there are companies that are developing fully automated manufacturing processes, and this is referred to as lights out manufacturing or dark manufacturing, which kind of already sounds a little bit dystopian. But it's highly ambitious, and some industries are focused on it. This is going to have a profound impact on technological, economical, and social implications. So let's take a look at how we got here. So there have been a few industrial revolutions. Manufacturing 1.0, or the first industrial revolution, involved the mechanization of industry. So this is just bringing all of your processes from individual personal labor into using machines. Then we have the second industrial revolution, which is the mass production and assembly line. So that's actually very important to this transition in the industry now. We had the third industrial revolution, which is early robotics. These are very rigid. These are all designed for a specific action, and they're designed by people with the skill sets to do so. Now, we are in the fourth industrial revolution, which is manufacturing 2.0. And this is going to involve a fusion of AI, robotics, IoT, and big data. So when we see some of these advances, when we see some of these advances in industry, we actually have to look at where the industry is at now. And we do know that a lot of industry is still very task specific, and it leaves little room for human adaptability or input. Now, we have plenty of changing market conditions, and there are large impact events like COVID, which have required some retooling of industry. And this is not very easy to do. This is not very flexible. Industry can be very challenging to change. It's very expensive, and it requires a lot of retraining. So how do we build a flexible industry? Now, one of the advantages of the future that we're in right now is the use of AI and the ability to take things like sensors and robotics and take off-the-shelf robotics and turn them into industry applications of the future. Sorry, I have quite a bit of notes here. Okay. So for machining, that means flexibility of tasks. And previous industries meant that we need to change the assembly line, which is costly and time consuming. And then for humans, this also means we need to take a look at what workers are doing now and understand how they're impacted and how they're going to be adjusting their careers. So a quick look at the economics. McKinsey has estimated that it could add $3 trillion to global market GDP by 2030. But this is also meaning that we are maybe losing people's jobs. So MIT has done a study that said AI will replace 2 million manufacturing workers by 2025. But I do believe that there is time, because we can only replace humans if robots can complete complex manual labor at an effective cost. So what we're working with right now is a cost problem, an expert capture problem, so an understanding of where experts work in the industry and what they're capable of, and then a management problem. And we're moving towards more fast and affordable manufacturing, which would be able to provide tools for people to be more productive. But this is a challenge to balance. So I just want to take a quick look at some companies that are using this type of manufacturing process or working in this idea of lights out manufacturing. And so I have the first example here at Canon, which operates with very minimal human interaction. They are producing basically like fully autonomous, and their work is separate from humans' involvement in the process, both for the assembly line, but then also for quality inspection. Now, this only works for highly specialized facilities with specific output. And they are immensely efficient, but they do also have rigid structures. Now, this company here, Yasukawa from Japan, is actually focused on designing cobots, which are robots that are more flexible and interact with humans a lot more efficiently. So this leads to more flexibility and more ability to change manufacturing processes. And now an example of a manufacturing process that was supposed to be lights out and very, very automated and fully usable was Tesla. So in 2018, Tesla attempted to create a fully automated car manufacturing system with minimal human involvement. But this actually had some serious issues. So they faced significant challenges and delays and inefficiencies because robots lacked the ability to be flexible and adapt to unexpected situations. And this led to Elon Musk actually saying that humans are underrated. And in this case, I think that we needed a little bit more flexibility and problem-solving capacity to create the better production process. And he works on novel systems, and we're going to see this more in the future. So the way that production needs to operate, it needs to be more flexible and able to pivot to changes that are necessary. So I also wanted to just talk quickly about the research that I'm actually doing. So right now with the industry, we're talking about retiring workforce, training and upskilling, and a machine system gap. So these are all issues that we're currently seeing in the industry. And with the AI systems and the cobots that we're working with, we want to look at expert capture for dealing with the retiring workforce to create data sets that can be used by AI. Expert training, so the ability to understand how to use the expert knowledge along with expert capture, and then be able to put that into systems that can work both with humans and machines, and creating a new workforce, an intelligent collaborator, and the new machine that can be flexible to use. So I'm just going to speed things up here. Basically, what we know is that if we are fully automating systems, we do still need humans involved. We do need to still be flexible in our structures of production, and we need to be able to let the machines take care of the hard labor, the AI to take care of the data and processing and communication, and let people take care of the expert knowledge and decision making. Thank you.
Hi everyone. My name is Mihailo. I'm the founder at Bullseye. What we're basically trying to do at Bullseye is automate hardware design. The way I teach hardware design to my students, I first start by explaining hardware design is not programming. You're not writing a program, you're writing actually a very, very distributed system. There's a lot of components, they all need to be correctly implemented, but they also need to be in sync. And that's a very hard problem. There's no type system for timing interfaces. I can't just go to GitHub and pull some piece of hardware and expect it to work with the rest of my system like it does in software. And that really stopped any sort of package manager from appearing. We lost out in this open source ecosystem. And also there's a lot of different market pressures. You need to get to market fast, but also if you make a mistake, you lose like $100 million tape out. So you're pressed, on both sides. And for the past 40 plus years, there existed this dream of high-level synthesis. The idea was that one day we'll have a compiler that goes from high-level software to actual circuits, even back into the early 80s, right? And what we wanted from it is basically we need high-quality results. I need to get power-efficient, fast, low-cost circuits, right? But also I would like it to support my language. A lot of startups have attempted this, and they often pick very strange languages like Haskell or OCaml, which don't have a lot of adoption, right? We also want a couple of other properties like being time agnostic and so on. But that's not what I'm here to talk about. My background is in machine learning. I went to grad school for computer architecture in a computer architecture group, and my advisor taught me how to write circuits. And they're teaching me about primitives like combinatorial circuits, and I have a name for that in my language. I call them feed-forward neural networks. Harvard people use registers when they want to store small amounts of memory state. Well, we use recurrent neural networks. If you need a lot of memory, you might use DRAM, something with a port where you submit addresses, get some data back, right? Well, we have neural Turing machines for that. So, compared to the previous approach of writing a compiler that goes source to source, let's say Python to Verilog, what we're trying to do at Bullseye is pretty much give you an ML synthesis approach where instead of looking at your source at the source level, I run your program. I execute it on a lot of independent streams, and I build a database of inputs and output streams. And then I train a circuit that fits your behavior, but not necessarily your implementation. You can give me badly behaving code, as in poorly performing, and I will find that independently a new implementation for it, right? So the benefit here really is that we scale with compute where compilers don't. As in, I can always shovel more GPU time at a problem to get a faster, higher performance, lower cost circuit, where compilers often just run out of passes and they're done. Also, data really separates us from implementation. So I can work with Fortran or JavaScript. I don't really care as long as it's an executable. And I can always keep retraining to get to fit any of your other specifications, like maybe you need radiation tolerance and so on. So our approach basically replaces the compiler in the middle with a very specific kind of neural networks that can learn circuits. And that is where a lot of the research comes in. How do you manage to get that? Because circuits are strange. And I'll get to that in a moment. But just to give you kind of a use case example, posits are an alternative to floating points. We've worked with a startup that wanted to develop a posit-based GPU. And we really don't want to write a posit unit. There are some open source implementations, but just writing 32-bit addition with posits is like 200 lines of very hard to debug Verilog. However, there is an open source software implementation on GitHub where I can hook it up in 10 lines just to say, like, give me random posits, add them up, feed it as data, and I'll find you a circuit. And we get pretty competitive circuits just by training DNNs to mimic a piece of, open source software out there. So, for the meat of the talk, basically, I would like to convince you that this is actually really, really hard. You can't just throw data at a problem and get the circuit back. First problem is that we have pretty much infinitely sized data sets. A 64-bit adder has 2 to the 128 possible inputs, right? So my program, I don't see this whole nice landscape. What I see is only the points where I actually do some evaluations of the program, right? And they're often incomplete. My outputs are often discrete, as in we're trying to do gradient-based optimization on a problem that very much is kind of piecewise linear. Verification is very difficult. How will you confirm that a little corner of this landscape does not actually match the actual specification. Discretization is difficult. I have a DNN. I need to end up with a circuit. I'm trying to use gradient descent to make a circuit that is not differentiable anymore. So that's an interesting problem. And finally, kind of, there's theoretical issues in that not all programs are learnable. AES is an example. If I tell you that I'm able to learn AES, that means that I'm able to learn cryptography from input-output pairs, plain text, ciphertext pairs, right? Which obviously doesn't work. And there are some tricks that we can do, like test point insertion into programs and so on. But I guess for the AI folks, the interesting part is that circuits are just weird. They're very deep and very sparse. Just a 4-bit multiplier, if you look at it the right way, the only way to learn just a 4-bit multiplier is with something like a 10-layer neural network. So you can imagine that most circuits for any useful piece of hardware are thousands of layers deep and extremely, extremely sparse. Density is just not a benefit to us. So you need a whole new category of kind of deep learning primitives to get this to work, which I will not go into much. So all right, I will forfeit the rest of my time, and thank you.
Okay, good morning, everyone. I'm Sebastian, CEO and founder at Amplified Industries. So if you've ever been on factories or oil field or mining facilities, you've probably seen that the industrial control systems out there, the electronic that runs machinery, is very clunky, outdated, extremely complicated to use, and the phone in your pocket is vastly more powerful, and no one ever read a 600-page manual to learn how to use a phone. On top of that, those industrial systems, so to give you an example, you take an oil field in the US, it's connected by dial-up speed connection. So those systems are sending very sparse data points, points every 15 minutes, every 30 minutes. Good enough to something is on fire, but that's, to know if something's on fire, but that's about it. And now you have, ubiquitous telecom everywhere. You can put a Starlink and get a 100 meg connection in the middle of the Arctic. So this is a problem because the US has about 1 million producing oil and gas wells, and almost all of them have no or extremely antique systems, which means they're very poorly controlled and they create a lot of spills. On top of that, the systems that are out there are extremely expensive to install, which means people only buy them on brand new well, and the vast majority of wells are not brand new. So to give you an idea, we're tackling about 500,000 wells in the US alone, which represent a very large market opportunity. So what did we go out to create? We've designed a software layer and a set of IoT hardware that are placed on the field that are designed to completely eliminate spills. And if you didn't know, most oil fields are actually water producing fields. You pump 10% oil, 90% water, but it's not drinkable water, it's mining water. It's brine, it's full of sulfur, of heavy metals, of all kinds of nasty stuff. And so spills are big issues, and you have millions of miles of pipes buried all over the place. So not only can we detect those at the surface, but also on all the lines that are buried everywhere. And sometimes people don't even know where their lines are buried, because some of those fields are, from the 50s, from the 30s, from the 1920s for the oldest one we're on. You also have to design a system that is designed to be deployed in very harsh conditions, right? -40 in North Dakota, plus, 50 Celsius in South Texas and everything in between. And that system has to be very hardened, but also beam a huge amount of data so that we can do very advanced analytic and math on top of it. So myself, I'm out of MIT. I was a PhD in aerospace over there. My co-founders are a PhD in mathematics, computer science engineer, as well as a former PE banker in the energy sector. So we started this company a couple years ago, and we set up to build this hardware, which looks a little bit like this. We have those little devices the size of a fixed cell phone that are instrumented on the wells, on the pump, on the compressors, on the tanks. All those big machineries have the little device that run on battery with over 15 years of battery life. They beam to each other the data, form a network, and then one of them sends it back to us. And then we're able to build the control system. So this is a system being installed. This is actually in Utah. Something people don't often consider is the cost of installing a system, the friction, is often the major problem. Even if your system is free, if it requires, to shut down everything, it will never be instrumented. So our system takes less than 10 minutes to install on any piece of machinery, and it doesn't require, certified technicians. So anyone can do it. So all those operators now have a system that is scalable. So the result of this is not only do we increase the machine efficiency by 8%, we've cut their power usage by 30%. And you're talking about, huge electrical motors and thousands of them running in the middle of the deserts. And we've eliminated 100% of the spills that our system is deployed on. So how much is that? To give you an idea of the scale, between January and September of this year, that's about 150 spills that we detected and automatically prevented. That's almost 1.5 million gallons. That's about 15% of the Exxon Valdez. And we're still a very small company. And that represents huge cleanup operations and fine avoided for the companies. So the way data works on the industrial system, without going into detail, is super complicated. You have industrial computer, pass it to one another, go through the radio network, and then eventually to their cloud. And companies are paying many softwares, many maintenance contracts, and by the time a data point reaches users, it's going to be very slow and it's going to be very expensive. Our system is straight from the device to the cloud to the user, which means not only is it tremendously faster, we're talking about over 1 million X in bandwidth increase, but also much more affordable, which means it can be scaled. So on the cloud is really where the magic happens, and the best way I can explain this is by beaming all the sensor information for those machines, the pressure, the level, the temperature, the current, the volts, the forces, the vibration, we get a full picture of what's happening to a machine. If you had just one sensor, that wouldn't be enough. But we build machine learning model and a lot of real-time control model that can be tuned to every individual machine automatically so that each of those machines is running in real time and so that we know exactly what happens to all the machines and to all the pipes that interconnect those machines. So we can tell when there's a crack, when there's a spill, if it's at the surface, if it's on the ground, if it's worn, and so on. So we've deployed over 2,000 systems out there, 2,000 machines. In the couple of years we've been around, and now we're in 10 states, North Dakota missing. So this is really taking off. The company is based in Boston. It's 20 of us right now and growing. So to summarize, we've built a system that allows to build, true machine learning capabilities on every piece of older industrial equipment out there. And that system has been designed to be very rugged and deployed in areas with very poor connectivity historically, and allows people to virtually, eliminate all the spills that were happening and clean up their operation and lower their carbon footprint. And that system is also future-proof. Now, there's no limit to how many applications we can roll out based on all the data we're collecting, and it can be scaled in many places. So, thank you.
How does it work? Okay. Hello, everyone. My name is Serge. I have a very important announcement to make to all of you. I stand between you and lunch. Right. Before I do anything, I'm going to introduce you to, so Ethos is a very beautiful community in Boston. I will introduce you to another community, and I would like to do it here. Everybody who has ever been to a Sunday hack, can you please raise your hand? Can you please stand up? So these beautiful humans are part of a community called Sunday. Alex, Sam, Ethos founder, but also part of Sunday. Nemo has been to a Sunday hack. Chris over there, Thomas, Jenna. After, when lunch begins, please go to them and ask them one thing. What is the strangest thing you use ChatGPT for? That's the prompt. That's what we always start Sundays with. Right, so let me tell you a little bit about myself and about what Sunday is. Whoever sees that corner, that flag, I'm originally from there. Most of my life I spent in another place over there. So it's very nice to have heard a lot of British accents here in this conference. Thank you for coming. Thank you for being here. It makes me feel at home. These days, I work here a lot. I work a lot on synthetic data generation with LLMs and with computer vision systems. In my past life, I've built companies. I really love open source, but sometimes I get into drones and fashion, not at the same time. And yeah, and I've done a lots of bunch of different things. I've traveled the world and been to Asia, built factory lines and Silicon Valley and so on. In that journey, I've met a bunch of people with fancy hats, and I had some tea with them. The strangest thing that you would learn about British royalty if you go to Buckingham Palace or St. James's Palace is they do not serve you milk, which was a big surprise for me. So that's the thing that I was shocked the most. Anyway, last but not least, I like to code, surf, and listen to music. Me and Chris were dancing last night until 11 p.m. or something. All right, Sunday. Sunday essentially is a hacker club. Ignore that statement. And I'm going to talk to you about what does it mean to be a hacker in the days of AI. Because what we do every single Sunday for the last 11 months, 48 Sundays back to back, we code AI apps with AI. And we try to put things into the user's hands by the end of the day. Over the course of this time, we've built a whole bunch of things that we've covered everything you can possibly think of, from agentic stuff to stable diffusion models, all different kinds of models. We've done guardrails, we've done video generation, full stack stuff. And so we've learned a lot. But the most important thing we've learned is to be a hacker is different than to be an engineer. So let's define what a hacker means, or what is a hack. A hack is an ingenious move or a shortcut. So when you have only one day to build an app and launch it into users' hands, you really have to think about it very well. Some people call hacks as bad things, and some people say a hacker is a person who just does impressive things fast. So most of us have done engineering degrees, or I guess a bunch of the room had done. So what makes a hacker different to an engineer? Well, a hacker is focused on being extremely fast. An engineer is focused on being meticulous and robust. A hacker always tries to use structure, and an engineer tries to build structure from scratch. And that's really an important thing to think about when you go to a hackathon or a Sunday hack. And hacker is very flexible and uses and prototypes things and doesn't really care if the thing dies like tomorrow, because what you want to do is to get a result today. Whereas an engineer is trying to build things that last for a long time. So if you ever go to a hackathon, if you come to Sunday, please do. There's lots of people in the room, they'll tell you what it is. What we try to do every Sunday is essentially find an existing structure, find something that's already working, and maybe change it in just one simple way to find a shortcut to build it. And the main rule of hacking, if you have very little time, is the 25% rule is you will always run out of time, like I probably will right now. Where is the timer? But so always plan to cut whatever you're doing. Last but not least, if you want to hack with Python is the easiest thing. If you know JavaScript, do that. Fast API Next.js is your best friend. Everything else is hard. And there are a bunch of things that we do at Sunday. We've learned a bunch of tools that are just extremely useful. So the first column there is probably the most useful. If you're going to be building models, replicate.com is your best friend. If you're going to be fine-tuning, if you're going to be doing RAG, use LangChain, or just build your own stuff. And we can tell you more if you come to a Sunday hack. So sunday.club, we hack every Sunday. If you're ever in Boston, come say hi. Thank you.
All right, can we give another round of applause to all the speakers? Just give us a presentation now. And so if you're interested in their approach, their solution, or their research, and we're putting up a slide here for you to get to know them and network together. And now we're moving to lunch. Rory, would you like to talk a little bit about how that works?
Yeah, absolutely. Thank you. And I just wanted to say, Serge, thanks for setting up the next talk, right? So Sam's going to be speaking about Pydantic, and Pydantic is a way for hackers to be better engineers without thinking much about it. So I think that was a great segue. So now we're going to have lunch. The restaurants are on the ground floor of the museum. We're going to come back here for 1 p.m. and then we're going to kind of kick off this expert AI and entrepreneurship session, which I'm really looking forward to. One thing that was just updated like last night is Christian from Fidelity is going to do like a mini panel on like how to actually get funded as a starter. So I think everyone that kind of gave a talk now, and if you're looking for funding, that would be a great place to go to learn the advice, but also to make some nice contacts. Okay, so we'll see everyone back here at 1. Speakers stay in the room because there's a little bit of lunch for the speakers. Okay, thank you.
Check.
Thank you for joining us today, everyone. At this time, we are going to ask any non-staff and presenters to make their way down to the cafeteria for lunch, and then we'll be welcome back in a little bit once the session resumes. Thank you so much. Hello, everyone. Just a final reminder, if you could please make your way downstairs to the cafeteria for lunch for all non-presenters and staff. All staff and presenters are welcome to stay here in the room. If you're not a staff person or presenter, please make your way downstairs to the lobby, Starbucks, or cafeteria. Thank you so much.
Hello, hello, testing. Okay, we're going to start in 5 minutes. So if everyone could make their way to their seats slowly, please, that would be much appreciated. Thank you. Hello, hello. Yeah, well, since everyone stopped talking so kindly, I think I'll use that opportunity to start off the next session for today. And we're getting close to the finish of the summit. We've been through Algorithms Day, Ethics and Society. This morning, we heard a lot of very interesting keynotes and talks that are kind of thinking about data, AI, robotics, how we might find useful applications for those in the real world. Now we've really got a superstar session. So we're going to hear 4 talks, and those 4 talks are by people who have all been successful entrepreneurs, who kind of have ambitious projects and visions, and they're going to tell you a bit about their products, but they're also going to tell you about their journey. So a lot to learn from there. And the best segue, I think, between data, coding, robotics, and AI and entrepreneurship is Sam Colvin. So Sam is one of the co-founders of Pydantic and Pydantic Logfire, which is one of those apps or kind of uses that once you know, then you cannot stop using it. And so people like OpenAI use it, people like Apple use it. I've heard it said that if you're not using Python yet, you should use Python. If you're not using Pydantic with Python yet, you should use Pydantic. And so I think many of the people in this room are independently coders and sort of will, now that, if they didn't know already, now they know. So Sam has a background in mechanical engineering, and I think I can sort of understand then how that translated into developing code and trying to make code work right. And so he's sort of been a founder as well and had kind of several successful companies and journeys. And we're really, really, really glad to have him today to give the talk, share your perspective on Pydantic, on the journey, but also maybe a few thoughts on being a sort of an engineer and then developer and then entrepreneur. So thank you very much, Sam.
Thank you very much. Yeah, so I created Pydantic originally back in 2017. So Pydantic is a data validation library for Python, not validation in the sense that many of you will think of it, but the dumb, boring, procedural data validation that you need whenever you're building an application. I'll show you an example in a minute. But Pydantic started long before Gen AI was even an idea, definitely long before I'd heard of it in 2017. I became a company when Sequoia backed me back in 2023, and we just released Logfire, so our commercial product earlier this year. Along the way, we also released Pydantic v2, which is a rewrite of Pydantic with the core all in Rust. So we got a somewhere between 5 and 50 times speed up. Is this talk recorded? Okay, I won't tell a story about one company and who told us not to. How big a company who I can't name, but who are a big company in the AI space, who we've talked about a lot today, use Pydantic very heavily. And when they migrated from Pydantic v1 to v2, they use, this is sort of, I'm going to identify them, but anyway, time to first token as their #1 reference on performance, and their time to first token reduced by 20% when they migrated from Pydantic v1 to v2. So that shows how much of the stuff going on inside established companies in the AI space is around Pydantic. So Pydantic is kind of ubiquitous. It's downloaded a bit over 300 million times a month right now. It's used by all of FANG, by OpenAI, by Anthropic, by anyone doing anything in, well, basically if you're using Python, you're probably using Pydantic. And I'll kind of explain why that is with a very simple example. So just before I get to that, I'd be interested in just a quick poll of the audience. How many people in this room write code of any kind, any language? So like 80%, 90%? And who's written some kind of Gen AI that's in production, actually serving people's, okay, so we've got like 5 hands. And how many of you have heard of or used Pydantic? Okay, so a bit more, cool. So some of this, to those of you who've used Pydantic, will be obvious, but I'm going to cover it anyway for those who haven't. So Pydantic solves dumb problems for smart people. So we take this example here. Hopefully, most of you can see that code. I can make it a bit bigger if not. It doesn't look like anything particularly special. We have a user with 3 fields. But the first interesting thing is that the way we define the types of those fields is using Python type annotations. So we haven't gone off and defined our own DSL to define type constraints. We use Python's typing system. That means it's much easier to learn, much easier to understand for anyone reading it, but also it works with static typing. If you've defined ID as an integer, your static type checker, your IDE will immediately know that that's supposed to be in it. So you can see in the code here, I've actually passed a string of 1, 2, 3 to the ID field. And even in my weird markdown setup, PyCharm is good enough to tell me that should be an integer. Same with date. I've passed it a string, which is an RFC 3339 valid date, but is otherwise a string. And again, my IDE is complaining. But the number one unusual thing about Pydantic, and something that people historically were very put off by, is it defaults to coercion. So it will attempt to convert types where it thinks that makes sense. So obviously the string 1, 2, 3, we can all see it makes sense as 123, the number. We can all see that date makes sense as a date. That is useful for lots of general purpose. I'm a developer, I'm just doing something lazy. But it becomes particularly important when we're doing things like parsing JSON. So Pydantic has built-in support for parsing JSON data. And that can be, again, we need at that point the coercion capability because JSON doesn't have a concept of dates, for example, or lots of higher order Python types. Even tuples can't be formally defined in JSON. So you need this coercion to be able to do JSON parsing. And I'll come back in a minute to why that's also very valuable in the AI space. And then the other thing that we added, so Pydantic, as I say, existed long before Gen AI. It was used mostly in API responses, was one of the most common ones. Sebastian Ramirez came along and used Pydantic as one of the foundations for Fast API, and it was actually him who first implemented JSON schema support because he wanted it as part of Fast API. So JSON schema is a protocol effectively for defining schema. It's a kind of boring subject in a sense because it's all abstract, but it is incredibly useful for defining how the shapes of data, the shapes of structured data. And of course, as many of you will know, after we had done all this work to have JSON schema and to have this lax coercion mode, suddenly Gen AI burst onto the scheme, and Pydantic was such an obvious choice for doing this. So over the last 2-3 years, well, I guess 2 years, every single agent framework and LLM library has started to use Pydantic. So it's used in the OpenAI SDK, the Anthropic SDK, LangChain, Llama Index, Crew AI, you name it, they're using Pydantic in particular, to do this. So we have the same user model defined here, and effectively this is just using the vanilla OpenAI SDK. We can define our tools, and we can define all of our tool using Pydantic. So we don't have to go and manually write out the JSON schema. We just define our Pydantic model. We use normal Python type hints, and we get, with in this case a little bit of plumbing, structured tool calling in OpenAI. So I'll just run that for you and show you roughly what that looks like. So if we look at, so this is the same code written out as Python, and you'll see if I choose to go and run it, and it works. That nothing particularly exciting you would see. We get the instance of the model here printed out. Maybe it'd be prettier if I printed it like that. If it's going to go and run, wait a bit of time, and we get back our structured response from this tool call. Not, you might say, particularly revolutionary on its own, but as part of tool calls are basically essential to doing anything beyond the standard ChatGPT exchange. So if you look at everything that OpenAI is doing with Google and Siri, if you look at everything Anthropic is doing with computer control, that is all implemented as tool calls. I think in the case of Anthropic, they're training the model on the specific tool calls they want for computer control, but OpenAI have made an enormous effort in tool calling because they know it's what everyone wants, and so those models are trained very heavily to be good at tool calling, and so you can give them relatively complex schemas as JSON schema, and they'll do a pretty good job of replying. But of course, A, you're getting back JSON from them, and B, that JSON is not 100% reliable, or rather where it is, they've gone and done Pydantic validation already. So even if it's not explicitly a Pydantic model, they've done validation using Pydantic either on their side or on the client side. And so, but again, that coercion comes in incredibly useful because AIs have a habit, or LLMs have a habit of getting things wrong. So confusing integers with strings either way around, and Pydantic is, doesn't even show you that that's an error. It just goes and fixes it. Another thing I didn't talk about, but I think is worth mentioning. If I, how are we doing on time? I've got lots of time, haven't I? Cool. So we can take this really simple example here, which is the very first example I showed you of Pydantic, and we go and create this instance of the Pydantic model. We get back what we expected to get back. But if we go and change this to no longer be a valid date, I can't remember if we do very early dates, so I'll make that definitely invalid. We get back, where it fails, Pydantic will give you back a nice error explaining what was wrong and what you need to do to fix the response. Now, obviously one of the regards in which we now kind of have incumbent advantage is that all of the LLMs are now trained on Pydantic error messages. So if you feed this response back to the LLM, if it gets it wrong, it's much better at fixing it than if you try and generate your own errors. And you even see some libraries trying to basically copy the text of Pydantic error messages to get, effectively, they've become the default for how you define schema errors. So going back to my slides. This is all very well, and this is kind of amazing that we can use Pydantic to do extraction. And obviously, we kind of have to remind ourselves, this seems so trivial now. If we were at a conference 3-4 years ago, this would be absolute state of the art, the idea that we could extract stuff from this sentence. Someone would have built their own model to do this. And yet now, obviously, mostly from the work of others, but also a bit Pydantic, that is trivial. But it's still a faff to go and define all of this. It's all very well in one simple tool call, but if you're trying to set up hundreds of these in an agent situation, it becomes annoying. So we just released, well, we only announced actually this. It seems like it's been longer, but only this Monday we announced Pydantic AI, which is our agent framework. So what is not in the content of my deck, but I think is worth saying, is that there is a fly in the ointment of Pydantic being used by all of these agent frameworks and LLM libraries, which is the code quality of them is pretty hideous. For the most part, they are built by AI researchers, let's say, not Python developers. And they no doubt push the boundaries on what you can do with AI, but they have developed such strong dislike by Python developers in such a short time. I've never seen that happen with any other piece of technology. I mean, MongoDB took 15 years to become as hated as LangChain has in 6 months or 8 months. And so we were very proud of how widely Pydantic was used, but we weren't particularly happy with trying to go and use any of these LLM libraries that we're using this. Unlike in web frameworks where there's Fast API that isn't perfect, but I have enormous respect for Sebastian and for what he's built, and I'm very happy building with Fast API. So we've just announced Pydantic AI. So this example shows exactly the same code. This is a kind of hello world example. So we defined our Pydantic model. We've then defined an agent, and we've said that the return type has to be user. We've given it, again, a system prompt and run it, and it will obviously give you back the model. Where Pydantic AI differs from most of the other agent frameworks is we are not particularly interested in making that first demo as easy as possible. We are interested in building something people can use in production. So things like agents are, in typing terms, generic in both the dependency type, which I'll show you in a moment, and the return type. So when you access result.data at the bottom there, the typing system knows that will be an instance of user. So if you access result.data.id, it will be green, and if you access result.data.foobar, it will give you an immediate error saying this is invalid. And things like that don't seem particularly helpful in the immediate demo, but become incredibly important in production situations where there is basically universal acceptance that things like strict typing make an enormous difference. So I will, for the sake of completeness, just go and run that example for you. And fingers crossed, it will do what I think it should, and sure enough, came back with a response. But that's really only the kind of hello world example of what Pydantic AI can do. So I talked about dependencies, or I touched on dependencies. These are incredibly important when you actually come to doing stuff in production. So in this case, we have this weather agent, and it has 2 tool calls registered. We register them with this, with this tool decorator, and we have get lat long, and we have get weather. And so you'll see at the bottom when we run this, we ask the model for the weather in London and in Wiltshire, and it needs to go and effectively convert London and Wiltshire into a latitude and longitude, and then call the weather tool to get the weather in those latitudes and longitudes. But that's not all, because inside those tool calls, we need access to, in this case, an HTTP client to go and make HTTP calls to the API that can convert locations into latitude, longitude, and also to get the weather. So the dependency injection system via, I won't go through all of it, but some wizardry with types and this run context. So run context is expected to be the fast argument to tool, and it is generic in the kind of deps. And if you pass the wrong deps annotation here, again, you would get a type checking error. You can get access to, you see deps.client, we can access that here and make our API call, but if, again, static typing can come along and help us if we get any of that stuff wrong. So again, when you're trying to build stuff in production, this kind of thing makes an enormous difference. And so I can come over here and I will run that example for you. Weather, here we are. I'm going to turn that off for now, and if I go and run it, it will churn away for, oh, I haven't got the API key set. Let me see if I can run it directly from the terminal here. So it's probably a bit small for you to see, but if I run this particular example, it will go away and churn doing something, we don't know quite what, and eventually it will return information saying that the weather, I don't know if you can all see that, but it does work, and it gives us back the weather in those 2 locations. But the next, this immediately leads to the other big problem of building stuff with building these agentic workflows, which is observability. I just showed you there, and it like sat and churned for a few seconds, and what was it doing? What exact system of sequence of steps did it make in terms of what calls was it making? And these are not things where they're going to take tens of milliseconds or tens of microseconds, and we can ignore the exact process. These LLM calls are slow enough that we care about the exact order. They're unreliable enough that we need to be able to understand what happens. And so that's where Logfire plays in, and where we think there's massive potential for Pydantic AI with Logfire. So Logfire is our observability platform. It's built on open telemetry, so again, built on open rails to allow you to monitor your application and debug it. And so if I come back to that same example, I'm going to make one change to this code. You can see all I'm going to do is import Logfire and call logfire.configure. That's enough to basically give us a view into our application when it's running. So if I run that example again, now instead of just waiting for 10 seconds, we get something in the terminal saying what was happening, but more importantly, we get Logfire itself giving us the sequence of, I don't know how easily you can see that, but like the sequence of exactly what happened within the agent call. So we got a structured response immediately. That structured response included 2 tool calls, 2 calls to get lat long. We can then go in and see exactly what was in those calls, what the information was that was returned by them. And we then went and made 2 calls to get weather for the 2 locations. And again, if we look at the top level of the call, you can see the full exchange of messages, what went on, and it's not scrolling for me because I'm zoomed in, but we can see exactly what happened. And obviously, the most useful immediate thing here is that we get our timing. We can see immediately what the sequence of what happened and where it was slow. If we had an exception that was raised, maybe I had the wrong API key, maybe I could run that quickly and break it to make the point. Let's say we spell API key wrong there, we run it again. We should see, you'll see it's immediately come up as red, and we can well, in this case, in fact, API key was seen as a security string, and so we actually have scrubbed that, and so you wouldn't get the full status message. but you can at least see what line the error happened on and go and investigate it. So I think we're pretty convinced from having built a number of agents ourselves that this observability piece is absolutely key. Going and building agents and just they're not like traditional code where you can just let them run and hope for the best, or be confident that they will behave. If they behave correctly once, that they will continue to behave correctly. They change over time, and so observability is key. Have I got a few minutes? I just want 2 minutes. I want to touch really quickly on Model Context Protocol, which was announced by Anthropic last week and is effectively kind of the next layer on from Pydantic AI. We will integrate with it, and it's basically the idea of you now have 3 nodes in your system. So you have the client itself, which is running. You have the LLM somewhere that's making that you're using to do the clever bit, but then you have these servers that you might call out to. So it might be Slack, let's say, or Google Drive or BigQuery that you want to be able to give your model access to. Till now, that involves enormous amounts of coding to go and effectively integrate with those APIs. You'll see there's lots of red squiggles here because this doesn't exist, and so my browser's complaining. But you could imagine in future, you could define an agent where you effectively add these tool sets using Model Context Protocol, and so you can give your agent access to systems, whether they be Slack, an open API, endpoint, or even the internet itself as a tool set, and it can dynamically decide what tools to register at which steps within a run. So yeah, thank you very much for listening. Have I got time for any questions?
Yeah, you get time for a question. So if anyone has a question for Sam, I'll also say we started off Ethics Day yesterday at the sort of micro scale, what individual AI researchers can do and how the effects of AI can hurt individuals. And I think this is a great example, right, of somewhere where an AI researcher should be always using this type of thing to make sure tool use isn't malicious. So any questions for Sam? We can take one, I think. Right at the back? Yeah, great.
Thank you so much for the incredible presentation. I just wanted to go back to what you'd said about 10, 15 minutes ago relating to the research coding standards. What do you think the industry can do to make sure that academia can keep up to date with the practices in industry?
I think that's a really hard problem, and it's been a hard problem for a long time. When I was at university doing CFD stuff, the bleeding edge of academia has not been good at being 5 minutes behind the curve. And that's for good reasons, right? Because it's more cynical, it requires a higher level of confidence than you do to go and start a startup. And so I don't think that academia should basically sacrifice itself at the altar of trying to be a startup and trying to be on the bleeding edge. There is good reason to use the right things that are coming along from startups and from industry, but also being cynical about them and not moving straight to them. And look, some bits of AI will turn out to have been, we'll look back on them like we look back on Web3, so I don't swear, I'll use the term Web3. As in, some of them are going to be bullshit, basically, and some of them are going to be like world-changing. And we don't know which ones they are necessarily. We can probably sniff at some of them, but I don't think I have an answer from academia other than to continue to be cynical about what's coming out of industry, but adopting the bits that seem obviously valuable. Cool.
Again, thank you very much. Next, we're going to hear from Kristen Kraft, and so Christian is from Fidelity, representing Fidelity, leads the private shares arm of Fidelity Investments. And when I was looking for speakers, I kind of found her profile, and I thought, oh my God, she's amazing. We've just got to have her. Kind of wasn't a funder herself, but is a founder, but is now in funding. And she messaged back and she said, look, I've got a better idea. Why don't I bring some friends and we'll have a panel and we'll actually tell you what you want to hear, which is how do you get funded? What are the best practices? What are the tricks? What are the best way to present yourself? So it's a pleasure to welcome Kristen and friends to kind of have this expert panel on how to raise funding in AI. So thank you very much.
traffic, so we're hoping that he's going to come in and join us, but it might just be Seb and myself. So we will hopefully share some insights on the fundraising piece. But this topic is so important. You know, as we all know, it takes capital to build something amazing. It takes capital to hire a team, to bring on talent, to retain talent. And it's a tricky time to raise money right now. That said, the best companies are still getting funded. I talk with founders every single day who are navigating and debating between different term sheets. A piece of good news very specific to this room is AI-based companies or companies that are leveraging AI in really intentional ways are seeing valuations that are 30% higher than those who are not. And, you know, I also spend a lot of time with LPs, you know, the sort of high net worth individuals, family offices, endowments that fuel and fund VC firms. And what they are thinking about is that they're looking for investment opportunities, like with amazing folks like Seb, who don't, you know, mimic what they've invested in the past. They don't want to be over-allocated on the stuff that they were investing in 10 years ago. They want to invest in new areas like AI. So I do think it's an exciting time for the folks in this room in particular. But I don't want to jump right in. So I would love to start by letting Seb share a little bit about himself, his work, to set the stage.
Thanks, Kristen. Can everybody hear me? Yeah, we're good. All right. So I always say yes to anything that Kristen invites me. She's wonderful. So I'm very, very happy to be here. Background, a business background, undergrad in Texas, did banking for 10 years, got bored, operated a company in Brazil, 6 weeks of cash left, we had to turn it around, publicly traded company. Then I went into private equity, learned how to invest and how to be an investor from the board perspective and select the right team and management team and support those teams. Then realized that the world's changing, technology is a huge accelerator on efficiencies, and decided to come here to MIT. Did 2 years here, focused on applied AI and entrepreneurship, and now we have a fund to support early stage companies building in the AI space. Awesome. And we are a team of four.
Thank you. And sort of similarly, for context, my own background is in the startup world. I founded a company myself coming out of undergrad at Brown, ran the business for a few years before going to MIT for business school, and then spent the next decade as an operator, but also as an angel investor, and as a mentor and advisor to startups. And at this point now, I'm helping to build out Fidelity's newest business unit, which is helping founders raise money. And we do that in 2 ways. One with cap table management to manage equity with Fidelity Private Shares, and the other, which is my favorite part of my job, you know, forging connections between founders and capital. All types of capital, whether it is you know, amazing folks like Seb at Milemark or high net worth individuals, family offices, corporates, you name it. And really like takes all of these pieces. So that's what we're going to dig into today is around sort of best practices for successfully raising capital. So digging into the questions that we wanted to get to today, you know, I guess just to set the stage, like why are you so bullish on investing in innovation in AI?
Yeah, so I guess it's 2 things. One, it's the productivity gains that the deployment of AI and ML models bring, but also combined with what we're able to do in this day and time, which is we're capturing a lot of data, we're able to process really quickly, we have access to cloud computing and compute power, and we're deriving insights that were there before, where we couldn't measure, or we couldn't estimate or infer, and some of those are beneficial in the business world. There's a self-selection of the people working in AI that want to tackle those problems with, in the form of a company. So for example, we're looking at a company that is doing, we've invested in a company, Piction Health, that does computer vision to identify skin diseases. They do it in 3 minutes. Now, if you think about where do we live in this, you know, the healthcare ecosystem here in the US, to get to a specialist could be 6 months. And then you're relying on the accuracy and the predisposition of that specialist. If you can turn that into a app where I upload my picture and I get a diagnosis really quickly, that's a huge efficiency, not only from the patient side, but also from the dermatology side, which are able to process a lot more patients on an hour.
I think that's such a great point. And I think like healthcare is a particularly compelling area in which to think about how AI can drive efficiency. On Monday, I was participating in a healthcare event here in Boston, and we had some really heavy hitters from the funding side, you know, corporate venture capital arms from Brigham Hospital, many different medical entities here in Boston, and this was the biggest topic that everybody wanted to dig into, was like, how should we be thinking about this? Like, where should we be investing? Where should we be thinking about future growth and downstream capital, which we will get to in a second. So thank you so much for sharing that perspective, Seb. And I think what I see every day is that different folks bring different areas of expertise to the fundraising process. Some folks really know their KPIs, they know their momentum and their traction metrics, but they're a little weaker on the storytelling. Some people are amazing at the storytelling and have the team. Some people have incredible connections, but maybe they're lacking elsewhere. And in reality, you kind of need to bring all of these ingredients to the table to have a successful fundraise. One thing that I do think is universally true and important, especially for those who are building companies, building early stage companies and raising early stage capital, is the way that you present your team. I mean, so often investors talk about the fact that for the first institutional raise, the team is almost the only thing that matters. Yes, of course the idea matters as well, but the team is sort of the most important thing to highlight and that an investor looks at. So I'm curious what is compelling to you when you're thinking about the team itself. What do you like to see about the founder or the founding team, or even the sort of extension, like the advisors who play a role there?
Yeah, so for us, I mean, the team I think is the most important one, but it has to be the right team with the right technology, in the right market, and the right timing. All those things have to be together. Of course, the team is going to take advantage of we call it the 4 T's. So the other 3 T's, they're gonna take advantage of that. So in the team, for us, it's, do they have the right combination that is required to migrate an academic idea from the academic world into the business world? They need to have technical expertise because this is very technical, but they also need to have the sales predisposition. They have to be able to explain in very simple terms what is it that their technology is enable. What is the world today, and what is the world going to be after the deployment and adoption of those technologies? So not only the technology, but user design, sales, and the individual traits is something very important. Is I need to see someone in that founder team that listens. Usually what happens, because everyone, and I made that mistake with my fund as well when I'm fundraising, but we get so excited about what we're building that we just download all the information that we think the other person wants to hear. When the founder is not asking questions to me or not receptive to the things that I'm asking, what it tells me is that they might be very lousy in PMR, primary market research, meaning they cannot listen to the customer. Maybe they cannot pivot. Maybe they cannot incorporate those ideas, because when you're putting something new out in the world, it's not going to be perfect. It will have some traction. It will wedge into an industry, but you need to form it in a way that has a lot of traction and scales. So that is super important. I found great startups with the TAM, the timing, the tech, but when the founders don't listen, it's a red flag, to be honest.
Yeah, thank you so much. I think that listening point is really important, and one kind of corollary observation that I will share that I hear from so many investors at all stages really, is they really only want to work with founders who will tell them the truth, not pulling any punches. Like your investors, your potential investors, they want to hear when things are going great, and they also want to hear when things are not going great, so that they can step in and help. And that is one of the mistakes that first-time founders, in my experience, make more frequently than serial entrepreneurs, because there, is a belief, understandably, that like you always need to be putting your sort of best face on when you're having conversations with investors. But trust and honesty is so critical.
Yeah, I think, yes, I agree. Once you have an investor, you're same team. And usually what we want to know is bad news first and immediately, so we can help, right? And that speaks really well of the team, speaks really well of the awareness that they have, because you're going to encounter problems. Nothing's going to be perfect, but if you are able to identify them early and seek help, then there's a chance you will solve it.
Yeah, great point. And we want to make sure that we're leaving you with a few kind of actionable nuggets that you can take with you as you are fundraising in the future. One idea that I might share, for those of you, if you are not doing this already, is think about launching a quarterly newsletter that you can share with supporters, potential investors. I work with hundreds, if not thousands, of founders, and I would estimate that like only about 10% of people do this. And generally speaking, most investors like to meet founders long before they ever decide to write a check. And so having a regular newsletter, this can be very straightforward. There are some great examples out there. But just having that kind of regularity, to Seb's point, helps an investor feel confident that there's a values alignment, and feel confident that they understand who you are, and feel comfortable making an investment there.
Absolutely. And it's also a good exercise for you to distill the main ideas and for you to communicate what are the areas that are going well, where you're focusing your effort, and it gives us a sense that you have a great grasp on what you're building. One of the traits we also look for founders is like, and this is not ours, I think I heard a partner at A16Z say this, they're like maze runners or experts. They can navigate the industry really well, and we are going in that journey with them because we feel guided. We know that they know their stuff really well, they know the players, they know how the industry operates, and we can support them. One of the best things or best traits that I like about founders is the ones that ask questions, they ask us what we think about it. They will ask our opinion, but they will do what they think is best for the company. And I really respect that. And I have more than 50% of the times founders come back to me and say like, Seb, I was really great conversation, made me think about the company, and I did the opposite of what you told me to do. Why? Because for my case, for this reason, I think it's best to go this route. And I feel really good about that because I helped the founder think and reach a much better conclusion.
That's a great point. So we touched on, what are the team attributes? What's the team makeup that helps you raise money successfully? Let's change gears for a second and talk about metrics and KPIs. Admittedly, in the earlier stages of a company, you might not have the metrics and KPIs you perhaps would like to show. You might be pre-revenue. You might even be pre-product when you're raising your first institutional round, and that is okay. For those who are raising an A, like generally speaking, you do need to have, unless you're in a really like COGS intensive industry, you really need to start being able to show those revenue metrics. But given your focus on the early stages, like what do you like to see in terms of numbers or even leading indicators?
Yeah, so yeah, we do pre-seed, usually pre-revenue. So they don't have those KPIs. And now we're preparing our valuation for our fund. Some of the companies don't have revenue yet. But I think it's the TAM, size of the market, has to be meaningful in the sense that if they're able, look, every fund wants one company to return the entire fund. Usually that translates into 50 to 70x increase in valuation after dilution, so it's 1 to 100. If we get an idea that's really good, it has traction, it has the technology, it has the right team, but the market is $1 billion, then let's say 10x multiple in revenue, that company needs to do 100 million. What's the possibility of this company to do 10% market share in that? It's really low, really hard. But if the market is 16 billion, it's 50 billion, and you have different routes to gain share there, then you can see it's more plausible for that to happen. And even when that company IPOs or is larger, the IPO investor also wants growth. So if you're IPOing at 10% market share and there's a chance of 20% market share, it's going to be a good IPO. But if you're already at 8% market share, even if you can jump markets, it's hard. So that's the one thing. And the other one is, do you have a good beachhead market strategy that will be a reference to grow into the larger market? So you have to operate in a large market, but you have to have a wedge. And that sequencing is also very important. Beachhead, and then how you expand into the adjacent markets.
I love that. I always get nervous when I talk with a founder who's like, oh, my TAM is like all of the United States. I'm like, no, too broad. So I think that's, even if that is the 10-year vision, having that beachhead and really demonstrating your own conviction and why you have that conviction about your ability to go after it is so important to the story. So, the final piece that I want to touch on vis-a-vis fundraising inputs is the sort of operational preparation. And, I'd be remiss if I didn't touch on this since we focus on cap table and data room. Forgive me if you know this already, but for those who maybe are doing this for the first time, these are pieces that you always need to have when you are going into fundraising. Oftentimes investors will expect to see your cap table in your data room. This is sort of the single source of truth about who owns what in the company. It also tends to house, bless you, like your IP, that kind of thing. Any other, meaningful elements that have value or create risk in the company. Those are important inputs when you are going into a fundraising conversation. And then on the back half, once you have a term sheet from an investor, the lawyers will step in and they will go through a thorough due diligence, going through all of the information about your company, especially ownership positions in your cap table with a fine-tooth comb. If lawyers find anything during that due diligence process, this can, at best, cost you a whole lot of money in legal fees to sort those items out. At worst, sometimes investors have pulled term sheets in that moment because it sort of erodes their confidence in the company. If anybody wants to talk about this further, this is our area of expertise, and happy to be a resource to any of you. Seb, when you are looking at a pitch deck, when you are looking at a data room, when you are looking at somebody's cap table, what instills confidence in you, either in terms of the items that are there in the cap table or data room, or even in terms of the way that they approach that preparation?
Yeah, so organization is, of course, easy for us to make the analysis and the diligence. It also speaks really good about the founders and the team and how they've thought about what an investor would want to see. And that's also a good proxy about they understand their company, their market, their challenges, and they can put it in a way, distill it in a way that is digestible. So that always helps. The other thing I would say is that if you're too technical with the investor, most likely we're going to feel dumb. And when you feel dumb, we don't want to invest because we're intimidated, right? And I have to do the same thing with my investors. I have to distill it, and I have to explain in very basic terms. So organization, the 4 T's, as I said, TAM, timing, tech, and team. That's very important. On tech, we specifically focus on defensibility, if it's proprietary, and can it scale. That's also very important. You need to think about how you're deploying your business and your technology for it to scale. The other very, very important thing is the size of the round and the use of proceeds. What do I mean by that? You want to know what's the average valuation of the stage you're in. Usually, if you look at PitchBook data, you know that a pre-seed here in the US is between 8 and 12 million. I think the West Coast is a little higher, but you need to be on those ranges. And you know that the average raise is also between 1 and 3. So seeing those ranges is important. Within that range, what I like to see is the least amount of money being raised, but optimized and maximized into deploying those funds to answer the most fundamental or existential question that the company needs to have an answer for to keep growing and surviving. Because you're testing something new, it's like an experiment. When you're done spending that money, you'll have an answer from the market. You've done pilots. You know where to go next. You will know what to tweak. You know what to build. You know where to go. You will have answers on the product, on the user, on the go-to-market strategy. You have something that nobody else has. So when I see in the deck use of proceeds, what I don't like to see, although it's the same thing, is like, oh, X% is going to go to salaries. Sorry, I have a call after this one. So yes, you're gonna spend on salaries. We know that, but the people that you're paying, they're working on something, even if it's yourselves, right? What is it that you're answering with the use of proceeds? That's super important, because at the end of that, you've spent all the money. You have answers on how the market works. You have less risk. The entire company has less risk, and less risk means higher valuation. So that's what we want to see as early stage investors. Can you chart a path into de-risking your business so the next round is successful?
Yeah, and just sort of adding on a very actionable suggestion here. Most of the best founders I work with have a slide. It doesn't have to be in your main investor pitch deck, but at least in your appendix that indicate exactly how you anticipate deploying that capital. Many founders even will earmark, like, I am going to hire this role, and this is the individual that I've already been in conversation with about this role. These are their salary expectations. Getting that granular, not that you need to go into that with every conversation, but demonstrating that you've thought about it, and being prepared to answer that question if and when the question does come up goes such a long way to indicate how you think about spending that money and really can de-risk that conversation with our investor. So I'll let you guide us. And okay to take a question from the audience? Okay. Is that okay with you?
Sure.
Okay. Awesome.
I have a quick one. Do you mind waiting for the mic just for the online? Oh, sure. Yeah. As a seed stage CEO, how much should I pay myself? So that my investor says, oh, he's judicial with the money and not overpaying, but also not starving.
That's the answer, actually. I want you focus on building the startup and not being worried about your rent, your transportation, your healthcare, everything. So the amount is very personal, but you need to pay yourself what makes you focus in the company and not outside. Maybe a little bit more because, life happens. But that's not something that we double click on, to be honest. Some CEOs are able to, don't pay themselves because it's a second or third company. That's fine too. But we want the team focus on building what they're intending to build.
Yes, hello, I'm Reginald Barkey. I'm an healthcare fellow at Harvard University. And entrepreneurial residence at Babson College. A question about term sheets. AI is very new to a lot of these older investors, but they want to get into it. Even the younger investors, and we all know that because it's such an early market, every single AI investment is very risky. Every single one, right? It's either very risky or somewhat risky, but a little bit higher risk because you have to actually go and sell it. And a lot of these folks are academics, and they're not salespeople. And then we spoke of earlier the gentleman who was speaking about they're not tech people either, they're AI researchers, etc. How do you see your flexibility in creating term sheets, in managing your risk at this level? For example, have you heard of a kind of term sheet where the investor gives a certain amount because you believe in the technology, but you're not sure whether I'm in healthcare, so whether folks at the hospital could really understand this as much, even though you know probably enterprise systems in hospitals might be going this way, or definitely going this way. So, yet you know as an investor, this is probably a great product. How do you hedge your risk in that kind of way where you know it's a great innovation, but you're not certain about the sales capability of the research team or the tech team or et cetera, et cetera? Is there a kind of term sheet where you can commit a certain amount of money and then invest as milestones and traction expands?
So that's a very good question, thanks. So one very important thing that you need to understand about funds, the way we hedge our risk is with diversification. We invest in 20, 30, 40, 50 companies. And we know one of them is gonna return the fund. 2, we're gonna get a great return. So that's how we are able to invest in risky value propositions, quote unquote, because we are diversifying on our end. If we're a good VC manager, we're doing that already. In the case of the specific company, I want that investor, that founder, to raise the least amount of money, but enough to get the answer to the question that they need. Whether that is, can I commercialize this? Will hospitals buy my product or not, right? And I've never seen a term, well, maybe. I don't think it's healthy to have term sheets that, disburse money with milestones. I think those milestones are called fundraising rounds. Your next one is the seed round. Your next one is Series A. And some investors do that, but they say, I'm a pre-seed to Series A investor.
And I would say, just to layer onto that, I would say that right now a disproportionate number of institutional investors are allocating capital in advance and earmarking that for follow-on investments. And so that is sort of like their mechanism to de-risk by putting a little bit in, and I think like it's okay to have a frank conversation about that, especially if an investor has given you a term sheet or indicates that they're going to. It's totally appropriate to say, hey, do you make follow-on investments? Like, what do you like to see to foster a sense of conviction when you're thinking about making a follow-on investment? It's an appropriate question to ask.
But I would add that pre-seed, you need to raise some saves. It's cheaper. You don't need to, pay a lawyer. Yeah. You can do that on the seed or Series A.
Great. Well, let's thank our panelists once again.
Thank you.
So not only a masterclass in investing, but I think a masterclass in public speaking as well. That was really wonderful to watch. So they told you who they are. They told you how to do it. So, it's up to you to connect those dots now. Thank you very much. So next, we're going to continue with a keynote by Dr. Anna Litvak-Henningsen. And so Anna is a successful serial entrepreneur, a member of the Harvard Business Review, and Chief AI Product Officer. And Anna was recommended to me by one of the very early guests that signed up and saw the group of people we had speaking, the types of topics, algorithms, application, and immediately recommended Anna to us. So we're very, very glad to have her with us today. We're looking forward to the talk, which is, again, very practical. It's how to make AI products and companies that work and they can get funded. So we're really looking forward to it, Anna. When you're ready, please do take it away.
Those geeks that been in the AI space for 20 years. I did my master's in computer vision and PhD in applied math, and I spent the last 18 years developing data science, machine learning, and AI-powered products across industries, including healthcare, consumer goods, and information technology. I am Chief AI Strategist and founder of Altec AI, which is a paraphrase of the alchemistry of AI. And at Altec AI, we provide AI education and AI strategy for product and for enterprise. So AI, I always, you know, as I said, I've been in AI for a minute, and I always talk about the fact that AI was not invented in 2022. It's been around for 70 years, since the 50s. And there were a lot of important developments in AI in the last 20 years with deep learning, and in the last 10 years, there were a lot of developments with natural language processing. And we just, in 2024, had some people winning Nobel Prizes for pioneering deep learning AI and pioneering various applications, such as the DeepMind's kind of AlphaFold that was like a follow-up from the AlphaGo and AlphaZero successes. So, but still, even though AI been around for a while, we are in a pivotal point in time where we have the democratization of AI with the latest development in natural language processing, generative AI, and conversational AI, allowing new opportunities that can really revolutionize the way we live and work, and will definitely impact every and any industry. And beyond kind of democratizing AI, the recent developments also enabling things that were never enabled before with technology. And we have some mind-blowing examples, and a lot of them are in the healthcare and medical space. We can really help patients to get better therapies and better life qualities with AI. And so I will share with you some kind of examples that I found mind-blowing. So for example, with generative AI, natural language AI, we have now all kind of applications that can read the mind, translate it to text, and then translate it to voice and to vision, helping patients have much better lives than before, by helping those who are visually impaired or speech impaired or hearing impaired. Just very recently, a few weeks ago, there was announced a partnership between Be My Eyes and Meta that helping people who are vision impaired or blind people to be able to manage better, almost see. So with the Meta glasses, they can really kind of be in a store or real life situation, and the AI describes to them what they're seeing and helping them out. But moreover, with the nonprofit Be My Eyes partnership, they are able to call in real time a volunteer that sees what they're supposed to be seeing through the Meta glasses and describe to them in real time what's going on and help them out. And even though there are a lot of mind-blowing applications to the medical field with AI, and I myself was fortunate to see it firsthand, because my team, in collaboration with Alexion and Radis Children's, developed an AI diagnosis assist tool that won the Guinness record for diagnosing rare diseases in newborns under 24 hours, saving lives using AI to diagnose rare diseases from genome sequencing. There are many such examples, such as personalized medicine, diagnostic, and therapies, especially for rare diseases and cancer therapies. But AI is really affecting every industry, and there are a lot of different examples. So, for example, in October, generative AI art piece that was painted by a humanoid robot of a portrait of no other than the grandfather of AI, Alan Turing, was sold for over $1 million at Sotheby's. There are a lot of opportunities with teaching and training. So Microsoft invested $1.7 billion to train people in Indonesia on skills of technology and AI, and they would upskill 2.5 million people in those skills of technology and AI, providing new possibilities of income and interesting work in that community. And all the training itself is also done with AI, personalized training in their own language. We hear more and more about investment in hardware in AI and robotic capabilities, robots for manufacturing, for warehousing, but also for helping you at home. And you know, there is recently also like a Polish competitor in the market that may kind of overcome Tesla's plans to come and sell you those robots that gonna help you to do tasks around the house, wash your dishes, fold your laundry, and even babysit your kids. Just kind of something small, mind-blowing as well, the Notebook LM of Google is a free tool that allows you to learn very effectively. And you can use it for children and adults. You can use it for generating content. So you can upload into Notebook LM PDFs, videos, books, pictures, and then ask it questions and learn. And also you can generate videos and podcasts that can even take your very scientific thesis and make it into a very kind of enticing 10 minutes podcast. And AI is going to change our economy by the end of this decade, and this is kind of predicted by many and already happening. And there are opportunities for every industry and every organization with AI along these main three avenues: product innovation, process automation, and communication. And we gave a lot of examples of AI-powered products and AI innovation in product, but the AI innovation in product can also happen in how we develop products, right? How we do the product management, the prototyping, and the product management lifecycle and software development lifecycle. We can automate all these repeatable tasks and make better processes and allow people to have free time for creativity and strategy. And communication is really definitely taking, like recent surveys show that 72% of adoption of AI in the recent year are around marketing and sales, because there are a lot of opportunity with communication in generating content and marketing collateral, but moreover, also in generating knowledge centers and learning opportunities and training. And the next big thing is predicted to be customer support. And despite all that, we have a lot of hurdles in developing AI applications, and research tells us that about over 80% of AI applications fail, and this has main three components of problems that happen that cause developing AI applications to be challenging. One is the technology issues, and the other one is the organizational issues, and the third one is the adoption or people issues. And so let's talk about the tech issues. So first of all, data science, machine learning, and AI applications are heavily dependent on data. So, and data is one of the hurdles in developing AI applications, because you need to have large amounts of data, you need to have quality data, you need to have data readiness, right? You need to have data sets that are appropriate for training AI models. You need to have data governance. You need to have labeling, because a lot of this training is done with labeled data. You need to be able to label your data. You need to be able to manage your data. A lot of the time, you have data, but it's in data silos, and you don't have it in one warehousing kind of place. So having all those, being aware of all those components of data is very important. And when you have the data, also kind of the model itself, model accuracy is very important. So now more than ever, the saying garbage in, garbage out is very correct, because data, quality, management, governance is essential and a big hurdle to develop successful AI applications. And then, of course, you need to have the model accuracy, and you need to monitor your model. And even if you already developed your model, AI models don't stay accurate forever. There is drift. And because of the data drift and context drift, you need to keep monitoring your model and keep retraining it, probably quarterly, but like you need to monitor and see when you need to retrain. Then you have, of course, the cybersecurity risks. You have various risks of getting ransom because of cybersecurity attacks, but also risk that relates to regulation because data privacy is very important, especially in regulated industries. So cybersecurity and data privacy are very important. And there are hurdles about developing AI application in regulated industry. And even if your company is not in a regulated industries, very likely that your client's company might be in regulated industry. So you need to make sure that you have in place all the right regulations, compliances, and data privacy in place. And of course, it's very important to develop ethical and AI, and there are legal concerns, such as, for example, because a lot of AI models, specifically the generative AI foundational models, are trained on publicly available data. You can unintentionally or intentionally infringe IP. For example, there are a lot of lawsuits going on. So you need to make sure that whatever you do with AI is ethical and not breaking not only regulations but also any legal requirements. And there is, of course, the technology risks of you need the right infrastructures. You need to have computational resources. You can use the cloud or in-house, but you need those heavy computational resources to develop AI applications. And you need some data warehousing solution, data pipelines, ETLs, and there are the AI risks themselves. So maybe your data is not biased because you actually managed to create good data sets, quality data sets, and you even maybe use synthetic data to make sure that your data is biased, because most of the AI applications today are deep learning AI applications. We don't know how deep learning AI actually forms its patterns because we don't fit to it in engineered features. We don't dictate the features. And even if we unbias the data intentionally, the application can still have biases that it kind of takes from the data, and we saw those examples like women being denied a credit line because of bias in the AI system that made this decision. Or we can have, like, when engineers trying to unbias AI system intentionally with some policy layers, we can have the opposite effect of changing the history and saying that the founding fathers of US also had mothers and all the different races, and changing history in other ways as well. So there are biases that is hard to predict and hard to treat. Hallucinations, context, for example, AI doesn't have context. If you look at this picture, right, if you don't give it the right context and you just say, make me a picture with a timeline, it doesn't know which year came first unless you kind of make sure that you provide. So you need to be very intentional with the instructions of how you build your AI. And of course, one of the biggest worries in AI is inappropriate use. So we can have also inappropriate use, intentional or unintentional. We can have, due to hallucination AI, like happened recently with Gemini, give like some hostile responses, but we can also have intentional or unintentional misuse of people using AI inappropriately for harm. And indeed, about 80% of AI initiatives fail. It's almost, and many researchers kind of tells us that. And this is because, and this is almost double than any other technology project. And this is because there are difficulties to articulate the value of AI, to build AI strategy that aligns with the overall business goals of the organization. There is a productization scaling up. Even if you manage to develop a prototype, it's very hard to productize or scale it throughout the organization. There are skill gaps. It's hard to hire those, the talent for AI development. And there are silos and collaboration gaps because it's essential to have the engineers and the data scientists and the business people in close collaboration from the get-go. And it's really important to provide the knowledge and the training, especially for the adoption, because the adoption gap is because stakeholder resistance, people don't want change. And on the other hand, it might be overrated expectations because not understanding of AI capabilities. Executives might say, we want to replace all of our task force with AI. Let's build it tomorrow, without understanding the complexities and the hurdles and how long it will take to implement that AI. And finally, people just don't like change and resistance. So that's why education is very, very important. So professional leadership, AI proficient leadership and AI literacy and training, demystifying AI, developing clear strategies and clear articulation of the AI value and how it aligns to overall business goals of your organization, and providing all the time the transparency, education, and why we're doing AI, how we do it, for what we're doing, through the implementation process and through the road mapping. It's very important for all of your stakeholders, your execs, your board, your clients, and throughout your organization and to your employees. Thank you.
For such a wonderful talk, and I think it was a really nice summary of the things we've been talking about over the last 3 days at the summit, and a really good time to have that too. So we can take a question for Anna, if anyone has one. Yeah, and especially because I didn't give you the question last time, so.
Hello, my name's Alvin. I'm a founding engineer at CodeFlash. We are using AI to optimize your code base. I was just curious, and this is just like a personal thought. You spend many years of your life kind of like building AI products for humans. There was an article I read about how the future is going to start looking like building products for AI, because there's going to be so many AI agents around. And so wondering if you have any thoughts on what that could look like.
Yeah. So that's a wonderful question. So you're talking about the fact that we're developing AI to help humans, but we might need to develop also AI products to help AI, such as AI agents, right? AI agents need to go to the doctor too. So, and that's correct. So like today, the same way that we're developing AI applications to develop products, develop software, monitor software, and fix bugs, that's essentially developing AI applications for software, right? So in similar way, we can develop AI tools to monitor AI agents. Like Sam, I think, before me spoke about how you need to have observability of AI agents. You have to have observability of every AI application. So you can build AI applications that observe, detect drift or fault in AI applications and even fix them. You can also develop AI applications that will apply the regulations and governance over other AI applications. There are today a lot of development around developing AI applications that do quality assessment and testing to other AI, detecting errors, detecting problems, etc. So, and this trend will just continue.
Thank you. So maybe while Dennis is setting up on the mic, we can take one more question for Anna. Does anyone else have a question? Yeah, please.
Yeah, so Anna, thank you for your presentation. The question that I have is a lot of time in political arena, right? There's a viewpoint, if it labeled as come from lab, and then you do the survey, and most of the left-leaning will give a favorable rating, but for the right, then it's different. And so I guess my question is, when a viewpoint is proposed, there's once it a dimension of label, then it can create some biases in terms of people judging that particular viewpoint. And when you apply to the language model, right now we're doing some labeling on the data. And I'm wondering whether there's a similar issue like that in terms of handling data when you need to label data in a certain format. Because by labeling it, you basically constrain the data into certain category. So that
well, because labeling is like a ground truth for the data sets and for training your models. Labeling of data is very important for the model development and how the model going to behave. So there are various approaches to labeling data to make sure that you avoid hurdles and biases. So first of all, there is crowdsourcing labeling that people use, and then you can use testing and some kind of golden sets, and there are today more and more AI applications for data labeling that you can kind of combine with then human feedback loops to make sure that the labeling is unbiased and provide you with the training that you're actually seeking. And I see that we need to go to the next talk, so happy to chat with you more about it later.
Thanks again, Anna. That was wonderful. Thank you. I'm sort of discovering that I can't clap while holding a mic, but thank you for leading that. Now we're going to have a keynote that I've been looking forward to for a long time, since the inception of this summit. And it's going to be given by Dennis Mortensen, who is a serial founder, is an interesting thinker, and has a sort of great spirit and energy that he brings to everything he does. He has the admirable title on the internet of Internet Personality, one that I would love to have at some point, but I'm not sure what quite defines it. And his a series of successful exits, and more recently has launched, founded, and is the CEO of Launch Brightly, which is a company that we're going to hear a bit about today, and taking product snapshots, something he thinks is a very important thing that's missing in the world. So Dennis, thank you so much for coming up from New York for this talk. We're really looking forward to it. When you're ready, take it away.
Sure. Thank you. Am I on? We good? Yes? Okay. Step one, a picture for my mom. Hands up, everybody. She fucking loves it. There you go. Thank you very much. Appreciate it. I will spin a story that you'll be part of later tonight. So, internet personality. Who said that? I'll add that to my CV. I didn't bring any slides, not because I'm lazy, but because I want you to pay attention. Because this might just turn into a small therapy session, mostly for me, of things which I did in the past that I'd rather not do in the future. If you agree, you will take note and not do what I did. So some of those stories will be based on prior ventures where that party is certainly over, done and dusted. We sent some monies back to the investors and no harm can be done. Anything which I say on my current venture will obviously be aggressively biased because I think it's fucking awesome and will make no mistakes. Now, the commentary that I will add today will be on the spectrum between you deciding if you build an AI product. And again, AI, right, is a funny little title that we've added. It's been called many things over the years, but you make a set of predictions for where you think the outcome of those predictions can turn into something of value for a set of users. And there's certainly one end for where you try to augment the qualities of a human trying to do a particular task. Then there's the idea of building some fully autonomous agent for where the user will say, hey agent, go do this particular job for me. Once done, come back to me and report that all was done as I had hoped for. It is not entirely black and white, and there's certainly some sort of gray area in between, but sometimes you'll have to make a decision early on in your venture whether your initial bet, even if you're on a path towards full autonomy, if you're going to be A or B. Now, why is this important? Or why do I think this is important? I think it's important because you'll have to both build your stack, assemble your team, invest the capital that you raised in different ways. And if you kind of turn left and you should have turned right, there might be some waste, or just the obvious, you go have this sudden instant death, which is the most likely outcome of all our ventures, by the way. The one venture we didn't do an exit on was the one venture that I self-funded. That's another story. Yeah, it still hurts. That was a damn expensive MBA, by the way. Imagine going home to your wife one day and say, hey, you like this apartment? It's not ours anymore. She was not happy. So I'm going to give you 4 things to have in mind. These are not necessarily the most important. It's just certain kind of moments where I walked that particular road and I turned left where I should have turned right. I think the first one, excuse me, would be this idea of whether the prediction you make is added value or whether the prediction itself is the product. And let me just add some extra color here. There's plenty of places where you can make a subpar prediction and it's still being of value. You go upload one of your photos to whatever photo platform you use, say Google Photos, there's 5 people in it, it's Christmas Eve, Google somehow picks out 3 out of the 5 people in the picture, that's a 60% accuracy. Thank you very much, all the added value. I can kind of search on my daughter, I can find her in a set of pictures, I'm happy. Now, then you work at some sort of self-driving car startup and you make a prediction, is this a plastic bag or a baby running into traffic? If you do that at 60% accuracy, that venture is now going far. But it's the same kind of level for where you need now to figure out if I exist in this kind of universe for where the prediction itself is the product. There's very little below 100% accuracy, whatever kind of precision recall you set up for this, for where you can survive. And sometimes there is no other way. That is the product. And you have to kind of accept that. It's a super dangerous territory to be in. And I'm only saying so because I jumped into that particular pool for only to later figure out that there was actually an option for where I could make predictions along the way that would just be value add. Ah, okay, Dennis, we'll take your 85%. I'll take you 90%. Shit, I'll take you 95%. Hey, you became fully autonomous at some point, but I kind of started in this end, and that was very expensive. Side note, speaking of very expensive, this is kind of, in my current venture, we are trying to do automated product screenshots. You do a software product, you need to kind of support it. To support it, you put a knowledge base in place, you write 400 articles, all 400 articles will be chock full of screenshots of that product that you're trying to support. Those screenshots today are taken by typically a technical writer or something like that who kind of owns the collateral. We're trying to replace that particular task with what is certainly for most people today a human task with a machine task. We can talk about that in detail. Our prior venture was this fully autonomous meeting scheduling agent. You CC in Amy or Andrew and say, hey, find some time for Suzanne, Tim, and I. Come in the next week for half an hour on Zoom, and Laney is optional. In that particular space, of course, as you can hear, there is no kind of credit for a meeting almost set up. Like, oh, good job, Dennis, we almost met. No, we just didn't meet. And I fucking hate your product, and I'm going to tell everybody on Twitter the same thing. That assembly of data to kind of make those predictions, because we went all in from day one, we had, and it's scary now when I think back to it, we had 101 exactly people doing annotation only. Like we hand-labeled a little bit above 32 million data points on about, in the end, 47 intents and 3 entities, like temporal, location, and people. It was a staggering amount of time and energy we put into that for where we had to if you wanted to be in this particular space. Now, that was point number 1. At least have it in mind as you kind of jump into the pool. Could there be some option here for where I could perhaps, at least initially, do value add predictions? Now, number 2, who owns the prediction? You make some prediction, and there's an idea of who owns the output here. Say, even just for a piece of software, I need to, I don't know, update the background on LinkedIn for my LinkedIn profile now that I'm an internet personality. I have figured out that is what 1584 pixels times 396 pixels, something like that. I take a picture, go into Photoshop, I crop it, it's a little bit off. At no point in this scenario do I assemble the anger to go to Twitter and say, fuck Adobe, this is off by 2 pixels. I very clearly understand I'm a Muppet and I can't figure out how to crop in Adobe Photoshop. It's on me, as in I'm the owner. That's not necessarily a prediction, but there's certainly plenty of places where you can somehow place a responsibility for the prediction on somebody. And I think it's not kosher if you are oblivious to who owns it. And there's plenty of places for where it's clear who owns the prediction, but sometimes you can also kind of make that call. And we can go back to our fully autonomous agent we did in our last venture, for where there's certainly one setting for where if I promise to do the job in full, and again, we can kind of create 2 buckets here, right? You can do tasks and you can do jobs. That's a little naive, right? And a job is some sort of list of tasks assembled together over time that does something to completion. Now, in that setting, I'm the owner, and I was the proud owner, and it was just not right for many reasons. When you're the owner, there's very little room to kind of outsource some of that responsibility. But you promised, Dennis, to set up this meeting. Here's a funny side note. It takes, we spent probably, on average, pre-us injecting the intelligent agent into the negotiation, it took 1.9 days across meeting types. So you have plenty of multi-participant meetings. Side note to side note, it is almost exponentially harder to do a meeting for every participant which you add. So it's somewhat easy to do an insert for yourself to do your taxes in April. It is somewhat harder to do a one-on-one meeting. It is quite hard to do a one-on-2. One-on-3, you're doing rocket science. One-on-4, that's just impossible, pretty much impossible. That's the space we operate in. So we took full responsibility. We took that from 1.9 days down to 1.7. All this kind of space in between, by the way, is just guests being fucking tardy. Like, come on, respond. But that delay and that kind of inability for them to kind of respond all fell on us, because we were the owners of those predictions. We then figured out through kind of clever product design and kind of what have you, to create a setting where it felt like the host, which we called our customers, owned the prediction, that I initiated this and I'm still responsible for kind of moving this forward. Simple things like, Tim didn't get back to us on the 2 tries. Should we remove him or do you want to follow up yourself? Like something where, I'm now an active participant in the negotiation and it's not just on Dennis to kind of solve this. That was the second point. Figure out who the owner is of your predictions. Number 3, you will never get to a point for where all of your predictions are running at 100% accuracy by whatever measure you put in place. You now need to decide who bears the burden of your poor predictions, because somebody needs to bear them. It could just be you and the software in some sort of fail state, or it could be some of the constituents who are attached to your software. Again, in our autonomous agent setting, we had a couple of constituents. There was certainly us as the agent, and then there was the guests, where there was a different set of flavors, and then there was the host, our customer, who would initiate and ask the agent to go to work. And it's just very easy, I'm sure, for all of us. If somebody gives you money, you kind of owe them something, right? It feels like you paid me some money to set up meetings for you. I should now try to not bother you too much. As in, I ask you to set it up. As in, side note, if I hire Tim, a human assistant, I ask him to set up a meeting between me and Fidelity. And he comes back to me. So who at Fidelity? She was on the thread. Okay, thank you, sorry. When should it be? I said next week. Okay, can we do it in the afternoon? Yeah, I guess. That is next week, isn't it? If he does that just enough time, at some point, Tim, you're not working here anymore. And that kind of feeling is what I wanted to inject into my agent as well, which is, don't bother the host. However, it took me years, it was stupid, but it took me years to figure out that the burden which we put then on the guest, which didn't give us any money, was the last person we should put the burden on. There was actually a very good case study which I read that kind of, to me was an epiphany in the moment. Now it just seemed like, Dennis, you figured out exactly 10 minutes into the venture. But eBay, many, many moons ago, who have kind of two primary constituents, right? Buyers and sellers. They make all their money on sellers, like 98 plus some percent. But you know what? In any kind of software design conflict or any kind of prioritization of resources which they need to kind of apply, they put the focus on buyers. Why? Because sellers don't give a shit if you bring them happy buyers. Like, this software, I hate it, but I'm making some money. It was the exact same thing in our particular setting where the host who asked us to set up meetings, I don't care about anything. Your software can kind of be clunky and what have you on my end as long as you bring me happy guests. It was an absolute sin to burden the guest. And here's a very funny thing. I should have brought a chart. So we ran like many things. For every step in the dialogue, people could rate it. 4.5 for host, 3.8 for guest or something like that, because the hosts were the ones that we kind of catered to. Then we flipped that around. Not, you don't do that overnight, but you make 100 little product changes so that you flipped it around. That meant our host was now, by their own score, less happy, it's not as good, I liked it more yesterday, and all of those things, but all of the metrics that mattered, as in they scheduled more meetings, retention increased, churn kind of decreased, even though they told us, yeah, I don't like it as much, but I'm keeping it. So that's point number 3. You somehow need to figure out where you place that burden, because there will be one. The last one, and again, these are not exhaustive. These are not necessarily the most important ones, but certainly had me think, when I sit alone at home in the dark, looking out the window thinking, why did it take you 2 bloody years to figure that out? We humanized our agents. So sometimes you'll make some product, and especially in this day and age, right, for where the agent will kind of be in an environment where it will interact with other humans, and if you're slightly entrepreneurial or slightly geeky, like me, you will have the lust to humanize the agent. Because who don't want to run 1,000 Turing tests every day? Like, you know what? Whenever I saw those responses for where somebody brought a sandwich to a meeting to our agent, somebody sent flowers to the office to our agent, somebody kind of brought whiskey for something where, oh yeah, I saw she kind of set it up at 3 a.m. on a Saturday night. You know what? My apologies, like, I fucking loved it. I'm skeptical now. We ditched it in the end, even though Amy and Andrew Ingram, which we kind of baptized them, they were awesome. Actually, side note, I liked it so much that I hired a small group of theater majors to craft the persona. So when you spoke to it on Monday, it felt like the same agent on Friday, even though the dialogue had taken a turn, so that you really had the opportunity to kind of create a relationship. Worked against us on all sorts of kind of obvious fronts. First off, that I should just have seen immediately. But do you know when you fall in love with something or another human being, you just can't see any flaws? Like, whatever people tell you, nah, it's you. It's not me, it's you. But the funny thing about when we did our best work, like I fooled somebody into believing that our agent was human, that was the smallest opportunity to convert them into a customer. Because sure, somebody's paying somebody 60K to have an assistant. I'm not doing that. So we couldn't convert any of the ones who had the absolute best experience. They somehow needed to be told, oh, this is a machine. If it's a machine, it's probably not 60K, it could be $8. So that was the part that just didn't work. But also, I'll give you just a few other notes once you start to kind of humanize. People, we all do this, will just kind of blabber on when they have to do something which they're a little bit embarrassed about. Say, reschedule, cancel, run late, something that could happen in my universe, right? All sorts of sad stories about I had to go to this kind of PTA meeting with my kids, and that's why, and why. And in that, there's a whole host of temporal expressions that I now have to make predictions for. That doesn't mean shit. Like, I don't care about that PTA meeting at 1 o'clock on Thursday. Just tell me, are we meeting or not? And if not, can we kind of move on? As soon as we start to expose the fact that this was not a human, we actually somehow, not even through magic, but that's obvious now, cleaned up the input data that we will receive. That kind of unstructured text just had all of those sob stories just disappear. That was one. Two, we could kind of redesign our product. I'll give you some funny kind of stories here. I'll not drag it along, but we had complaints, like real volume, on emailing at night. As in, hey, your assistant kind of nudged me. I know I didn't answer at Sunday, 4 a.m. Come on, hey, I'm at home. If it's a machine, and they know it's a machine, it's just probably part of some sort of system where they figured out I haven't responded in any number of hours or minutes, and they nudge me along. I get it. But there was all sorts of kind of defects attached to the idea of it being a human. Here's another interesting study. You should kind of read that if you have time one day. But there's a real, true, confirmed unwillingness to forgive machines. So that when you do move to the machine setting, you are now actually creating a different kind of, you solve some problems, but you're creating a new set of challenges. Microsoft did this study on stock trading, the exact same set of trades, exact same amounts, and then the level of willingness to kind of forgive. And people just couldn't see themselves forgive the machine. They could see themselves forgive, Michelle. Like, you know what? Happens to the best of us. That's the last one. Try not to, unless somehow you're forced into it because of the setting, to humanize the agent. I find it very hard. I'm very skeptical. Even though some days I'm sure we can all kind of close our eyes and kind of imagine that it might just be inevitable that at some point these agents will be somehow humanized because they need to kind of work in human environments. I'm still just not, I tried to kind of push back because I simply couldn't see or didn't find any. And I spent 6 years trying to make the most of the idea of it kind of being humanized in some sense. Those were the 4 points. 1, try to at least initially figure out how to make value-added predictions. 2, figure out who owns the prediction and make that clear. And if you can push that ownership onto the user, not in any negative sense, but as an active participant in solving the particular job, do so. And if you have to put the burden, have a clear understanding of the constituents in your universe and make sure you put the burden in the right place. I certainly put it in the wrong place. And lastly, before you romanticize the whole thing, don't go humanize the agent too quickly, or at least know why you do it. Cool. That was my story. I will spend 2 minutes, because I am an entrepreneur, to tell you what I'm working on today. That's the cost of my song. So today, our last company got acquired in May 29th, 2022. The one before that in May 6th of 2013. And the one before that was how I arrived in the US to Yahoo in July of 2008. And the one before that was I self-funded. We died in 2003. And the funny story about that, I actually had an opportunity, like 4 months before we went tits up, to merge with Just Eat in Europe. I spoke to Carsten and Mikkel, and I thought they were a bunch of amateurs. Still do, perhaps a little bit, I don't know. But I said, nah, you know what? Of us two, I'm surely winning. We didn't at all. Like the delta is not even, yeah, it was a close race. Not at all. So they did very well, and good on them. Now, today, with Launch Brightly, you create a software product. You put it into market, whatever version, 1, 2, 3, 4, 5, 6. It's in market. There's surely some utopia for where you believe that it's so intuitive that anybody can just look at it and immediately figure out how to use it, and there'll never be any support tickets. Obviously, a utopia. You start to get some support tickets. Support tickets are expensive. So the way you combat those support tickets is that you put this knowledge base in place, because it would be nice if you could figure this out yourself at night without kind of bothering me at cost. And those articles hold these explanations for how to set up two-factor authentication, how to add a team member with these rights, and so on and so forth. And they have a whole host of pictures. Those pictures of that product is what we built a platform to do. So you can set up these automation recipes where, hey, Dennis, every Sunday night, can you log into my product, go to this particular page, put it in this particular state, clean it up, take a screenshot, annotate these particular parts, add these arrows, log into Zendesk, scan my articles, see if that image exists. If it exists, update it. If it's changed dramatically, do an audit, some sort of pixel diff, and let me know. Then I'll give you a thumbs up. And just do that repeatedly, over and over again, every Sunday night or every Tuesday night or once a day or once a month, depending on the velocity of your engineering. We've been at it for 14 months. Somebody said that before. The dude here from the VC firm. So we raised initially 3 at $15 million. There was another dude here. I pay myself $60K a year throughout the whole venture. And then I hope the stocks turn into something, which sometimes did. So that's very nice. That dude over there had a question in the idea that agents might meet other agents. That was a very funny scenario, right? So we had good penetration in market, but sometimes we would meet ourselves. Our own agent would meet itself, right? So there'll be some individual, they'll CC in the agent, set something up. Then on the other side, they'll say, oh, cool, my assistant will speak to your assistant. But it's me. And then what we'd have to do, we had these kind of, essentially turned into an internal preference negotiation, right? Which we could do instantly versus the whole kind of going back and forth. But even the funny thing is, the internal preference negotiation we did as a negotiation back and forth, which you could go read. So this is how the agent negotiated with itself. So, and the reason we did that, by the way, was so they could see that we didn't necessarily favor anybody, as in you and me meet, where do we sit on the ladder? Oh, I'm a little bit below you. That means we're meeting in your time zone or whatever. That was the one part. Here's another interesting thing, and I'm not evil. I'm pretty nice. But there's then the very likely scenario, if you're in a market where the TAM is big enough for where you have competitors, you meet their agents. That's funny, right? So what can I do to make sure that their agents stumble, which will then increase the probability of people looking at my agent? And we did some, this is being recorded, but we put on our pirate hat. I'll tell you that, where, here comes one of these agents. I know, because we did the same set of predictions. I know exactly how to write this to kind of have that kind of fall over, but that's a long story. Cool. That was my words. Thank you very much.
No, thank you very much for the wisdom, for the stories, and the laughs. We can take a question if you have one for Dennis, and we're also going to have a break after, so we can continue to talk and tell stories. Yeah, Sam.
I'm really interested in your take that making it seem like a human isn't always the right thing. I'm slightly obsessed by, there's a company called 11x who do like outreach, who not only try to make it like a human, but they, well, so to the company who is buying 11x, they have this picture of this very beautiful woman with freckles who's like shaking her hair, and this, you get Alice, right? and they have, I think, Mike, and I don't know whether they use Mike for when they're pitching to women. I definitely got pitched Alice. But on the other side, when they're doing the outreach, they're just flat out pretending to be me or whoever it might be. Do you think that whole idea and going further and having the like pitches is all a mistake, or do you see there's like it's a nuance and there are cases where it's worth doing?
It's a good question, and it might all be on me and me not being able to see what they can see, and I somehow stumbled. However, I'm full of side notes. Almost all men picked Amy. Almost all women picked Andrew, our two agents, just as an interesting little fact. I'm trying to figure out when somebody kind of, not you, but when somebody kind of presents me the idea of them wanting to kind of humanize it. Sure, okay, I'll buy that. What is it that you're trying to achieve by humanizing it? Because if it's just to kind of fool the other party into believing that you're human, I'm not kind of seeing the value in that. We had a real dramatic, near instant churn-like events when guests felt fooled. Like they felt a little stupid for, I said all these things, did all these things because I believed it was human. Now I figured out it's not, and you know what? Not only do I not like it, I'm going to go out of my way to tell everybody, first of all, it's not human, and I don't like it, and it's deceiving. And it was not one for where, that's one story, Dennis. Now I have another 5 good stories. Sure, I have the geek stories of how we won some Turing tests here and there, but I don't have any really good stories on what we won on it. It was mostly on, here are all the dangers, and here are all the things which we lost. And I think we have some good examples, right? There's you and me, I don't know, in the last 10 days, probably somehow tried to do whatever on some support system where they put a virtual agent in place, for where they don't even disguise the fact that it's a machine, but they somehow semi-humanize it, which I think is even worse. As in, Citibank, what the fuck are you trying to do here? Like, I like you, not to begin with, now a little bit less. If you want me to kind of look at your help files, that's cool. Then just craft it in such a sense where you can help me do an international wire back to Denmark, and that's fine.
Can I just do a kind of follow-up really annoyingly? Sorry. So I think in the case of 11X, when they're selling, they're calling it Alice, but they're not pretending it's a human, right? And they're using the name so that they can basically compare the $3,000 a month they charge to whatever you would pay for the BDR to do it. When they're on the other side, when they're reaching out, they are absolutely outright pretending to be Samuel because they think that's necessary, but that's not pretending to be Alice. So it's a slightly weird situation.
And there's probably, and again, it's a whole spectrum, right, where there's the idea of going all in, which I did, so I'm not an angel here. So I went all in as in, we need to apply effort to have people to believe this is a human. And we would actually charge it against the idea of, well, you're going to pay 60K here and some other amount over here. I'll give you some interesting so we had what? The data science team was about 30 people, so I'm sure you can imagine a whole host of kind of experimentation going on and kind of precision recall. We kind of dialed up ever so slightly. This, if not the single biggest increase in our core metric, which was meeting success. So meeting success for us was the metric of you do a request to the point where I do an actual insert into a calendar, as in this happened. The single biggest kind of driver, like multiple single percentage points driving that, like a step function for us. Like everything else was in the kind of small digits, like, okay, now we can do these particular temporal expressions slightly better, was when we changed the name from Amy and Andrew to scheduler. Like, it's one of those, it took 3 hours to run the experiment. I hated it, so in love with these two agents, but it worked really well. Another one, when we saw that work was when we started to inject HTML into the emails, because that was our particular communication platform. Before, I was all ASCII. Like, no, we can't do anything which I wouldn't have done myself, and I'm not going to go design HTML to put into my emails. But that just worked well. And by the way, sorry, this is, again, thank you for the therapy. The idea that the conversational UI was a UI so distinct that people didn't want to escape it was again a little naive. As in, you and me kind of grew up on the command line, or I certainly took my CS degree on the command line. It was pretty much the only kind of interface to get access to compute. My mom kind of got the graphical user interface, and my kids kind of grew up, if it's a distinct UI of its own, the kind of touch interface. And I just believed in the idea of the conversational UI being a new UI paradigm and people wanting to kind of live in it entirely because it would kind of fully democratize access to compute. Nah, you know what? Sometimes I don't need to write back next Wednesday at 1 o'clock is good for me and Lainey, but make Tom optional. If I know that that is the most likely outcome, a button for that is just, it's not bad. Sorry, like I'm helping myself here.
That's fantastic. Thank you so much. I was worried maybe if you got too many side notes, I was going to have to kind of slightly.
yeah.
Nested side, yeah, that's right.
I've never seen that. That was wonderful. It makes the weed from Trump look positively amateurish. Then just wait once they go recursive. That's when I really lose you.
Yeah. Okay, so let's thank Dennis. 20-minute break now, and enjoy. Yeah.
Apple Card is the perfect card for your holiday shopping. When you use Apple Card on your iPhone, you'll earn up to 3% daily cash back on every purchase, including products at Apple like a new iPhone 16 or Apple Watch Ultra. Apply now in the Wallet app on your iPhone. Subject to credit approval. Apple Card.
Hello, everyone. We're going to begin the last session of the day. So if you could slowly make your way to your seats, wrap up conversations, that'd be much appreciated. Thank you. Testing, testing. Okay, if everyone makes their way back to their seats, thank you very much. We're gonna begin again with the last session of the day. So we've heard all of today. We've heard about use cases of AI that might be considered more technical. Thinking about data, thinking about products, slightly unsurprising because we're sitting so close to MIT and CSAIL, one of the great homes of AI. We're also sitting very close to MGH and Harvard, and this has been a really, really interesting and impactful place for generating innovative ideas in healthcare and putting them through probably the kind of lead place in the world. And so our last session is AI cross biomedicine, biotech, and all of us that thinking for one reason or another did medicine before we did AI. And so we've all got some kind of interest in it. And we all think that if we might have left the clinical field, practicing there, we can at least help by designing some kind of solution based on artificial intelligence. So I'm not going to chair this session, which is sort of a relief after 3 continuous days of chairing, because we've got a superstar chair in Yasmin Ayman, my close friend and colleague, who is just finishing up her PhD in neuroscience at Harvard. She's joining the job market soon, is an exceptional person. If you're looking for hires, I would suggest going up and talking to Yasmin as soon as possible. Yasmin, could you take the stage, please? Thank you so much for chairing this session.
Thank you. Is this on? Thank you, Rory, for that kind introduction. I'm only a third-year PhD student, but also, very excited to discuss future directions. It's my honor to present Dan Nicolau, Dr. Dan Nicolau, who is also a friend and a professor at King's College London. He is not only a physician, but also an engineer and mathematician, and is interested in using mathematics and computer science to understand complex biological systems and how they intersect with the healthcare systems. So without further ado, join me in welcoming Dr. Dan Nicolau.
Thank you. Thank you, Yasmin. As you can see, indeed a hire, so I should go talk to her right away. It's been a great day. It's been a great workshop. Thanks to Rory and everybody else who has put so much energy into organizing, and thank you for sticking with us till the end of the day. A slightly different talk, hopefully for me, on not unrelated to the other talks of the day, but maybe just a little bit of different flavor, also a little bit experimental with sound, I'm afraid. So let's see if it works out. So what I want to tell you about for 20 minutes, it's flavors from a few different things, but learning from small data, and centered around three little snippets, 3 little ideas. One is powder, exactly what it sounds like, the material, something about pathogens from immunology, and something about power. And when I say power, I actually mean statistical power. So In my first life, I was a mathematician, or am. So one sees these announcements in the news with frightening regularity. This particular one, there's nothing special about it, but that there's an AI model, Llama 3.1, which does things with 405 billion parameters. At the risk of offending a lot of the audience, as a mathematician, I would be embarrassed to talk about that. I would probably be borderline ashamed, and yet one gets the feeling that the people who are making these announcements are saying this proudly, and in some cases even boastfully. My friend and colleague Tom reminded me of this saying. This is a quote from von Neumann: "With 4 parameters, I can fit an elephant. With 5, I can make the trunk wiggle." There's actually something in the history of mathematics called von Neumann's elephant. I would certainly be embarrassed to go from 4 or 5 parameters to 405 billion. Because systems do learn from very small data, and I'm going to give you 3 examples of systems broadly construed that learn from small data. Experimentally, let's see if this works. So this is my son, who is 3, heading towards 4, and he's called Arjuna Juju to his friends, including 2 his goddads, both of whom are in the room. And his favorite activity is to be, at the moment, is to be taken to grocery shopping and to be tested on whether, like, does he know, like, the names of all the vegetables and stuff. So let's see if this works. So this is one from about a month ago.
It's all right. Let's do a review of the shopping. What's this?
It's a juice.
Yep, it's a juice. Yep. It's a?
It's a popcorn.
Well done. It's a?
It's a milk.
Mm. It's a?
It's a cheese.
Yeah. It's a?
It's a milk.
Yeah. It's a?
It's a pasta.
Yep. It's a?
It's a bread.
Mm. It's a?
It's a ice cream.
It's a?
It's a orange juice.
Oranges, yeah. It's a?
It's a sweet potato.
Yeah, it's a super potato.
It's a big potato, so it's a super potato.
It's a bacon and that.
Okay, it's a bacon. It's a?
It's a bacon.
Okay. It's a?
It's a lepoposo.
It's a lepoposo.
It's in French. I don't know why that one has to be in French.
It's a banana.
It's a?
It's a juice.
It's oil.
Oil.
Mm. Yeah, it's oil.
So this is the one I wanted to show you, okay? So he'd never seen oil before. I think he'd probably seen it in a frying pan or something, but he'd never seen it in a bottle. So he knows what juice is, right? And he's seen this thing. It's transparent. It's obviously a liquid. And so he's like, well, it's a juice, okay? So I think I told him it's an oil, did I?
Yeah.
It's an oil. And then we kept on going. These are radishes. Believe me, he knows everything else. Right. So this was on a Tuesday. We always do it Tuesdays and Fridays. This was on Tuesday. On Wednesday, so I told him it's a liquid like juice, but it's not a juice. It's oil. This is the second video. And this happened, so this was about 60 hours later.
Okay. Let's review the shopping. Shall we review the shopping? Okay, what's this?
It's a sausage downfall.
Yeah, it's a sausage.
Cat litter.
What's that?
It's a bacon.
Yeah, it's a bacon, yeah. It's a?
It's a cheese.
Yeah, it's a cheese, yeah. It's a?
It's a tomato.
It's what kind of tomatoes?
Baby tomato.
Yeah, it's a baby tomato, yeah. It's a?
It's a spinach.
Yeah, it's a spinach, yeah. Okay, here we go. It's a?
It's a tea.
Yeah, it's a tea. It's a?
It's a flower.
No, it's not. It's a coffee.
Coffee.
Yeah.
So he had never seen coffee before, but I bake bread for him so that he doesn't need bread that's full of crap. And so he knows what flour is because we always buy flour because I bake on Tuesdays and Fridays. So he'd never seen coffee before. I guess he'd seen it in mugs, but he didn't understand it. So he's seen this thing and he's like, it's a flour because it's a powder. Okay?
Powder like flour, but
it's a powder like flour.
It's a?
It's a radish.
Yeah, it's a radish. It's a?
It's a sweet potato. pear.
Well done. Yeah, what's this thing?
It's a pear.
It's a pear that he had eaten half of. It's a?
It's a ham.
Yeah. Well done. It's a?
It's a chicken.
Yeah. It's a?
It's a cheese.
It's a cheese. Yeah. Well done. It's a?
It's a love
Yeah. It's a le poisson. That one's in French for some reason. It's a?
It's a bacon.
Yep. It's a bacon. We're almost there. It's a?
It's a flower.
Mm-hmm. And this one?
It's a juice.
It's a?
It's a oil.
Yeah. Okay. It's a?
It's a milk.
Last one. It's a?
It's a milk.
It's a milk as well. Well done. High five. Again. One more time. High five. Well done. Well done. You passed. 100%.
Okay. Right. So we know it's an oil and we know it's a coffee. Now let me show you this one. I will beg your patience with one more of these videos. In this one, I introduced a third category. Instead of telling him that we're going to buy grated Parmesan, I told him it was powder cheese. The product is transparent, so you can see it's powder inside. It's sort of like the coffee, kind of, right? So now we know it's an oil, and I think you will see in a minute that he knows it's a coffee. It's a powder like flour, but it's not a flour, and he says that. But then he's presented with, okay, so this is a powder cheese. It's a powder like flour and like coffee, but it's neither coffee nor flour, right? So let's see what happens.
I think it's time to review the special shopping. Okay, here we go. It's a?
It's a daddy milk.
That's right. It's a?
It's a judge's milk.
Mm-hmm.
It's a judge's milk.
It's a?
It's a hand's milk.
Correct. It's a?
It's
Medicine.
medicine.
Mm-hmm. It's a?
It's a tomato juice.
Mm-hmm. It's a?
It's a juice.
Yeah. It's a? It's for wipe your bum.
Rugby ball.
Yeah,
to wipe your bum.
Yeah, it's a?
It's a summer barbecue.
Yep. It's a?
It's a sweet potato.
And a?
It's a monster potato.
It's a monster potato.
It's a orange pepper.
Correct. It's orange pepper. Well done. It's a?
It's a popcorn.
Yep. Okay. It's a?
It's a baby cucumber.
Yes, it's a baby cucumbers. Well done. Excellent. Yes.
Reasonable inference.
It's a?
It's a juice.
Yeah, it's a juice. Okay. All right. Hard things. It's a? Well, it's powder, but it's not a coffee, and it's not a flour. What is it? What is it called? It's a powder cheese. It's a powder cheese. It's a powder cheese.
It's a powder cheese.
Yeah, it's a powder cheese. Okay.
It's not a powder cheese.
It's it's not a. It's a powder like flour, but it's not a flour. It's a powder cheese. Yeah. It's like.
It's a powder. It's not a powder cheese.
It's a powder cheese. Yeah. Okay. It's a.
It's a water.
Okay. So. So apparently this thing about the powder cheese, he was just like, no, the old man's lost the plot. Like, it's not a powder cheese, right? So that's an example. Obviously, we don't know how these systems learn from such small data. We know a little bit more about these other systems, which as a card-carrying immunologist I think about. This is a simplified diagram of what we think the immune system is doing. But the immune system is a system which learns from very small data, as I'll try to convince you. And by the way, I know this audience is into brains, but anybody who is telling you that the brain is the most complex system either doesn't know what they're talking about or is just arrogant. The immune system makes a mockery of the brain. It's at least 10 times larger, and in terms of connectivity, because every one of its cells is connected essentially to every other one of its cells, in terms of its potential computational power, it is radically more powerful than the brain. As a show of hands, what's older, the brain or the immune system? Who thinks the brain is older? Okay, who thinks the immune system's older? Yeah, that's the answer that we always get. The brain is far older than the immune system, by hundreds of millions of years. And that's why it exerts control over the immune system, not the other way around. Otherwise, the immune system would melt you, as Tom, I'll borrow your line, I'll give it back when I'm done with it. If the immune system wanted to do to you anything short of a hemisection, it could. And in fact, in some autoimmune conditions, it actually melts your skin off. So it's under the exquisite control of the brain, which is much older and much smaller and much less sophisticated. How does the immune system learn? So obviously it's a very active area of research to state the obvious, but basically it has a very strong underlying model. A pathogen turns up, it has a genetic signature, or it has things at the surface of the cell. The adaptive immune system recognizes that, looks whether it's in the database. If it's not in the database, it adds it to the database. And then the next time you have an infection, like the second time you get COVID, basically you mount, you've got B cells and T cells that have learned from one single infection that you've ever had in your entire life, which can span 100 years. It will never forget. It will learn from one single shot. And it will remember that pathogen for the rest of the organism's life. But there are lots of things that we don't know about the immune system which suggest that this story is, at best, extremely incomplete, if not indeed completely erroneous. The adaptive immune system emerged with jaws, as in maxilla. We don't know why, and it is not at all clear why. So, for example, here's a picture of a crayfish, and very shortly thereafter there was the emergence of jaws, and then we have little sharks. These guys live in the same water. They're predated on by the same bugs by definition. They eat the same stuff, and yet one of them, the little shark, has an extraordinarily complex adaptive immune system, whereas the crayfish has just sort of carried on existing, is perfectly happy without an adaptive immune system. What they do is generate antibodies to every potential thing that they could possibly encounter. So there are certainly some mysteries. You're not really allowed to ask in immunology why the adaptive immune system emerged with the jaw. I know because I tried asking. If you ask this question, you don't get tenure, basically. So I was like, okay, moving on. But another mystery, a potentially even bigger mystery, is since you got the brain thing so wrong, let me give you another another opportunity. Would you just shout out how many pathogens, how many things colonize us? Not necessarily pathogens in the sense of like hurting us, but like how many bugs, including viruses, helminths, worms, whatever you want, together, and viruses infect humans? You're not allowed, 20,000? Cool. Okay, it's all over the place. Good. So I don't know if you know or if you're just taking a guess, but the answer is very close to 1,000. It's about 1,400 is the best estimate that we have. And that also, well done. And that also applies to other mammals resembling us. So there's about 1,400, generously 1,500 things that can live on us. That includes commensals. So if you wanted to recognize those things and say for each of them, for the sake of the argument, you wanted to recognize something like 100 surface things, right? So 10 to the 3, but you want, sort of 100 things you might want to recognize on the surface of the cell, which is a lot. That takes you up to 10 to the 5. And say you wanted 10 epitopes per bug to make sure that it doesn't, if it mutates, you can catch it. I'm just making numbers up. You're looking at something like 10 to the 6. You need to have a database with a storage capacity of something like 10 to the 6 generously, because there's only 1,000 things that can be, right? The size of the database that can be generated, that can be marshaled in terms of B cell and T cell responses is called the immune repertoire. So if we take the total size of the immune repertoire, which we can estimate very easily, there are some variations in estimates, but basically, it's simply it depends on how many locations you have in the databases. I'm happy to go into it in questions, but so that's your total repertoire, and then you take what we just calculated, 1,000 bugs, 10 epitopes, 100 receptors. If there's a difference, like maybe you want a little bit of give, right? You want to like not completely fill up the database, so maybe you want like a little bit of extra space. You kind of want to give yourself some redundancy, what engineering would call redundancy, okay? So in the case of the immune system in mammals, the repertoire size is something like 10 to the power of 18. It depends on who you ask. There are estimates up to 10 to the 20, 10 to the 21, but the smallest estimates are 10 to the 15. So we've got 1,000 pathogens, 10 antigens, 10 epitopes, which means that the immune repertoire is 1 billion times, conservatively, 1 billion times larger than it needs to be, which is another question that you're not allowed to ask in immunology without not getting tenure. So, but it's a question that's so big that it's almost, I almost understand why they don't let you ask, because it clearly means we don't understand what the immune system even is. Even if this naive repertoire which is extremely difficult and expensive to maintain. And when it goes wrong, you get lupus or whatever. So it has a lot of things associated with maintaining it. Even if you could, even if you presented anything approximating this number of challenges, it could never exist physically. And even if it did physically, you couldn't access it in a lifetime. Biologically, it would be a lump of like B-cell goo. So there are some mysteries. Nonetheless, it does learn from having seen something once, right? So let me give you a third example. This is what Tom and I are working on. So this is a very old paper. It's the only time in my life I've seen the word manurial, and it's exactly what it sounds like. So Fisher was interested in like if you put like shit on like potatoes, and there's another piece of the field where you don't put shit, which of the potato varieties becomes a super potato to quote a living classic, and which one's not, right? And so believe it or not, this paper from 1923 is basically how we do clinical trials. We have always done clinical trials for what is now 101 years, roughly. And basically, for this audience, I don't need to do it, but basically how it works is you have some preclinical testing, you have some idea that aspirin is good for headache or something like that. And it's most simplistically, you split the groups into two, 100 people get aspirin, 100 people don't get aspirin, for example. You have to estimate how good you think aspirin is for headache, and then you run the trial, and at the end, somebody apparently in a lab coat with paper comes, it looks like toilet paper, and they use the toilet paper somehow to come to a conclusion regarding whether aspirin is or is not effective for headache, okay? So now when clinical trials first started being done, Tom knows more about the history than I do, but in the 40s and 50s, I'm happy to report that it happened in Great Britain. There were little trials, and they cared about whether something made a big difference. Some of them were surgical trials with very small numbers of people. But they've become extremely expensive to the point where there's something called Irum's law, as in the opposite of Moore's. So basically, there's an exponential increase in the cost of clinical trials. They like double every whatever. It costs billions to get a drug from the lab to the bedside. These numbers are actually out of date. It's more than 2.6 billion now. 90% of them fail to get from the lab where they worked very well in the petri dish or in the mouse to humans. No other industry on planet Earth could sustain a product development failure rate well exceeding 90%. And one of the major reasons, if indeed not the major reason why they are so expensive, and not only expensive, but they delay medical research so badly, probably by a factor of 3, 4, 5, is because of the clinical trial having to be run in this like manurial way, the way that Fisher did it. So you didn't know if you put manure or not, and the other one, so blinding. That process is called blinding. And maybe most of you know what I mean, but basically the team doing the trial doesn't know whether the patient's getting aspirin or placebo in the aspirin example. So the doctor doesn't know, the patient certainly doesn't know. And the idea behind that is to reduce bias and preserve the quality of the data. One downside of this very important process is that you have to wait to the end of the trial. And because you had to power the trial at the beginning, you had to say how good you thought aspirin was for headaches. Or, in modern practice, it would be more like whether this drug is going to make the cancer recede or not. You don't know, so you're waiting to the end of something that potentially costs billions, hundreds of millions, in some cases tens of millions, but extremely, extremely expensive. You're using patients that are a very limited resource. You're exposing them to risk. If the drug doesn't work, you've exposed them to risk for no reason. If the drug does work, you should have stopped earlier so that people could get the drug. So the cost of this procedure to preserve data integrity is that you don't know. You just have to run it to the end and you don't know. And that's one of the reasons, if indeed not the main reason, for this appalling graph. But if you, in terms of learning from small data, if you have a strong underlying model, if you think about what's happening under the hood, very simplistically, I mean, there are a lot of mathematical details here, but to just give you like a very, very like almost cartoon sort of thing, you have a data stream coming from the placebo arm, you have a data stream coming from the treatment arm, okay? And you can calculate something approximate, some kind of measure like this, which, something like a Z-score. I'm just literally lifted that off Wikipedia, but the point is that you have some idea of a comparison between these two arms. And so classically, you wait to the end, right? And then you do the comparison. But there's no reason why you can't, if you somehow had access to the data stream, why you couldn't sort of do it as you go. And how that process goes, I think statisticians don't think in this way, what I'm about to show you, but my PhD was in stochastic processes, and we do. So I'm standing here, okay, and like a little bit of data comes in on this patient, aspirin worked, say. So I take a step to the left. Left is aspirin works, right is aspirin doesn't work. And, you know, another bit of data comes that says, oh, aspirin actually made the headaches much worse. So I take like a big leap to the right. And every time a new bit of data came in, I'm not allowed to look because I have to protect the blind, but if I could look. And in some trials you can, if you can't blind for whatever reason. So basically I'm just diffusing left or right, potentially in a well-behaved way because I'm sampling these step sizes from a Gaussian, potentially in a very not well-behaved way because I'm sampling from some strange distribution, but basically I'm moving left or right. So you can think of this thing as a real-time kind of like walk in one dimension. And if you can think of it as a random walk in one dimension, then you can bring tools from the study of stochastic processes to think about it. But all I will say, in the interest of time, is if the drug works, you have a drift term, basically. Not too unlike a Black-Scholes, actually. And so all you're trying to figure out as you go is whether there's a drift or not. In the classical case, you basically would draw a line here and say, if you pierce this line by the end of the trial, we say p is less than 0.05, and we conclude, for some reason, that that's the number that humanity has chosen. We conclude that, that this drug works, the FDA approves it, billions of bucks, rock and roll. And if not, if you're just short of this imaginary line, then we say the trial failed. So if you can implement this without anyone ever seeing the data, only the computer sees the data, if you can implement some procedure like this, or much more sophisticated version, but essentially something like this without, in the cloud, the team doesn't see it, whoever built the software doesn't see it, then you can come to a conclusion potentially far earlier. And since 90% of this pipeline ends in failure, there must be failures sort of along the way. So let me just show you very briefly what this would look like if you're actually running it on a trial that you had continuous access data for. Basically, information doesn't accumulate linearly. It accumulates with the square root of time for the same reason that standard deviations fall with the square root of time. So it's a very classic finding. So you can basically draw a dotted line and say, okay, if this sort of measure, something of this type, is above that line, then basically the drift term is likely to be positive, or negative, sorry, in my example. And if it's below this line, then basically it looks like this thing is going to go to failure. And then you can ask questions like, given where you are, and given that you need to go above this line in order to declare this thing a success, what's the likelihood of that? What's the likelihood of covering that territory in the remaining time? I'll just play this video. It would be hilarious if my toddler videos worked, but this video did not. No, okay, it doesn't. So time on the x-axis, this is a sort of a measure of whether things are working or not, and then you have this imaginary line. And at the bottom, again, time on the x-axis, and this is an estimate of your odds of covering the ground that you have left in the remaining time. And so initially, that probability is quite high because you don't have very much data. This red line is the magical 0.05. And in this example, this was a publicly available opioid thing, but I'll play it one more time. What happened is that this failed. And in this case, we could have, depending how confident you want to be, we certainly, this collapses around about the midway mark. So by the time you get to 60% of the way into a trial, you're already, few percent likely to have. So you could have stopped this and saved everybody loads of money and trouble and indeed risk because it's an opiate trial. That's roughly the kind of thing. And you can ask how well it does. Well, this is I can take questions about this, but essentially, this is a histogram of when, if you said, okay, if it's less than 1% likely to win, I'm gonna stop. What's the histogram of like stop times, if you know what I mean by that in a stochastic sense? And as you can see, the great majority of the time, either because something is working very well or because something is not working, you can stop very, very early. And this is what Tom and I are building. In general, you can stop about a quarter of the way in. And in terms of the number of mistakes that this, if you want to call it an AI, we can, the error rate is so low that essentially even a very large company like Pfizer or Novartis would have to run more trials than they've ever run in their entire history in order for this thing to have made a mistake. And obviously the economics given that it costs billions, the economics is extremely compelling. You can stop like a quarter of the way and a third of the way in. That's it. I just want to tell you one more thing. Having to put these slides together made me think a little bit, well, first of all, videos of my son, but also what, can you learn without a model, thinking about these 4 and 5 billion parameters? I argue not, and actually if we think about the etymology of the word learn, in English it's a Germanic word, and it comes from, it's cognated with Dutch leer and to read, but it basically, the basic sense of this is to follow or to find the track. We speak about learning, all the time, especially in this context and in our time. Hardly anybody ever thinks about that. So I argue that learning as is classically understood, virtually by definition involves that you have a very strong underlying model, like the immune system has of the things that it may be challenged by, or that we have regarding this process of whether I'll go right or I'll go left. I have a very strong underlying, very small mathematical model. And the process of learning sort of collapses to some sort of parameter estimation system. And therefore, I argue that learning virtually by definition, whether in our AI for clinical trials case, or obviously we don't know how Little Juju does it, but I suspect he has a very strong underlying model, involves fitting to an underlying strong small model. And of course, that doesn't mean the model is static. And indeed, when you see the video of him with the powder, I think, he's like, no, it's a powder cheese. No, it's not powder cheese. But I think what he's actually doing, jokes aside, is having to rethink what powder is. Like maybe he thought powder was something else, and so it's taken him a while to kind of like go back probably many levels and like recompute everything. I'm happy to report that in the 2 weeks since that video was taken, he has now accepted that it is powder cheese. Thank you.
Thank you so much, Dan. We have time for maybe one question, and then you can catch up in the social after as well. Yeah. Back.
Thank you. I'm Mike.
Hey, thanks for the great talk. There's well-established statistical theory on always valid p-values, such that you can protect the type 2 error rate. So I can guarantee, no matter how many times you look at the data, no matter when you stop or when you go on, we can guarantee, like, say, that I'll only falsely reject a true null 5% of the time. So that theory is well established.
Yeah.
Those experiments are used a lot in tech platforms.
That's right.
So it's not a technical problem. The theory's well established. I don't have to assume Gaussianity, you just got to put tail bounds on how fat the outcomes are. If the outcome in medicine is 0-1, it's tail bounded by definition. It's 100% regulatory. The theory's sound, its theorems have been sitting there. You got to talk the FDA into it.
I mean, there's no doubt that the theory is well established. There are some interesting distributions in clinical medicine. So you get, maybe the blood pressure moves for some people in the trial, not for others. So you get some interesting distributions. But even in those very difficult cases, the underlying like physics of the situation is well understood. And as you say, we use them in. I wasn't sure what the question was, but.
Well, the question is like, well, it's all. Well, I think the answer probably put the question is. When the firms, I think, why do you think the FDA hasn't adopted it, right? One reason is when drug companies go to the FDA and they call people like me, I'm a statistician, and they go, hey, this drug company wants to put distributional bounds on the outcome. I go, no. We spend billions of dollars on these trials to protect the type 1 error rate without any further assumption. But there's theory that requires no further assumption other than very weak bounds. So like the question is like why hasn't the FDA accepted this? Why do large tech firms accept it?
Oh, I see. Your question is why it's not been, it hasn't been attempted. It's actually a very simple answer. It has never been attempted. No company has ever tried doing it before, so the FDA has never been asked the question before. Nor have the counterparts in the rest of the world. But,
well, we can take it offline. During COVID, it was asked, it was done. I'm just telling you that the FDA is thinking of this adversarial setting with drug companies.
Yeah, that's interesting. Also, that's more discussion with Tom, but certainly the theory is rock solid. Almost no one doubts that, including the FDA, for reasons that are indeed in COVID. Actually, I was involved running a clinical trial in COVID where we did ask this question actually successfully. But so yes, in COVID, that's right. But in general, basically, people have not tried to move the needle of innovation for reasons which are fundamentally to do with like the manure response and ossification. But yes, thank you for the question.
Thank you. So I'm excited to welcome our next keynote speaker, Dr. Marzia Ghasemi, who is a professor at MIT leading the Healthy ML Lab, where they develop robust machine learning algorithms to inform and improve healthcare decisions. There's a lot of cool and interesting work and important work that's being done. So join me in welcoming Dr. Marzia Ghasemi for our next keynote. Thank you.
This one's on. Okay. Yeah. While we're figuring out tech support, are you guys, you did the machine learning stuff yesterday, right? Yeah? 2 days ago? Everybody's excited about AI. They think it's amazing. You have to do like full screen. No, you're not excited about AI? You don't think it's amazing? Lukewarm. Tough crowd. You know, I heard a comedian say this, but it's true. I'm dyslexic, or I had dyslexia as a child, so I don't know how to read a room. So I'm sorry. Very sorry. Also, I have to give a shout out to our session moderator, who said my name correctly for the first time in recorded history. That's right. Yeah. Yeah. There are 2 canonical pronunciations of my name circulating around the halls of MIT. One makes it sound like it rhymes with Zendaya. Marzia, that's not it, okay? I am not young or cool enough to have my rhyme with Zendaya, so she said it correctly. All right, I'm going to talk to you quickly about machine learning in health and some of the research I do with the Healthy Machine Learning Lab at MIT. We focus on 3 things. Number 1, assessing whether you need machine learning in a healthcare setting. Number 2, if you do, designing a robust, private, and fair algorithm. And number 3, even once you have a good algorithm, deciding how we deploy it so that it's used well. Let's say that you are a doctor and you want to develop a machine learning model to help you with this situation. This is not entirely hypothetical. I might have been approached by a doctor to do just this. So you have patients. They're here in Boston. It's a Friday. People get crazy on Friday. I know this because I'm in a college, not MIT. I'm actually cross-appointed in Harvard. MIT students don't do anything crazy on Friday. They're very good students. But those Harvard kids, they go to the hospital quite a bit on Friday nights. And if it's sunny and you go to Harvard, there's not a blade of grass that doesn't have a student sitting on it. If it's sunny and you go to MIT, the grass is all yours, because they're in the basements and they do not care. So all of these Harvard students are at Mass General, and they need a doctor to look at them because they're having trouble breathing. You don't want a bunch of people to be sitting in a hospital because of COVID and MRSA and SARS and who knows what else. And so can we just build a machine learning model to triage a patient who's having trouble breathing, so if they don't have anything in their chest x-ray, they can go home? Well, the answer is yes. Hopefully yesterday you were somewhat convinced of this. At this point, we can choose a problem, collect some data, define an outcome, develop an algorithm, and then potentially deploy a model and predict most things that we have good labels for, caveated on the data that we've collected. And I've already given you the problem that I want to solve, right, because it was given to me. I want to do model-based chest x-ray diagnosis so that I can triage people who aren't sick and get them out of the hospital. Let's run through the rest of that pipeline. There are 3 publicly available chest x-ray data sets in the United States. That's over 700,000 images, pretty large sample size. I can train a dense net, that's a kind of convolutional neural network, and optimize for a label of no finding. That means there's nothing in this chest x-ray. There's no pneumonia, no pneumothorax, no fracture. They're clean, they can go home. And lo and behold, I can get a nice AUC of 0.859. If you don't know AUCs, 0.5 is random, 1 is perfect. If it's perfect, something is wrong with your model. There's no way it's perfect. And you say, you know, surely nobody has ever thought that, but I had a student come to me recently and say he could perfectly predict mortality in the intensive care unit, and it's because as a signal he was using that life support got turned off. So yes, in fact, you can, but maybe you shouldn't. And I mean, a lot of people, stop here. This was a fun paper. I enjoyed writing it. We got nice performance results. But a lot of people don't stop here, right? So there's, at this point, many hundreds of FDA-approved AI and ML-enabled devices. And they are deployed now in a range of clinical tasks, many of them in radiology, but in other fields as well. But should I deploy my model? It's a hard question. You're all like fun people. Not I. I'm at MIT. Sorry, guys. But you seem like fun people. It's a Friday. I hear there's a party happening later that I can't go to. I'm from MIT. But, there is a party. What if you ended up in the hospital? It's a Friday night. You want to protect your time. It will be 3 hours to see a doctor at Mass General, or you could have this state-of-the-art machine learning algorithm triage you now. By a show of hands, democracy works, except recently. Who, so painful. It's still painful to me. Who would wait for 3 hours on a Friday night to have a doctor see them? We've got some Luddites in this room. Okay. And the rest of you would let the AI triage you. Okay, all right. So you raised your hand. You would wait for 3 hours. Why would you wait for 3 hours? You're not an MIT student, are you? No? Okay, just checking. Yeah. Yeah, pretty high is not high enough. And as it turns out, we benchmark this against clinicians. Clinicians do worse. But no. But we, I think as a prior speaker said, we do hold algorithms to a different standard. Maybe incorrectly, but we do. I think just in general, not only in health. Let's go back and look at that number. That is one number. That is one number there that is demonstrating how amazing my algorithm is. Let's check some other numbers. Let's check the false positive rate for this algorithm in different subpopulations, and I'm going to call that a model underdiagnosis rate. Why? Because if you falsely positively say somebody is healthy, that means they're actually sick, and you're sending them home. And if you do that at a higher rate for one subpopulation than others, then you're automating underdiagnosis bias in that subgroup. And when we run this on our fantastic model, which, plausibly could have cleared FDA approval, it has the largest underdiagnosis rate in female patients, young patients, Black patients, and patients on Medicaid insurance. And if you exist in an intersectional identity, I don't know if you can see those smaller bars, the model does even worse for you than if you belong to like an aggregated group where you might have more predictive power. What's going on here? Why is this so bad? Well, it's bad in some ways because of all of the parts of this pipeline. There's so many choices that you can make that can lead to non-robustness. Robustness is a big area in machine learning in general. It's the one that I focus on. I'm going to walk you through some examples of how we can make this better and what the limitations are. First, about data. Data is arguably one of the most important parts of machine learning. Hopefully, right, you all agree with me on that. But there's actually some problems with the data that we use. I'm going to focus on health, but everything I say is true in other areas. If you don't believe me, talk to me later. TLDR, you may not know this, but it's really well known in my community now that you can take a medical note and you can remove all of the mentions of somebody's biological sex at birth or self-reported race. And machine learning algorithms can perfectly predict your demographics. And doctors can't. We tested doctors. The Boston area doctors hate me. Like I test them so much. They're great. They're like a fun bunch. But now I'm worried if I get sick, I might die. And not because of the sickness. And then even worse, in my opinion, if you take a chest x-ray, and there's no radiologist. Every radiologist we tested could not look at a chest x-ray and determine somebody's self-reported race. But machine learning models can almost perfectly, even when you bandfast filter it so it looks like visual noise. Okay, so these are superhuman capacities. They're not things that humans can do. And machine learning models can do them really well. And you might be thinking, as one reviewer said, not that I'm bitter, so what? So what if machine learning models can do this? This reviewer also said, oh, is this finally evidence that there are differences, real differences between the races, like a eugenicist? So maybe we can dismiss his comment, but despite that, I wrote a revenge paper that came out this summer. It was very fun to write. I suggest you all do it. Write your revenge papers. And in this, what we did is we said, let's reprove first that demographic attributes are encoded in medical data. Okay, so we did that. And then after we proved that demographic data is encoded when you learn on radiology data, ophthalmology data, and dermatology data, even when you're training it to predict a clinical outcome, we showed that the greater the encoding of such demographics, the worse the model does in terms of performance disparities. What that means is the more you learn to predict who is male and who is female when you're looking at chest x-rays, the worse you do at predicting pneumonia in female patients. Take that, reviewer two. So, can we fix this? Well, yes, actually there's a lot of really good algorithmic optimization protocols now that you can use. We tested a bunch of them here. Has anybody seen a Pareto plot? I hate them, but economists love them, so I see you guys out there. You must have been the reviewer on this. We made them. They're in the paper. I've come around to understanding that they are efficient ways to communicating information. What this is showing is that using modern machine learning optimization techniques like group distributionally robust optimization, on the x-axis, you can maintain overall performance, so it's really high. And on the y-axis, you can bring the bias all the way down. So you can pick a model that works really well for everyone and doesn't have big biases for one small subgroup. That's great. But this is the graph you get when you train on data from Massachusetts and test on data, unseen data from Massachusetts. Is that what models do when they're approved by the FDA? Is there a secret cabal of machine learning scientists who live in every hospital in the world and they're retraining all these models to work on their local populations? The answer is no. Hopefully nobody thought the answer was yes. There's no secret group chat. There's just a Slack channel. And so what really happens is we take data from Massachusetts, we train a model, and then we evaluate it in California. And when we do that, you can see that these perfectly fair optimal models actually shift. And in our analysis, which you can read in the paper, but it's a long paper, I don't suggest it, our analysis, which you can read in the paper, finds that you actually have even odds of creating a model that is much worse, much less fair, even if it was an optimal model in the training distribution that you evaluated in. Okay? So this is problematic because this is how we develop machine learning models right now. This is how the FDA evaluates them. We assume that if they work in one population, they'll work in other populations. But that's not actually true. And so we've been working on algorithms that can try to de-bias models in the settings in which we actually try to evaluate them, which is more in the wild at test time. So first, you might be wondering, how does this even happen? How do we have these machine learning models that are biased against specific subgroups, but they work for the majority? This is not a machine learning problem. This has been true for decades. Did I hear that there's a bunch of doctors in the room? Are there doctors in the room? Raise your hands. I want to see you. Oh, there are doctors in the room. All right, so you can vouch for me here. It has been decades. We have known for a very long time that if you use group attributes like sex, age, and race in a clinical risk score that is just logistic regression or a decision tree, you can get worse performance for a small subgroup, even though you get better performance on average. This has nothing to do with fancy machine learning, deep learning, none of that. What's happening is, let's say I train a simple logistic regression model and I want to predict sleep apnea. If I include sex and age, you can see it's worse for younger male and older female patients, even though it's better on average. And this is happening because of one of two things or both of these things, depending on how sad your life is. Either model misspecification, this is where your model cannot capture the necessary interaction effects between a feature and an attribute, okay? It happens. Or model selection. If you use the vanilla empirical risk minimization, that is the way that all models are trained by default, you told it to do best on average. You didn't say do best on average while not destroying performance in any specific subgroup. And so the way that we do model selection and specifically hyperparameter tuning matters a lot. But what happens when we scale from simple logistic regression to vision language models? Hopefully all of you have played with a vision language model at some point. If not, you should know that they are really flexible models that map words to images, and they can do many things, amongst them image generation, zero-shot classification, and zero-shot retrieval. But in all of these cases, lots of wonderful papers have proven that these vision language models retain human biases. Okay? And all of the methods that we have to debias these models do pretty poorly. And the reason, one of the reasons that they do really poorly is we're assuming linearity. Okay, what does that mean? Imagine the model's mental conception in very high dimensional space of all of these different pictures of doctors, for example. The way that we do debiasing now is we assume there is a vector direction in n-dimensional space for male, there's a vector direction in n-dimensional space for female. All you have to do is draw a line between them and collapse them out, and then you're fair. You've removed the bias, right? But in reality, these models have really complex nonlinear embedding spaces, and so the direction you would collapse out to normalize for male or female doctor is different than the one you would do for male or female pilot or manager. So what do you do here? Well, we actually have a new approach that I'm very happy about. My postdoc is going to present this at NeurIPS next week because I refuse to fly to Vancouver. Like, it's too far, but you all should go. It's a nice conference. It's too far. It's like a long flight. I get to pretend I care about carbon credits, you know. So let's say that I don't even know what carbon credits are. I just know that flying kills the planet. And even though I'm a fake vegetarian, I need to not kill the planet. So let's say that I want to generate a new picture of a doctor, and I want it to be debiased. This is what the model looks like, and I queried doctor, and it lands right there where the star is, okay? The way that a traditional model debiasing approach would do this is, as I said, they'd estimate the linear orthogonal projection between these two spaces, and then they would move this star this one step. So now it lies perfectly on the line, right, between the male and female spaces. But as I've told you, the problem here is that even though you've done this, you're still closer to the picture of male doctors than female doctors. And this happens repeatedly in many different ways. This is just one example of a complex nonlinear space where it might happen, okay? And so what we ask people to do instead is something we call bend VLM, which is bias elimination with nonlinear debiasing. So you start here. You can do this one step so that you lie on this curvy space that separates male and female classification, and you take an extra optimized step. And there's an analytical solution to this, which for the machine learning people in the crowd is a godsend, that ensures that you are equidistant from male and female samples. And so this is a nice approach because Bend VLM requires no fine tuning of the vision language model. You can take a biased vision language model that somebody else made, and you can do the debiasing operation for each query, and you can do it at test time for new queries that are unseen. So I think this approach is one thing that we're really excited about. It does really well both in classification performance and on retrieval tasks. But there's another thing that we're excited about discovering and unsure how to fix. So maybe you could understand why a vision language model would be super biased because humans are super biased. What about negation? You guys know the difference between a dog and not a dog, but it turns out vision language models don't. There are all these funny memes that you can see on social media where you'll ask a model to generate a table filled with food, but there aren't chairs. And there are a lot of chairs in that image. And this has happened repeatedly, even in state-of-the-art vision language models. They're really bad at understanding negation, not just in image generation, also in retrieval and in visual question answering. And so we wrote a paper to try to understand how bad this is because we had some clinical collaborators say we'd really like to use vision language models in healthcare. And in healthcare, it's really bad because if you say, I want evidence of lung opacity and you pass it through, you want this picture. But if you say, I want evidence of lung opacity with no sign of edema, maybe you don't want this picture. And so part of the problem is that the existing benchmarks for vision language model negation are really bad. They're really bad. They're these like templated Yoda-style sentences that are not the way that people use negation in real language, okay? And so the first thing we did was make a benchmark of real negation examples, and we found that state-of-the-art vision language models specifically trained to handle negation fail. And they fail in these natural images, and they fail really hard in medical images. And so this is an ongoing area that requires more research. But does anybody know why? This is a funny thing. Maybe you've seen T-SNEs, which are these visual projections of a model's mind space, right? Their embedding space. And here we're looking at two, clip and neg clip. Clip is not trained specifically to handle negation, but neg clip is. And here I have a bunch of colors, and the color is a concept like cat, dog, house, airplane. And the shape is whether it was an affirmation, it is a cat, or a triangle, it's not a cat. And you might say, they look like they're really close together. Where are the triangles and where are the circles? And it's because they are really close together. In both of these models, the colors are in the same place. The circles and the triangles are embedded to exactly the same place. A cat looks a lot like not a cat. And perhaps even worse, if you look at a fancy model trained contrastively, you see that cat, dog, house are all on the right-hand side. Look at that red circle. Do you know what that is? That is the not of everything. That's not a cat, not a dog, not a house, not a bicycle. And so one of the things that we have learned auditing these models to try to make sure they're safe enough to deploy in a medical setting is we don't know what they don't know. And they're very good at things that they've been trained to be good at, but that means they have some pretty gaping holes because we don't evaluate them on things we don't know they will be bad at until we're actually doing it in practice. The last thing I'd like to talk about is how we deploy models. Okay, so maybe at this point you're thinking we should never deploy a model. These models are really weird. Not necessarily. Let's assume that you agree with me, right? Hopefully you agree with me at this point, that we can train a model to predict almost anything, but that model will probably be biased. Has anybody here ever volunteered for a crisis line? I did in college. You get a transcript. In this one, I have demographics, and they're highlighted, but in the example where we had a bunch of people do this exercise, the demographics were not highlighted. And we asked people, oh no, the text is white now. Well, I will tell you, what this would say is we asked people to make a simple decision, call for medical help or call for police help. And the training that we gave people is you should only call for police help if and only if there's a risk of violence. And so we wanted at baseline to see how people would do without any AI advice. So, you know, just looking at the example and then making this decision. And then in the treatment group, we gave people advice from one of two models. Either a really racist model that we had fine-tuned to be racist against African American and Muslims. It's easy to do, but obviously I don't advise doing it. And then from an unbiased, not evil model. Okay, so treatment number one for everybody in this experiment group who are not the controls is, did you get advice from a good or bad model? Treatment number two is, how exactly did I give you that advice? Did I tell you that our AI system has flagged this call for risk of violence? Or did I say you should call for police help? And these are the same thing. Because I told you in the training that you should call for police if there's a risk of violence. And if there's a risk of violence, you should call the police. These two things are exactly equivalent. But one is sort of descriptive, and one is prescriptive. It tells you what to do. So which of these is going to make a difference in this ultimate decision that people are making? So first of all, you guys have to vote now. Sorry, democracy again. For controls, do people think they will be biased or unbiased? Without any AI device, who thinks people will be biased? That's sad. All right. Cool, cool, cool. All right. Now, treatment. Who thinks that the options are that the bias level of the model will matter most? Option two is that the way I phrase the advice will matter most. Who thinks the bias level of the model will matter most? Who thinks the way the advice is delivered will matter most? You know you're invalidating my life's work, right? Right? Just letting you know, okay? Like, look at me, I'm so sad. All right, I have some good news for you. At baseline, you're wrong. Clinicians and non-clinicians are both not biased. They're not more likely to call the police on Black and Muslim people. However, when you give them biased prescriptive advice, when you tell them to call the police on minorities, they do. When you tell them that there's a risk of violence for all minorities, they don't. And so here we have exactly the same evil model. And what's protective is not some weird debiasing thing I did with a latent space. It's just the way I delivered this advice to the clinicians and non-clinicians, which again invalidates my life work. But another thing to keep in mind is I'm not the first person to discover something like this. So there was a paper in 2020 that found that the losses, this is not the point of this paper, this is hidden in figure 2 subfigure J, by the way. But they found the losses from poor AI were larger than the gains of good AI in human-computer collaboration for skin cancer recognition. Another paper we wrote found that doctors are really susceptible to incorrect advice, even when they have expertise, even when they're radiologists who have decades of experience, and you give them the wrong advice and you say it's from an AI, they're still susceptible. And finally, what we found, biased advice delivery mattered more to clinical action than the actual content of the advice. And so I'll end on a positive note, because my talk is always the downer you bring in at the end of a session, which is, does it have to be this way? It doesn't have to be this way. There are people who are doing really fantastic work in machine learning for health. For example, creating more robust breast cancer screening programs. But Regina Barcelay did that by getting hard drives of data from multiple countries around the world to force the model to be robust. Or AlphaFold. AlphaFold was a secret program that many people at different companies collaborated on in order to ensure that a machine learning model could do something that humans cannot. And so if we want to move forward with ethical AI in health, we need to think transformative and focus on considering sources of bias in the data, evaluating models comprehensively, and recognizing that not all gaps can be corrected, but that's maybe okay because we want to create actionable insights in human health. Thank you.
Thank you so much. Wow, there's also a beautiful sunset in the background that I'm just now noticing. But before we get too distracted, we have time for one question for Marzia, and then can the panelists for the for the next panel, our final panel, get up to get mic'd up while we have the last question, while people take photos? That's my fault. Anyway, yeah, maybe one question for Marzia. Yes. Oh, Leroy, you have a question? Sure. Okay. And then can the panelists come up, please?
So,
and the moderator.
awesome talk.
Thank you.
Phenomenal delivery. My question is about deployment process-wise, not just model-wise, right? Because technology interacts with process when out in the wild. And I'm curious whether through your work in developing technology that is robust to its implementation and like how we think about where it will be implemented, so how do we improve that technology, whether you have insights on the process by which we implement said technology that would either work best or like flaws in that, in the way we think about its implementation now.
I think you have to look at why the technology is being implemented. Why do we have GPT-4 in every hospital in the Boston area writing your medical notes and responding to your queries instead of doctors? It's because it's not regulated. It actually fits into this convenient regulatory loophole because it's an administrative use of AI in a healthcare setting. And CTOs and CEOs and COOs love it because it's an efficiency measure. Does it hallucinate, create biased text, and lead to discriminatory behavior against women and minorities? Yes, it does. But that would be very hard to prove without, rampant record requests. And so was that a good example of technology being deployed? I hope nobody here, is from these hospitals, but if you are, call me. It's bad. Nobody expected this to work well for patients. It wasn't meant to work well for patients. Epic is a billing software. It wasn't meant to work well for patients. It was meant to make billing more efficient. And so I think if we want technology to work well for improving healthcare outcomes, it needs to be designed by, or at least requested by, people who are suffering from or stand to benefit as a result of its implementation or lack thereof.
Thank you so much again. And now for a very exciting panel, and unfortunately our last panel. I'll let Clara introduce the panel, but yes, hope you enjoy.
Okay, last talk of the 3-day conference. Thanks so much to everyone for sticking around. And thank you, Rory, for bringing us together. This was a lot of fun and very informative. We'll be chatting about healthcare and AI and what is kind of overlooked in that space right now. And hopefully afterwards we can continue the conversation with questions and more informal chats as well. So Gregory, you're a trained neuroscientist and now work at Flagship.
on AI in particular and implementation in like company platforms. Salim, you're a surgeon, but also very involved in innovation, in healthcare innovation, and an entrepreneur. You founded Reveal Health Tech, where you're also Chief Medical Officer. Anna-Marie, you're an investor. You were SVP and Head of AI at Ginkgo Bioworks, and now work as an advisor. Alex, you're a mathematician, a radiologist, filmmaker as well. But you mostly founded Cost Plus Drugs, Mark Cuban Cost Plus Drugs, where you work on delivering affordable medicine to Americans. And Thierry, you're an environmental scientist at Harvard at the School of Public Health, and also an entrepreneur, and founded an AI platform to assess the impact of AI. So maybe, Salim, we can start by just like chatting about how do you think, what is the role of AI in maybe redesigning the structure of healthcare delivery?
Sure. You know, as a surgeon, I really understand risk and the consequences of the work we do. And there's so much suffering and so much harm that occurs in our current health system, both in the US and globally. And I think it's really important, like, why we're doing this is because there's people who are dying constantly and having complications. And AI, as we've talked here, is a full range of applications. And I think Dennis mentioned, is it adding value? Is it a product? It's about how do we implement it incrementally to rethink kind of the experience and the outcomes that matter, right? Like, if I step really far back, and today, unfortunately, the burden falls on patients and families around coordination, communication, and if we start to think about the patient themselves and the families that are supporting them, and think about how can we use AI algorithms and tools to serve them, it's going to change new service lines, we'll reshape the entire infrastructure around it. So I'll just leave it there, but I think it's a reorientation regarding this one-off application to a series of integration of different tools with people to serve people.
And yeah, I noticed also in the audience a lot of Oura Rings, Whoop devices, and people have started using AI chatbox tools to self-diagnose or maybe get more information on healthcare. And like, maybe Gregory, can you talk about this a little bit and how you think it will just impact that industry?
Sure, yeah. I think, well, I'm very guilty of the Oura Ring phenomenon and the kind of general quantified self-movement. At Flagship, I have the great opportunity to co-lead a startup that's focused on AI and mental health. And we've been talking to a lot of people, including clinicians, about how they think about this. And as you said, a lot of people have started using AI tools for all sorts of advice and help on medical things, including on mental health. Some people, talk directly to ChatGPT about their problems. One thing that I think is a little bit overlooked is this possibility that where this leads is that people take their healthcare into their own hands. Where in the future, instead of me trying to call my doctor to ask, what's wrong with me, I'll go straight to ChatGPT or maybe a bespoke product to actually, get the advice and maybe even kind of some sort of treatment. This, I think, I haven't heard too much of this as a possibility, and what the effects might be on the kind of standard and established healthcare system.
Yeah, it looks like we need to really think critically about how this technology will reshape not just individual processes, but also the ecosystem as a whole to make it a bit more efficient. But also keeping in mind that it's an industry where there's a lot of different stakeholders that have incentives that often collide.
So, and then maybe you could like say, what do you think is overlooked in that space, and where should we maybe focus?
Sure. I think there's a lot in that question. And maybe to provide a little bit of context on why I think you're asking me that question, I've spent a lot of time recently working across government, philanthropy, the private sector, on how do we actually create the ecosystem that allows us to take advantage of these technologies more quickly, because I was getting really frustrated at how slowly things were moving. And just catching the last couple talks, I suspect that a recurring theme of today, if not just the last couple talks, was that it's less a technology problem sometimes and it's more an implementation problem. I come from the biological side, less the healthcare side, but I think the challenges are very similar, where this industry, maybe because of regulation, maybe because it is so darn technically difficult, has resisted a lot of the infrastructure, if you will, that basically any other modern industry has progressed to. All other industries, manufacturing, technology, anything, you have specialists who build technology and are really good at that, and you have systems integrators who bring it all together. In these fields, we force everybody to do every single piece of the value chain, from picking a target to designing a clinical trial, and oftentimes to then like commercializing that technology. And that's nuts. And so what we observe over and over and over again is when things fail, they don't fail because the lab at MIT that invented something that wasn't good. It fails because they picked the wrong disease to go after. Or it fails because they didn't stratify the population in their clinical trial the right way, blah, blah, blah. And there's somebody else out there in the world who's already solved that problem. In fact, there are probably hundreds of people out there in the world who have solved each of those problems, but we as an industry have not figured out how to bring those solutions together in an integrated fashion, unlike any other modern industry. And so one of the things I've been most focused on and that I'm actually most excited about with AI is not the sexy, like, we're going to design proteins from scratch. It's not hypothesis generation. It's around all of the really boring implementation stuff that we are just not good at. I'm sure a lot of you have tried to replicate methods in papers sections, and the experiment didn't work perfectly the first time. Like, why is that? It's because something was missing in the method. Like, we're not perfect at recapitulating this, and we're not perfect at trying to recreate it ourselves as scientists. AI can help provide some of that translation and some of those fill in some of the gaps for us. So all those boring steps aren't the reason we're failing. The reason we're failing, hopefully, is because we're pushing the boundaries on science, not because we're not following the recipe the right way or we're not talking to each other the right way.
And Alex, maybe that's something you can talk about a little bit, because you've also shown with Cost Plus that you don't really need advanced technology to disrupt an industry and to reimagine how care is delivered, right? But you're also now using AI to make some processes more efficient inside your company. So, yeah.
Yeah, absolutely. So I actually spent a fair bit of time in Boston. I did my surgical internship at Brigham and Women's Hospital before I went into radiology. And at the time, this is 2010, so old, but not that old, but the electronic medical record system there, BICS. Did anyone ever use BICS in the crowd? All right, you remember BICS.
Very fast.
It was very fast, high learning
DOS
curve,
based,
but very fast, but it also ran on Microsoft DOS. Yeah. When do you think they got rid of BICS? 2015. So the entire Brigham and Women's all patient health was being run on DOS until 2015. Yeah, so to that point of healthcare being resistant to new technologies, because the risk of something going wrong is just so high that if something is working, like, why would you risk it? Like BICS, and say what you will about Epic. Actually, I will say what I will about Epic. Like, geez. Like, actually, is the new thing actually worse than the old thing? Like, BICS was super fast. Epic is really slow and clunky. And it's based on Visual Basic, so like. But yeah, at Cost Plus Drugs, we're really deep in that ecosystem of doing things sort of the dumb and boring way. I refer to us as sort of the dollar store of pharmacy. So we're building what I like to refer to as a parallel supply chain for the pharmaceutical industry based on fundamental principles of transparency and honest dealing. So forgive me, I'm going to ramble for a while, but there are these entities called pharmacy benefit managers. Has anyone heard of them? Yeah, they're basically payment processors for pharmaceuticals. No one's ever heard of them, but they're effectively a cartel that buys all the drugs in the United States, marks up the price as much as they like, and then resells them. So we have a product on our platform, our direct-to-consumer marketplace called Imatinib, which has a list price of $10,000 for a month's supply. The PBMs will say, hey, we got you a great deal. We got you a 90% discount. Oh no, they're coming after me. We got you a 90% discount on this drug. It's only $1,000 for a month's supply. Meanwhile, we sell it for $30 for that same month's supply. So there is basically, the problem is a very simple one. There's a cartel, there's a monopoly that does this payment processing step and can arbitrarily mark up the price of drugs. Insulin famously has a $400 a month list price. The pharmaceuticals companies actually only charge $20 a month behind the scenes. But they're all afraid of crossing the big PBMs, CVS Caremark, Optum, Express Scripts. So what we did, we just revealed all the prices of all the drugs. Very simple, very straightforward, no AI required. And yeah, we've tried to take on the entire supply chain, because if there's any middleman that blocks us on that supply chain, we might not be able to reach the patient. So we are a pharmaceutical manufacturer. We just had our factory approved by the FDA a few months ago to start making our own drugs. We're a pharmaceutical wholesaler. We're a pharmacy, and we're an employee benefits offering. And that is a lot. I've heard it said that when starting a business, it's a good idea to do it one thing and do it really well. We just don't have that good fortune. We have to own it all. So that's really where AI comes in for us as something helpful, as we can automate a lot of the processes that otherwise require a lot of physical manpower and labor. I remember I was at Rory's conference in San Francisco earlier this year, and in the spring, and there was a panel that was really making fun of this company that made, I think it was like a virtual assistant for dentists. And you know, that's not cool, that's not sexy, that's not like protein structure prediction. But I was like, that's a really good product. Dentists could use a virtual assistant. So we're kind of trying to build with that idea of streamlining operations, allowing us to punch above our weight, go against these huge Goliath companies with hundreds of thousands of employees, and really be able to compete with them effectively, be that process development, quality assurance at our factory, AI customer service, really trying to implement artificial intelligence in sometimes boring ways. Like, I think there's some room for us to do some cool stuff. Like, I think in the factory, maybe like probabilistic programming languages or something might have a role. But for the most part, using boring, conventional, like going after boring, conventional problems that otherwise take a lot of sweat equity, that cost a lot of money and manpower, so that suddenly you can compete against these entrenched behemoths that otherwise control the supply chain.
Maybe you can tell us a little bit about how you can measure the impact of AI in healthcare delivery, because that's also an issue right now, is like evaluate the efficiency of these technologies.
Sure, I feel like an kind of an outlier here because I'm not a medical doctor or healthcare professional. So, but I think when we talk about AI implementation in healthcare, one of the big questions come to our mind is, does it deliver what it intends or promises to deliver, or does it work for a certain group of population or some people, or does it favor some group over another? So that's impact measurement. So that impact measurement is all about making sure that the actions and projects that we are delivering are actually working. You know, it answers questions like, for healthcare sector, or health intervention and AI implementation in healthcare, we are trying to answer whether it works or whether it improves outcomes or it kind of reduces the diagnosis time for patients, or it saves costs and time for healthcare sector, or it improves healthcare accessibility for underserved populations. Those are the kind of questions that we are trying to answer. So another area that we specialize in is health impact assessment, or HIA. That's where we predict the impacts of development projects on population's health before it is implemented. So traditionally, it has been done with a mix of research, randomized control trials, or expert opinions, sometimes with stakeholders' input. But AI can kind of supercharge the whole process of it or automate much of it. In our case, kind of we automate the whole process of impact measurement, starting from developing and identifying measurement metrics that projects and context specific, and also automate data collection, analysis, and find patterns and trends that might miss using manual processes or overlooked by healthcare professionals. So that's where AI comes in for us. It's about leveraging AI for improving outcomes and decision makings. I think the area that often been overlooked but extremely important right now, for especially in healthcare. So it's also about making sure that we don't only improve outcomes, also is about not making sure no one is left behind. So that we can actually flag if AI implementation in healthcare, let's say one tool isn't working for some certain group of people, we can flag that and we can say this is not working and kind of recommend strategies for mitigation and improvement. That's where our role as Nixie and our platform comes in. So healthcare is not only not the only sector that we looked at. We look at social impact, environmental impacts, and also health impacts for programs, initiative projects, and development projects, including health implementation. So I'm really excited to learn and work with health sector to how to train our model, particularly for healthcare implementation. Since AI implementation in healthcare is extremely new, we're still improving our data every single day, but we definitely have limited data in that sector. So it will be exciting to work with healthcare professionals in the field who are using AI for many different purposes to improve people's life, so that we can actually see and actually to determine if it's not just a fancy technology that is innovative, it's actually make differences for people's life and healthcare system as a whole, because healthcare is a sector that needs a lot of improvements, needs a lot of adjustment for people so that we can lead a better life, better sustainable life. And AI actually is really an exciting technology for this sector, but we need to make sure it's working for everyone equally.
Do you mind if I hop in really quickly on the topic of evaluation? Because it's both, I think, a really exciting area and a bit of a pet peeve of mine. One of the things that I observe is that we have these sort of two camps. You have people who care about eval because they want to prove that their model is state of the art and is doing what they want it to do. And you have another group of people who are focused on eval because they're worried about safety or bias or something else. And this group of people is viewed by the industry as like, we're trying to slow you down, guys. You can't release your product because it's biased. You can't release your product because it might make a mistake. You can't release your product because. And the reality is they should be asking and answering the same question. It's like, what the hell does this model do? And can it do the things that I want it to do? And can I stop it from doing stupid stuff? And right now, they're fighting with each other instead of working with each other. And as a result, you have like terrible design of some of these evaluations as well, where like this group is only looking at models that are already got 10 layers of protections on it, and so they're not actually evaluating the real capability of the model. They're not actually being able to really get under the weeds on like what could the changes be. And so like if we can come together a little bit more on this topic of evaluation and start a little earlier in the process, I think it would be very, very, very helpful, because candidly our eval systems right now are broken.
It's funny because in the sort of frontier LLM world, this is also happening too, where people are really excited to show off all the cool things that ChatGPT or Claude can do, but there is not this culture of like writing a paper that says, actually here's where it fails. So this is just like not in the sort of repertoire of how people are talking about these things. They're treating it more as like a new toy that can do whatever without actually testing it. So that actually needs to change, right? If we're going to deploy these things in healthcare settings and things like that.
And one main takeaway from these past few days as well is that the AI is as good as the data is. And in the healthcare industry in particular, healthcare providers are realizing how valuable their data is, but it's very siloed. It's not harmonized. And so I guess one question is, are we fixating on data privacy, maybe at the expense of building better technology? What do you think?
Look, from a technology standpoint, all of this stuff is solvable. It's the people that's the biggest challenge, right? Hospitals, health systems have an immune system against any change. And that's the reality. And there's no accountability and urgency tied to it. When you walk into a hospital and there's 200 people, this is my work in Zambia, and you know 100 people are going to die in the next 24 hours. And you're looking at the mother, you're looking at the father and the child. There's a sense of urgency. We often spend so much time saying no to everything and don't have a system of evaluating and balancing risk and benefit. And we just take a dichotomous view about everything. And there's so when someone has a rare condition, it takes 10 years to get a diagnosis. And there's all these failed attempts, and the patient is bearing that journey. That is unfair, right? And so it's super frustrating to those in the front line, doctors and nurses, who see these patients who are going through the system, bouncing around, those that can't give up, who have outcomes that really shouldn't be. And so I think the change management, the building of unity of vision that leads to thinking that's aligned, that leads to action aligned, that's a fundamental culture change that has to happen. And it doesn't happen in organizations where you have separate P&Ls, in academia where you have a certain track and you're competing, right? We have to be really moving together towards the why of what we want to do regarding care. And that's part of it's information asymmetry, right? When it comes to PBMs and even today, last week I went to CVS to pick up a med, and they're it's a $150 copay. I'm like, okay, fine. They're like, wait, what's a good RX price? And
cost plus drugs price.
No. So I was there, right? So there's a situation, right? I'm like, what's a good RX price? Because I needed the med because I was traveling. And on my phone, I'm looking up cost plus. It was $120 for good RX, and it was $80. But I couldn't get it that moment, right? So she's like, do you want, and it was this big process for them to rerun it and everything. I'm like, this is ridiculous. I need this medication. Why isn't there an agent that looks at all three areas and shows what the best one is? Why is it I have to do this work and extra work?
Yeah, to your point, it's they're actually the pharmacists actually have to sign a contract that say they're forbidden from doing that on your behalf. So it's not even an information asymmetry issue. It's that the structures are built up to act against you.
And it's consistent with healthcare pricing, right? You will never know what things actually cost. When I joined one of these big health systems, I got the entire fee schedule. And I looked at it, I'm like, this doesn't make any sense. And basically for the past 20 years, they were negotiating across the board 3%. So your Tylenol now is $180. But then a facelift is 20% of the market rate in Boston. You're like, what? How does this even make sense? It's because it's easier to go on the Excel sheet and say 3% across the board. And if someone complains, you make a little adjustment. But then it's not transparent. And there was a federal mandate to make it transparent. It's unreadable, right? You could download the file, but you can't read it. So it's about intention and motive and building alignment.
Yeah, and the simple solution or a simple answer to why is it that way is it's a scam, and the simple solution is true. That's what it is. So in classical economic theory, when you have an opaque market, the winners are not the buyers or the sellers. It's the people that broker information in between. And you see all these health systems barely making ends meet, sometimes going under, closing, rural health is collapsing all over the country. Meanwhile, patients are pretty frustrated about not being able to afford their health services. And at the same time, the big national insurance companies are all Fortune 10 companies. And that's not, I don't think that's a coincidence. Basically, by setting fake prices and only having the information brokers know the real prices in between, it allows so much arbitrage to happen. And yeah, perhaps there's a role for artificial intelligence data systems to break through it. But I don't think it's so much the data, it's the intent. The intent is to deceive. Yeah,
It's all
yeah.
culture. This is like the thing that's overlooked and totally unsexy, right? There's no like AI model that you can make that's going to change the culture unless you start putting, I don't know, chips into people's heads and get them.
I don't know that it's culture. It's like it's money. Like it's money. They're incentives, and there are a lot of people who are making a lot of money who are very disincentivized from changing this right now.
But it's a lack of reflection, right? When you have certain values and you're not coherent to that, like we're not asking those questions. Like, hey, does this actually make sense?
But who's we?
The people. So at board levels, right?
Like
so
what
most
board?
boards of hospitals are just fundraising organizations, right? Management doesn't ask questions. Like, I'll give you an example. I was a surgeon at Boston Children's Hospital. We know that if you have mass health, you're 10 times more likely to show up late to your appointment. That's a fact through the data they've identified. The big reason is why they're late is to find parking. And people are looking for a parking space in the Fenway area, right? Because they don't want to pay the money for the parking at the hospital. Even though it's subsidized, there's an information issue. So when patients would come, we would ask every patient, hey, did you have any trouble with parking? If parking is an issue, we'll take care of it. So all of a sudden, our numbers were amazing. Patients would say, oh yeah, I needed help. I parked down in Mission Hill and walked 2 miles and was lost, whatever. We go, next time just park valet, and we'll take care of it. Well, compliance, so we did this great program. The hospital's like, wow, your numbers are amazing. Then all of a sudden, the general counsel was like, oh no, you can't do that. You can't do that. Why? Because you're tempting people to have surgery. It's like, what? So that's the immune system internally, right? It's like that's a federally managed. So the risk of possibly being seen as biased as you're trying to promote surgery by covering the $10 parking space for a $10,000 operation, so that things run more fluid. Like people will say no. So there isn't an actual and I'm like, look, there's a risk crosses the street. Everything has a risk. It's not meant to drive management.
I think.
I have a.
Anna Maria was right. So sorry, but I mean, I think that I still think culture is a huge part of it. But the money thing is, ironically, in this country, what allows us to have both the really fancy AI that's, I think, not super controversial to say, has been really nicely developed here as opposed to Europe or other places. But at the same time, it gives us the top 10 Fortune whatever insurance companies. That's where we live.
So I would be. So first, I want to tell a story that goes along with your aversion to risk thing. So the first startup I ever created in grad school with Professor Nicolau, actually, was called Altitude Medical. We made a door handle that cleaned your hands when you use it to stop the spread of nosocomial diseases in hospitals. We made it. We had it manufactured overseas. And we wanted to do a clinical trial to show that it improved outcomes. And we needed to change one door handle in the hospital in order to run this trial. We had a panel of 20 people. I kid you not, I could not make it up. The hospital locksmith, the building engineer, the hospital architect, because the head of nursing, everyone was on this panel. And we had this whole tour to go to the door handle, and everyone, as a group, reached consensus that we could change the door handle. And then I went to the department head, and I was like, look, I've got 20 signatures that say we can change the door handle. And he's like, did you talk to legal? And I was like, that night I went in with a screwdriver and I just changed the door handle. But to your point, it's very easy if you're an administrator to say no. Because the downside, let's say you reject something, there's no downside. Your job is safe. If you approve something and it comes back to bite you, that's your job. So you're always incentivized to say no to any outcome. And to the point that this sort of shifty game is what allows the free markets to operate. Exactly the opposite. So we talked to the pharma companies, and they actually like working with us because we pay more. We're a small startup. We've got outsized brand recognition, but we've got 60 employees. We don't have the negotiating leverage of CVS Caremark. So that $30 price point for imatinib, that's more than CVS Caremark is paying. I would say it's actually a rent on our system and actually delays innovation and delays research and development to have this sort of arbitrage game that happens as a layer on top of our system.
Why do you think that rent is allowed to continue? I'll just, let's maybe give an example of something where maybe one can hope it'll get broken up in a good way and not a terrible way. Trump released Doge. Now, as somebody who advises for the government, hopefully this is somewhat off the record, like there's a lot of fat. Like it's a freaking ridiculous document, but like, yeah, I don't know that a lot of these consulting firms that are making God knows how many billions of dollars adding red tape to the system need to exist.
But by the way, sorry to interrupt you, but Jennifer Palka has an amazing book about this that just like documents this in a, I think, pretty nonpartisan way. But yes, there's a whole lot of fat.
And so there's an example of maybe, now who knows how the hell it's implemented, but like maybe an executive order from top says like, all right, the like government consulting industry is gone and like we're going to have a more efficient government. Could we do that in the healthcare system? Or like what is stopping what is stopping the top 20 pharmas who are getting paid more by you from coming together and say PBMs are stupid? And I know Jake Auchincloss here is lobbying against PBMs and like all coming together and saying this is stupid, that should go away, and like what's stopping it right now?
Yeah, no, great question. So I gave a talk at the Chicago School of Economics, which is very, for those who don't know, very laissez-faire, very the market is the solution to everything. And I also talked at the Cato Institute, very much a similar philosophy of libertarianism, the market will solve the problem. So the feedback I got was, well, certainly the PBMs must serve a function, right? Because if they didn't, they wouldn't exist and be such massive entities. But I think the data environment is so poor in the ability to analyze it. You know, the classic example is when you have a heart attack and you're in the ambulance, like, you don't select what hospital, you're not an informed consumer. And the people who are deciding which PBM to choose at the Fortune 500 companies are HR executives. The HR executive is not trained in medicine, they're not trained in healthcare, so they go to a consultant. The consultant, a PBM consultant, so there's a middleman for the middleman for the middleman. And the consultant gets kickbacks from the PBMs to recommend specific PBMs. So you have this, basically, you don't have an efficient market where people can't evaluate the data that's presented to them in an effective way. So to your point, like, why don't we do this? We're working on it. Like we're going basically Fortune 500 company by Fortune. By we, I mean Mark Cuban. They won't meet with me. But like CEO by CEO and saying, listen, like you need to move your employee benefits. We're meeting with all the pharma companies and saying, hey, I know it's scary. They're saying you'll lose your formulary placement. They're the devil you know. But the world would be better if you just like all, you know, they're worried about, to your point about risk, antitrust implications for like going against these guys. It's just a mess. But I think as people become more informed consumers and they are able to analyze the data and realize they're getting ripped off, I think it'll move to the sort of world that you're describing.
How do you think government entities should be involved in making these processes more efficient? And also, how do you educate them about AI and these new technologies?
Yeah, so actually, as a rule, as a company, so, you know, I have my own personal biases, obviously, which I was not so subtle about a few moments ago. But our view is that actually we don't do any advocacy. We don't advocate for any policy change. And the reason for that is that the bad actors here move so quickly. Like as soon as it's sort of whack-a-mole scams, as soon as one bad practice is discovered. So they were taking spread so at the level of the pharmacy, like what I was just describing. You know, the drug costs X dollars, they make it 2X. And charging that to self-insured employers. Obviously scammy, some states started putting laws against it, the federal government was threatening it. So the PBM said, hey, we're going to proactively stop doing this, we're not going to do it anymore. But then they created effective rate clawbacks, where they take the money back, they add on the money after. And they started their own pharmacies, specialty pharmacies, where they refer prescriptions to. And they started Swiss overseas purchasing organizations, where rebate dollars can flow to. And they started their own pharmaceutical companies in the Cayman Islands, where they can manufacture their own drugs by putting a new label on it before sending it overseas back here and negotiating the price with themselves. So basically, government cannot act quickly enough to, because just explaining any of this stuff to your average congressman is Auchincloss is actually great. He's probably the best in Congress on these issues. But like it's a tough conversation. So really, we feel it has to be a private sector solution. It really has to come from Elon Musk as the owner of X AI, X, big companies saying, hey, we're not going to hire the PBMs anymore. So the private sector, the private market is really what has to drive change here, because otherwise trying to regulate all these bad practices away. And I think that's also a model for AI. It's moving so quickly that any attempt at regulation is either going to have inadvertent consequences or just do it poorly. So I'm not really sure what the balance there is with AI, but surely on these sort of bad practices, PBMs, that's where our biases fall.
It's funny because it's kind of like, it sounds good, and if people have the best intentions and considerations for humanity, it might work. But there's no guarantee, right? With AI, there's been some attempts at regulation recently, and it was very clunky and well-intentioned, but just bizarre, right? It's clear that people, it was just really poorly understood what AI is. But at the same time, now you have all these AI companies that have their own sort of safety teams and maybe some ethicists also. You can argue that they have like a really particular way about thinking about these things. But it's up to them to do it. So if they didn't want to, they could just do whatever, right? And like Elon Musk has his own AI company and LLM, and that one's gonna give you alternative facts potentially. So who knows?
So I think that in the near term, there's going to be an explosion of services that will accompany the AI kind of implementation. So from an evaluation standpoint, and so in your context, both validating, say, AI toolkits, but also monitoring, right? Hospitals can't do this, health systems. So there'll be a slew of different services that come along that will enable that, right? Independently of the product, right? So one of the things I think is a big opportunity is from a chief compliance officer, building them a dashboard to take what their criteria are and to implement across anything that's generative. Doesn't matter what product it is, and creating a governor system right across that. So there's a whole slew of different opportunities that exist.
That's great. Yeah, that creates more, a bigger market for people to innovate. Right.
Yeah. Certainly there has to be a balance at some point. Allowing industries to self-regulate historically has not gone well. I think it's up to people much smarter than me to figure out where that balance lies. And something as complicated as artificial intelligence, like the frontier labs, the new generation of frontier labs, like how, again, Brigham and Women's Hospital, Harvard Medical School was on DOS. Like, how do you, and I guarantee you the legal profession is actually further behind the medical profession in terms of technological implementation. And policymakers are even further behind that. So, how do you get them to, how do you educate them?
For DOS, DOS can't run your LLMs and all that stuff, but like in many ways, if it wasn't broke, then why fix it, right? But there is probably the culture that needed the fixing of like, how do you sort of get rid of all these restrictions, right? Like, how do you just change the doorknob?
Yeah.
Like, it's fine, just do it.
Yeah, how do you fix the culture of Washington? That's a tough question.
Yeah. Well, but it permeates, right? It permeates into healthcare systems. And like Clara said, what if we have too many restrictions and rules on private data, for example? I don't know. It would, I'm working on a mental health company. It would be very, very bad and irresponsible if that kind of data leaked out or was compromised in some ways. But at the same time, there are really strict rules if you want to do like a high trust or HIPAA. Like these are really intense, and it makes you go a lot slower if you go that route, and when you're building this.
Maybe you can take some questions from the audience. Do we have time? One question.
The museum staff have to go home by.
Okay, so big responsibility for whoever.
So Nico.
I'll bite the bullet. My question is, and correct me if anything I say is wrong, if there is such widespread discontent within what seems to be the greater medical community in general, which I was wondering what really gets in the way of like connection between different sectors of the medical field for pushback against this like block against innovation internally? Because it seems, at least to me, that there's no one saying like entirely happy with the medical system. It seems like everyone has a problem with it, but there seems I guess my question is, why do I feel or like see like a lack of organization?
I maybe take a quick stab at it in a slightly more general or philosophical way. I think there is an inverse correlation between resource constraint and ability to execute. And what you find with government, and I think the healthcare system is candidly very similar to that, those are organizations that cannot fail. They cannot be allowed to fail systemically. And so they never feel the fear of failure in the same way that like a brand new little startup that has to move fast or else they're not going to raise money and they're all going to be out of a job in 6 months, feels the fear of failure and is forced, therefore, to ship product every week and execute. When we don't have the feeling of like, if I don't figure this out, like this is not going to work tomorrow, we don't execute, we don't feel the need. And I think that's as true in healthcare as it is in Washington.
And even worse, I think, if you say, oh, I'm going to change this, or someone comes to you, let's change the doorknob, you could be in a lot of trouble if that doorknob is bad.
That was a great doorknob.
I think the same thing, by the way, is true in profitable companies. So even companies that maybe once had that, and then now they don't feel the urgency anymore, even if they could fail.
But I want to say something on a positive note. Over the past 20 years, there's been a massive shift internally. So there is a rising group of individuals who become leaders, who are wanting to kind of change the system. It just takes time, right? It takes decades of work. But there is that alignment of vision, and people are coming about, and we just have to create the conditions that allows for those groups to act.
And accountability. I think one of those conditions is accountability.
Yeah.
Thank you very much.
So thank you, Clara, for doing such a fantastic job. Thank you, panelists. Thank you to all of you for making it through to the end of the third day. If you're interested in learning more about thinking or helping us with these events in the future, send me an email. If you want to just learn about the events as they're announced, follow me on LinkedIn or Twitter or something like that. But thank you very much. We're going to go to Lily Peas now, which is a fried chicken and oyster place very nearby. Good vibe. Just to relax, enjoy a bit, talk together. So we hope you all come there with us. Thank you very much, everyone.
And I just say a big thank you to Rory for putting this all on. And yeah, thank you very much, Rory.